So, good morning to all of you. Thank you all for joining us today at the 17th Greener Shipping Summit, organized by Newsfront Naftyliaki under the auspices of Martekma, Greece's most powerful technical body. I would also like to thank our sponsors. Without their support, this event would not be possible to happen. Today, we have a very tight schedule, and I won't take time from our distinguished speakers and panelists, as they have much more interesting things to tell you than I do. Before I pass the floor to our conference chairman, George Kyriazis, I would like to tell you that the next Greener Shipping Summit, New Technologies and Education, is going to take place April 1st, Fool's Day, and here again at the Evgenidio Foundation. And the November event is going to take place the 11th of November, here again. So, George, the floor is yours.
Good morning, and thank you all for coming for this Greener Shipping Summit. Let me introduce our keynote speaker. Is Mr. John Xilas, is the President and CEO of Ariston Navigation. Mr. Xilas has an economics degree from the University of Pennsylvania and 38 years of experience in shipping. Mr. Xilas was recently elected Chairman of Intercargo for the period 2025-2026 and is the Treasurer of Union of Greek Shipowners since 2015. Mr. Xilas, the floor is yours.
Καλημέρα σας. Ladies and gentlemen, distinguished colleagues, it is a privilege to address the Greener Shipping Summit today. I would like to extend my gratitude to the organizers for this important initiative, and especially to my good friend, conference chairman, and Athens College classmate, George Kyriazis. A special thanks also goes to Martekma for their role in orchestrating this summit and fostering technical knowledge exchange within a sector. As an economist by education, not a marine engineer, I hope to offer you my perspective on the dimensions of our industry's transformation. While I may not delve deeply into the technicalities, I will be contributing my insights into how we can navigate this evolving landscape together. We tend to think ourselves as professionals in the maritime sector, but our key role is our contribution to a vital global industry that powers trade, prosperity, and connectivity. Today, we will discuss the current state of our industry and, more importantly, envision a sustainable and resilient future. This will require more than compliance with evolving regulations. It will require collaboration across the entire maritime value chain to seize the opportunities for innovation and excellence. One of the most pressing challenges we face is the evolving regulatory landscape. The maritime sector is undergoing a significant transformation driven by ambitious decarbonization goals set by the IMO and the European Union. While those goals are crucial, they present operational challenges, especially when it comes to regional measures like the FuelEU Maritime and the EU ETS regulations, which are not fully suited to the global nature of our industry. Such measures risk undermining the competitiveness of EU shipping. The industry is welcoming the new EU Commissioner's recent pledge to increase green marine fuel production in Europe. The future take-up of fuels, however, by customers will depend on IMO agreeing next year a pricing scheme that levels the cost of green fuels and conventional marine oils. It is essential that we advocate for a balanced regulatory approach, one that aligns with global frameworks and supports the long-term sustainability of the sector. In that spirit, we are hopeful that the upcoming MEPC session in April will help to align international emission reduction measures with the EU's regulations, creating a coherent and effective approach. One must not forget that the IMO has become powerful not only for the shipping industry, but for every other industry, in the sense that by defining Scope 3 emissions, it is defining the emissions for every other industry. As we navigate the uncertain path toward decarbonization, Greece's position remains clear: fuel and technology neutrality for new builds. This, in my opinion, is key, as the next generation of green fuels must meet several critical criteria. These fuels must be safe, must be globally available, and must be scalable. Until our industry reaches that point, we should continue focusing on practical solutions for the existing fleet. Drop-in fuels like biofuels and bio-LNG offer compatibility with existing engines, allowing us to reduce emissions without the need for costly retrofits. Additionally, onboard carbon capture and storage may provide an alternative that could help the industry reduce emissions, although one must address the challenges of storage and safe disposal. At this point, I want to highlight Greece's involvement in the Clean Energy Marine Hubs initiative, joining Canada, Brazil, and others in this important effort to build a global supply chain for low-carbon fuels. Given that the bulk tram sector, which Greek shipping predominates, operates on market demand rather than fixed schedules, initiatives like the CEM hubs are especially valuable to our industry. By prioritizing green fuels for new buildings, drop-in fuels for the existing fleet, CCS adoption, and CEM hubs infrastructure, we can balance sustainability goals with industry resilience and global competitiveness. As we move forward, big data and artificial intelligence will play a pivotal role in achieving decarbonization. Data analytics and AI analyze weather patterns, ocean currents, and fuel consumption to optimize routes, speed, and timing, reducing fuel use. Advanced digital technologies enable real-time monitoring of fuel consumption and emissions, allowing for immediate action to maximize vessel efficiency and reduce our carbon footprint. These technologies not only help us meet regulatory demands, but also enable smarter, more sustainable decision-making across the industry. So far, shipping has reduced emissions significantly in the last few years, mainly through operational and technical means. No doubt this summit will be discussing green technological advancements, energy-saving technologies, the more efficient hull designs, propeller ducts, bow ducts, and hull coatings are becoming mainstream, while technologies like air lubrication and wind-assisted propulsion are increasingly under test in real-life conditions. A little bit further into the future is nuclear. Nuclear, of course, is not new to shipping. However, new generation molten salt reactors are gaining attention as a potential clean and efficient power source for shipping. MSRs differ from traditional nuclear reactors by using molten salt as both a coolant and a medium for nuclear fuel, which allows safer, high-efficiency operation. Nuclear offers zero carbon emissions, high energy density, improved safety, and operational efficiency. At the same time, it poses significant challenges, regulatory and safety concerns, difficult infrastructure, and very high initial cost, not to mention the negative public perception, and these are some of the challenges that nuclear is posing. This new generation of reactors is still in an early experimental phase for shipping, and becoming part of the energy mix is at least 5 to 10 years away. However, achieving our decarbonization targets requires more than just technology. It requires collaboration. Every stakeholder in the maritime value chain must be actively involved. Fuel producers, suppliers, shipyards, marine equipment manufacturers, and other out-of-the-sector partners all have a role to play in making low or zero-emission fuels and technologies viable and scalable. It is also crucial that as we implement these innovative solutions, safety remains our top priority. In a way, it is unfortunate that in the IMO, MEPC has taken center stage over recent years over MSC. The safety of our people at sea, the protection of our vessels, the safeguarding of our environment must not be compromised. The transition to sustainable energy demands a skilled workforce. And as we implement major changes to ship systems, training will be essential for both crew and shore personnel. Decarbonization with safety should be our unwavering commitment. It is important to remember the indispensable role of shipping in supporting global prosperity and geopolitical stability. Shipping carries nearly 90% of the world's traded goods, ensuring the well-being of billions of people and securing essential supply chains. Greek shipping controls over 20% of the world's merchant fleet by deadweight tonnage, and more than 60% of the EU-controlled fleet. Being largely focused on bulk and tramp shipping, it is uniquely positioned to meet urgent demands as a pivotal role demonstrated during the pandemic and the Ukrainian crisis. Greek owners have shown a strong commitment to green innovation, leading the world with the largest fleet of alternative fuel-capable vessels. Greeks have also led in the order book with over 500 new vessels, a substantial part of which being alternative fuel-ready vessels, and 35% of the existing fleet equipped with energy-saving technologies. These statistics are a testament to Greece's leadership in sustainable shipping and our commitment to decarbonization. As we look into the future, we must recognize that decarbonization is not just an environmental goal. It represents a fundamental shift in how we operate, how we collaborate, and how we innovate as an industry. what we are discussing today is just the beginning of a broader transformation towards a sustainable maritime future. I encourage all of us to continue these important conversations, explore new ideas, and turn our challenges into opportunities for growth and innovation. Together, we will lead the way in reshaping the maritime industry for future generations. Thank you, and I wish you a productive and fruitful summit.
Thank you, Mr. Xilas. We are moving to the first session of our conference on the development of the Greek shipbuilding industry. And I would start with our first speaker, is Mr. Panos Xenokostas. He's the president and CEO of Onyx Shipyards and Technologies. He's a visionary entrepreneur and investor in shipbuilding, maritime, energy, defense, etc. His group has invested more than 650 million euros in Greece. And since 2019, when Syros and LFC shipyards were reactivated, more than 560 ships, Greek and international, have been serviced here. Mr. Xenokostas is also the president of the newly established Hellenic Shipyards Association. Mr. Xenokostas, the floor is yours.
Good morning, everyone. I would like, first of all, to thank the organizers for the kind invitation, for this brief presentation and sharing with you what we have done since 2019 in the shipyard, ship repairing and shipbuilding industry in Greece. And before sharing with you where we are now and where we're heading, I would like all of us to go back to 2017, 2018, when I was first introduced and I was first visited Syros Shipyard in Greece. More or less the situation I faced there was the same across the board in the Greek shipyards. Abandoned assets, scrappy stuff. Nothing in Syros Shipyard had been maintained and had been serviced and had been even basically repaired for the last 15 to 20 years. So the floated docks were sinked. Cranes were not operating. Actually, the power had been cut off for more than a year. And imagine a facility with that level and so massive in the center of an island with big cranes and floated docks in the center of Aegean without power. That means that they were not able to do even necessary stuff for safety, and nothing was operating. At the same time, it was very dangerous for the city because back then, nothing has been done for the last year, as said, and it was a great safety issue for the town during the winter time. I'm saying that because before even getting involved in the shipyard, before even starting negotiations with the government, I had been asked from the workers and from the church there to give a corporate guarantee, a personal guarantee, in order to have the shipyard connected back to the grid and have power to do necessary stuff in order to avoid a severe situation. What about the people there? The people, I found 180 people that had not been get paid their salaries for the last 5 years, and people ready for retirement. They could not actually get fired to go, to continue with their retirement, and ships had not been there for more than 3 years, and actually the shipyard was not able to do necessary maintenance to ships for the last 10 years properly. That means maximum 10 ships a year, and nothing was operating at all. That was the situation. What's the situation now? The situation now after 5 years is that we have already invested 65 million euros there. From the rehabilitation plan, we have already paid close to 25 million euros. 10 million of them was payments for salaries, unpaid salaries for previous ownership and management to the workers. From historical record with the previous management of 18 to 20 ships per year, we are now servicing more or less 100 ships per year. A historical record from the Syros shipyard was the annual turnover was never more than 16.5 million euros, and 80% of that was coming from defense programs from the Hellenic Navy. And for us now, we are reaching to 53 million a year. Indirectly, we are hiring 650 people working in Syros shipyard. And the economy of the island has been revived since the Syros island, if you know, it's not Mykonos, it's not Paris, it's not Santorini, is an island that is very depending on the industry there. So the whole island has been changed, and the footprint of shipyard's operation in the local community is massive. LFC shipyard, more or less the same situation. The only difference was 10 times more difficult, 10 times bigger numbers. But we are 10 times more experienced in order to face what we had to face. And I'm saying that because now we are operating the shipyard, the LFC shipyard, for 1 year and a half with this intermediate phase. The intermediate phase is innovation of ours in order to mind the gap between the reality of things, the reality of market, and the reality of the Greek legislation when it comes to bankruptcy and turnaround companies. That means if I had to wait until the process of bankruptcy law had been finished, we couldn't do something in Syros for 3 years and a half, and for LFCs until now plus 1 year. That means that okay, we have an operational agreement. In LFCs, the court decision has been made. We have the ownership, but until the final transfer happens, it takes time, which we accept, and that's why we said it's innovative, because we're starting putting money, our money, my money, without having the full ownership of the shipyard. That is the trust and the belief of what we can do with the Greek shipyards and what we believed. And that wasn't given, because in the beginning, most of the people thought we are crazy, I'm crazy, that something else is happening. Nobody believed that we can have shipyards in Greece. And actually, it was crazy, because the common sense says that a nation of ship owners, of ship owners that actually #1 power in shipping industry worldwide, that cannot have operational shipyard in Greece, that's the crazy, not the other way around. So in LFC shipyard, we run faster. We have serviced so far 120 ships in these 18 months, having in mind that at the same time we are renovating the shipyard, we are doing the necessary repairs, etc., and we have already invested there more than 65 million euros. 20 million of them is unpaid salaries to employees, out of 40 million that we will get paid at the end. And we have the rest is CapEx improvements, and we are continuing our CapEx improvements plan and renovation upgrade of the shipyard. So far, everything is operating. We can service up to Aframax size. We have renovated all the floated docks we found there, also synced, because I have to share with you that all the floated docks in the shipyards we acquired were synced, or were synced and they were just left over without any maintenance. And in total, what we have done in LFC so far is we have a historical record of annual sales of plus 80 million this year, having in mind that the previous record with previous ownership was not more than 25 million a year, and 80% of that was also Navy contracts. We are more or less having more than 1,000 people working every day in our shipyards, and in total, we are servicing in both shipyards we own 215 ships a year up to Aframax size. And this is what we have done so far. What's next? During the next 5 years, we're running a investment plan of 250 million in order to increase the capacity volume-wise, tonnage-wise, and number-wise. That means we will go up to Suezmax dry docking capabilities through new docks, and we're going to go up to 300 ships a year that will be our target for the ship repairing sector, aiming a very big portion of the market share in the region meaning between Black Sea, Gibraltar, and Suez. That's the sector, the ship repairing sector. We also focusing to expand our activities because our vision, my vision, is to transform to the traditional shipyard to a hub that will offer more services, meaning, first of all, shipbuilding for tugboats, for ferry boats, and other special vessels, naval. We can build up to frigate any ship for the Hellenic Navy and other navies, and we can service and do the maintenance, repair overall for the same type of ships. We have already prepared our yard in order to build. We're still waiting the Navy to take a decision to trust again the Hellenic shipyards. Third sector is energy sector. We are focusing in servicing with the offshore wind farm, wind generators, floated generators, capabilities to build them and operate them, the energy transition and energy safety of Greece and of Eastern Mediterranean. This is part of our DNA because we have been signed a loan, a bond loan with DFC. DFC is the United States state-owned development bank, and in the center of our scope is to help and support the region in this energy transition, energy safety, and that's why we are focusing on green transition and especially offshore floating wind generators production. And last but not least is the logistic integrated solutions, which is not the right time to share with you, but we intend to turn all this facility to a hub that is servicing as a platform, connecting the local industry, our ecosystem, SMEs, and local capabilities with the ship owners, and this is how we increase competitiveness. Concluding, I would like first of all to thank the Greek ship owners who have been trusted us from the beginning. This is the reason we are still very passionate about our vision. They are there, they are here. In 81% of the vessels we service in LFCs are Greek ship owners, Greek ship owned, and 78% of our vessels that we are servicing in Syros are also owned by Greek ship owners. I'm also very thankful for our workers and our people who are working every day, competing internationally and successfully in this very competitive market. I would also to thank the government, the Greek government, Prime Minister Mitsotakis, and the Minister of Development, Mr. Theodorakis, who are really supporting our efforts. And a last thing I would like to share with you is that as Europe, and following Draghi's message, we need to go back to reindustrialization and to bring industry back in life in Greece and in Europe. In order to do that, we need to run faster all the needed legislation changes and framework in order to stop the unfair competition that the European shipyards and Greek shipyards are facing because of the local competition that initial scope was to have fair competition. We have shared with the Greek government our, as a Hellenic also Shipyards Association, our concerns and our proposals, and we are hoping that this time we will not lose the opportunity, and we will do whatever is necessary in order to bring industry back, industrial capabilities back to Europe. Thank you all for your time, and have a great day. Thank you.
Thank you, Mr. Xenokostas. And we will move on to our third speaker. And the third speaker is Mr. Miltiadis Vavritsiotis, who is the CEO of Scaramanga Shipyard, a lawyer by education with graduate studies at Harvard University. Mr. Vavritsiotis, since 2000, has been elected 11 times as a member of Greek Parliament, and he has served twice as Minister of Shipping and some other ministries. And in 2024, he resigned from Parliament to work at Skaramangas Shipyard under the new ownership structure. So welcome, Mr. Miltiadis Vavritsiotis. The floor is yours.
Well, thank you. Good morning to everybody. It's a pleasure to be here. When I got the invitation, I was, I didn't pay a lot of attention to it. because normally I was used to speak in other kind of shipping conferences. But then my guys in the shipyard, Mr. Georgiadis, who is here, come and tell me, oh, you should be there. All the people that we want to talk to are there, and you should be there this morning with them. And therefore, here I am to tell you a few things and a few thoughts about the Greek shipbuilding industry. I've heard my friend John Xilas, who I congratulate for his election as the chairman of BIMCO, talking about the future of shipping, greener shipping, how the energy transition is going to be accomplished, how Europe is introducing unilateral measures that actually don't make our ports as open as they should be. And I was thinking that after the US elections, we are getting in a new phase. Probably being greener wouldn't be the #1 priority, but being competitive would definitely be. We are getting back to the raw competition era, and in this competition, Europe has lost a great advantage. Back in the years 2000, when I was firstly elected in the parliament, Mr. Chairman, Europe was building half of the world ships. Nowadays, Europe is building only 5% of world ships. That means that all these state aid rules, regulations for workers, for environment, that put a heavy burden in our production, energy cost, which in Greece is unbearable for a shipyard. Today we are more than double than France, more than triple than Spain today as we talk, make us lose our shipbuilding industry. And now only 150 shipyards operate in Europe, while in Asia the number has increased and the berths and the shipbuilding capabilities are increased. And if we talk to anybody, any of the ship owners for the prospect of building a bulk carrier or a tanker somewhere in Europe, they think that it's out of the question. Because now in Southeast Asia, in Asia altogether, new hubs of shipbuilding industry have been introduced with the provision of capable of providing all the spare parts, something which is not the case, and especially it's not the case in Greece. So why and how the Greek shipyards may be competitive? And I will introduce the case of Skaramaga shipyard. By coming a little bit forward back in history, by starting in the years 2013, 2014. Then I was the Minister of Shipping, and I tried to introduce, to award to a Greek shipyard the new project of the Hellenic Coast Guard for the new OPVs that we were acquiring at the time. Skaramaga shipyard was not even operating at the time. It was closed. And LFC shipyard could not issue a bank guarantee to participate in the tender. That was the situation. Today, we have a robust rebirth of the Greek shipbuilding industry with investment, as Mr. Xenokostas presented his own endeavors. And of course, I will present the vision that I joined, the vision of George Prokopiou, to set a foot in Greece and say that this country, these people, this knowledge should be materialized and transformed into modern ships that may be designed and built in Greece. And this is the vision that we are pursuing at the Skaramagas shipyard. And we try to do it by, first of all, putting back our huge infrastructure back into operational mode, and of course attract ship repairs. The first ship that came into our shipyard for ship repair after a period of 15 years was only last February. And since then, I can proudly say that we are almost fully booked. And a lot of companies that actually call us, especially Greek companies that call us and try to find a slot for a dry dock, they're unable to find due to the fact that during the period that Skaramagas shipyard was under a special management, controlled bankruptcy management, they actually sold all the floating docks of Skaramagas, and we have been left with only fully renovated within the last year huge dry dock that can accommodate Suezmaxes. And proudly, we have so far accommodated quite a few with very heavy repairs that we have accomplished both on time and, of course, within the proper budget. The future for us is to level up our capabilities, to make this huge infrastructure that started to being built back in the 50s and developed up to the early 2000s when a new shipbuilding capability was introduced to Greece, and this was the shipbuilding capability of submarines. Yes, we are able to build submarines, Skaramagas, as we are able to build frigates, as the shipyard has done it in the past. We want to actually introduce ourselves to several areas of the market. One big aim and challenge for us is to make ourselves capable of repairing and hosting LNG carriers. And we hope that from the beginning of the year, we are going to be the shipyard, the only shipyard in Greece, and one of the few in Mediterranean that will be able to service LNG carriers, which are increasing in number, also, not only worldwide, but also Greek-owned LNG carriers are increased on a daily basis almost. The second is that we want to level up our capabilities by, and this is what we are actually in the market for, try to have a new floating dry dock that will also help us accommodate smaller than Suezmax and Aframax ships at a competitive rate. We want to also be able to accommodate mega yachts, which is a great market, and we have actually done so far quite a few of mega yachts, and we are going to level up also the mega yacht capabilities. New building projects for the Hellenic Navy and long repairs for the Hellenic Navy and the Hellenic Coast Guard. And finally, we are going to introduce also new capabilities for the learning of new shipbuilders, new welders, and all the other people who are necessary to work in a shipyard. Let me say a few words coming especially from the experience of our owner. When we talk with Mr. Prokopiou about how to make our shipyard more competitive and whether we are expensive or we are not expensive, something that is actually discussed among people in the industry, one of the things that we have come to realization, having also the data from our mother company that operates more than 125 vessels at the moment, is that we are extremely competitive, especially vis-à-vis our neighboring country, Turkey, that has seen a rise in its shipbuilding and ship repairing industry. The last 15 years, the years that our LFCs and Skaramagas shipyards were closed. And this means a lot to us. We are definitely oriented to service the Greek shipping industry. We want to welcome Greek ship owners in our shipyard, and definitely we are going to do the best to accommodate them. I find it a very refreshing experience to come in the office in the morning. When I went there last February, it was actually almost a dark, empty office without anybody coming in or going out. Now we have 3 meeting rooms and they are full throughout the day, especially from the technical departments of Greek shipping companies that they want to get to know us. They try to bring their projects. They try to find a long-term and more solid cooperation with our shipyard. And this is something of very, very crucial, but also very effective for our industry. Ship repairing in Greece is actually giving both to the shipyards, but also to the companies, a great competitive advantage. You can drive early morning to go to the shipyard, to visit your ship, to supervise the repair, to actually get to be close to the billing process, and also to have a great monitor of the subcontractors of your choice to work on your ship. Let me say that I'm really proud that, first of all, that I have Mr. Prokopiou actually trusted an old politician to run a new project. This is very rare, and I'm very proud and honored by his choice, but I'm very proud and honored to work with a team of excellent shipbuilders, people of high technical capacities, people who have been committed in keeping this shipyard alive for years under special administration, without pay some of these years, but they kept this national asset alive. Because what Skaramagas was, is, and will be, it will be one of the greatest industrial infrastructures that we have in the country. I believe that it's the third biggest solid industrial infrastructure after the 2 refineries, and one of the key assets for our national defense, because it has not only produced, but also repaired the whole of the Greek fleet, not once, but several times. And this is something that actually gives us also a national pride to what we are committed to do. And this is to do our job with a highly competitive rate, but also with a being very focused on the quality of our production. Thank you very much for your attention, and we are going to be pleased to welcome you in Skaramagas Shipyard.
Thank you to all the speakers. We would like to open the floor to questions. You know, we have some time for questions. So anybody that wants to make a question, to ask a question, please feel free. Yes? There is a microphone next to you on the...
Hello. My name is Cihangir from Turkey, Ara Shipyard Commercial Managers. Mr. George and Mr. John, I remember you before in Turkey for repair in, I think, Sefin Shipyard, I don't know, but I know your site and you. So my question is for Mr. Miltiades and Mr. Panos. Now in Turkey, I know some problem for the shipyards repair application. Normally, I have experience more than 15 years in repair side. Now, our shipyard is a new shipyard. We are instruction this shipyard. So we want to change our mentalities, Turkish shipyards repair mentalities for saving time, money, and also this industry in Turkey. Nowadays, I see the shipyards condition. Many of them are almost empty, and also European side has opened their shipyard as you and start their business. So many clients are going to European side, Chinese side, and also for the Middle East side. So Turkey has losing his power for repair side. I listen Mr. Miltiadis' opinions and congratulations and thank you for your opinions. They are good and almost right. So I'm for these two shipyards' opinions, I came this committee. What do you think for the future conditions of the Turkish shipyards and European repair sectors? What's your opinion, general? It's going to be good or it's going to be bad? So, what kind of things Turkish shipyards need to do? I want to learn your advice or your opinions. Thank you.
First of all, I would allow me to say that I respect Turkish shipyards. I still consider that the number one power in Mediterranean when it comes to ship repairing and in some type of vessels when it comes to shipbuilding. So I think that you are doing well, you're still doing well, and congratulations for that because it's not easy. And we have a lot to learn for how Turkey turned its industry to a leading industry in the region and has covered a lot of markets, especially in Africa and Mediterranean. And I think that you are doing just great in this sector. Now, when it comes to Europe and Turkey, this is, I think it's beyond shipyards. It's a political thing about if you're part of Europe, if you're not part of Europe. So, I mean, Europe will change its legislations, and if a country wants to be part of these legislations, it has to have the right, when it comes to shipyards, of vote, but also the obligation to do what has been voted for. So that's what I'm calling fair and unfair in general, because shipping industry and ship repairing is an international market, international competence. So when it comes to fair, all the players has to have the same framework, no matter what the framework is, and the same competition, let's say, starting point in order to be fair. So concluding, I think we just have to congratulate and copy from Turkey what has done in the past, and congratulations for that.
Well, if I may add one word. First of all, I agree with Panos that Turkey has excellent shipyards. And we look after things that they are doing, so to learn also. What it's in this business, but in all businesses, but especially in the shipping business that you address the global market, you have to be always competitive and you have to be always very good in quality. This is a level of excellence that you have to pursue all the time. I know that lately the cost has risen significantly due to government regulation, but also the depreciation of lira. And this has caused a lot of change, let's say, in the influx of ships and new jobs to be undertaken. But as you know, in all these things, these are circles, and sometimes you are at the bottom of the circle, another time you are at the high point of the circle. Definitely, we are coming back as Greece. Perama is doing an excellent job as well, and a lot of things have been done in Perama for ship repair and have leveled up its capabilities. Other smaller shipyards in the area as well. So, yes, you have a competition now from Greece that you didn't have the last few years. This is something that we have to work, and you have to work with it. I mean, we have to cope.
Any other questions? There is a microphone near there. No.
My name is Spiros Alexis.
Can you open it?
Huh?
Can you open the microphone?
Can you hear me now?
Yeah.
Okay. I would like to ask Mr. Miltiadis before, at the start, he mentioned that there are a bunch of legislations that are holding back the Greek shipping construction theater. I would like to ask if there's any specific ones that are currently holding back, and what can we do to either reform them or say introduce other ones?
Well, first of all, I introduced the idea that Europe altogether for the last 25 years was against the shipbuilding industry, excluded shipbuilding industry and shipyards for any direct money influx coming from European programs. Shipyards not eligible. Point. Finished. Line. This is going to change the next few years. Last February, the European Parliament passed a legislation actually asking the Commission to bring back the shipyards in the eligibility mode for European programs. The second is that the digitalization, innovation fund, all these funds, they can also be addressed by shipyards, and a few of them, a few shipping projects have been financed in the last round of the innovation fund. But listen, in a country that we are lacking of, still we are lacking of exports. And shipbuilding is definitely an export business, 100% export. And we are lacking of highly paid jobs for skilled workers, and the shipyards are offering this kind of job opportunities. It's not like to be in the tourism sector that you take the basic salary and then you live out of the tips that you get if you are lucky enough to work in Mykonos, or lesser tips if you are in a remote island. But anyway, you make a living out of the tips. In the shipbuilding industry, you get paid by a very competitive salary, double to say from an office salary, level up your skills, and this has to be also embraced by the Greek government. It hasn't been embraced, the shipbuilding industry. If you build a house, what you pay at EFKA is a nominal rate. But if you work in an organized shipyard, you pay a full rate. And this makes a lot of difference. And that's why we see that we are competitive in construction and not competitive in shipbuilding. And if you go to Perama, some of the, of the operation is not really transparent in terms of the actual pay. But if you come to our shipyard, there is no the possibility that you pass through the gate if we don't have you announced at EFKA, at Ergani, in the moment that you pass the gate, and to know exactly for how many hours you can going to stay on a ship working, either for us or one of our subcontractors. So these are critical issues in order to level up without losing anything from, let's say, what should be returned to the state, how we can make our business more competitive with slight regulation. Another point is that we all want to produce our own electricity through renewable resources, wind and solar, but it's very hard to get a slot now for a net metering program in order, when you are producing, to sell it back to the system. Because, as you know, the system of the renewable resources has been closed in Greece because of the extreme capabilities that they have introduced without the possibility of absorbing all this power that has been regenerated by the renewables, because now renewables in the Greek system overcome the 62% on a daily basis, and some days they are up to 100%, and there were a few days this summer that they had to shut down the system in order not to overheat it because of the huge production coming from wind and sun. So these are things that I hope that in the next few years they're going to be addressed. The government has always an ear for new business, and we can cope with these, let's say, competitive disadvantages that we may turn them in advantages.
Any other questions? Yes, go ahead. Go ahead.
Hello everyone, my name is Fotinakis Dimitris.
Hello everyone, my name is Fotinakis Dimitris, and my question is the rates of the workers a necessity in order for European and Greek shipyards to be competitive again? I mean, the change of the rates, is it a necessity? The hourly rates.
I don't believe so. I don't believe so. I don't think that you make yourself competitive by lowering the wages, because then you are not going to attract the most competitive people. I don't believe that. I think that the actual wage and the money that a worker, a technical scientist who works in shipyards, the pay that he's bringing back home should justify, let's say, the social burden that we have nowadays, especially in our country, that dirty hands are not something to be proud of. So there should be a compensation, because working in a shipyard means dirty hands. You come back home dirty. And this is something that should be paid. What I am talking about is not the direct cost, but the indirect cost, and that comes with the social security and the other burdens.
Actually, what I would add is that there is, I think, a misunderstanding what the sector is. The shipyards is part of the shipping industry. Shipping industry has different rules and different framework. Part of what Miltos said about the non-direct cost of the wages, which I fully agree, is because, shipyards are transit. We are part of the shipping industry. We have to change the way the European community, the European, the EU and Greek government and all the system sees at what they see at the shipyard. And that everything will change automatically following the rules of the shipping industry. That means flexibility, that means non-direct cost, that means everything that could increase productivity by giving also incentives to our people and by actually attracting, because the truth of the matter is that there are some specific jobs that Greeks do not do it anymore. And we have to attract other people as other countries. Otherwise, we are lacking of certain jobs. So the only thing that has to start changing, first of all and fast, is the mentality and culture of shipyards are not part of the local industry, but is part of the shipping industry. And the rest will follow.
Well, answering this question between two shipbuilding experts is not the right thing to do, but I will give you my 50 cents. Back in the days, let's start differently. Japan and Korea are countries that have very high wages, very expensive wages. However, they are shipbuilding nations. And I think back in the ways when we were building ships in Japan in the 80s, we were building ships in Turkey in the 90s. The man hours per ton of steel produced, if I remember well at the time, was about 22, 23 man hours in Turkey. There were about 13 man hours per ton of steel produced in Japan. And in Greece, there were about 60. So it was a question of competition and productivity that comes out of competition that comes out of productivity. And this is where the key is, as Mr. Panos said earlier, how you can improve your productivity. So even if you have very high skilled and expensive labor, you can still be competitive.
Thank you very much for all the speakers. I think we will stop at this point because we have a full program ahead of us. I would like to thank the speakers again for their presentations and their replies to the questions. And we will move to the second session immediately. There is no need to move. You will stay there and we'll move to the next session. Thank you very much.
Our first speaker will be Mr. Jakob Nielsen. He's a senior sales manager for TGE Marine Gas Engineering. Jakob, the floor is yours. 15 minutes. I will call you 2 minutes before time. Thank you.
Good morning, everyone. First of all, it's a pleasure to be here at this conference. It is a very, very nice opportunity to be here to talk about everything that is happening in shipping. From our part, TGE Marine, together with our representative Seapower, we will talk a little bit about what we would like to do and what we develop in the shipping. So I'll go very briefly into what we will talk about in this 15 minutes, about the TGE as a company, what we are developing, how we are developing and looking at fuel systems, and then moving into a bit about specifics when it comes to ammonia and LNG bunker vessels. So TGE, we are a German engineering company. We have been in the business for 45 years, working on gas systems for gas carriers, developing systems for carrying liquefied gas, LPG, LNG, ethylene, ammonia. And then we have transferred into fuel systems that we've done for 15 years, since the beginning of starting using LNG as fuel for gas-fueled vessels. About 5 years ago, we were acquired by Mitsui, which is our main shareholder. That gives us as a strong company an even stronger owner, which is very beneficial, especially in this shifting world of maritime industry. So at the moment, our company, engineering company, we focus our new developments very much on ammonia, the new transports of energy, and of course LNG is still a very, very important part of that. In addition, we work on the carbon side. We are developing and delivering systems for transport of carbon, liquefied carbon, and we plan to continue to develop that. So I will start with the carbon part of it, the end of the exhaust. And we've been part of the first commercial transportation project for liquefied carbon, the Northern Lights. That is a joint venture program with Total, Shell and Equinor, where they will transport captured CO2 from industrial plants across Northern Europe. It will be transported by ship to a terminal west coast of Norway, and then it will be sequestrated to the underground. And this program has been ongoing for many years. In TGE, we have developed the cargo systems that will be on the vessels and being critical for this transport. It is currently 4 vessels on the building. The 2 first vessels are very close to completion. They are doing gas trials these days and will go into operation in a few months in Europe. And there is across the whole Europe and, well, globally, a big interest in carbon capture, and that's very interesting for shipping because it is planned a lot of shipping of liquefied carbon. And of course, it's also a question that's been mentioned this morning, like carbon capture. And of course, this part of carbon that's captured on vessels also needs shipping or to be transported somewhere. So TGE is very much involved in the part of transporting liquefied CO2. So this goes a bit the next the approach we have for CO2 carriers. That is kind of the backbone of TGE. How do you approach challenges and engineering challenges in shipping? But this approach from TGE as to look at the whole picture is very important. So for CO2, it's a new trade. And it's a new trade for everyone. So to how to figure out how is the best solution or the optimized solution for this shipping, we would like to look at the whole picture, and we look into, of course, ambient conditions, the selection of pressures, voyage time, because that will help us engineer and optimize systems when it comes to cost efficiency. Of course, the composition of CO2 is important because you will have different composition from different emitters, some industries, volumes and tank materials. And all this we try to put together to an optimized shipping solution or ship solution. And that's kind of, that is how we work on every project. And that will come into more also an approach on the fuel system and the systems we make for energy transport. So, when it comes to fuel systems, in TGE, we have been doing LNG fuel systems for 15 years. We were the first ones, at least among the very, very first ones, developing LNG as fuel gas systems. We saw the transition moving into LNG as a fuel. It's taken 15 years, but now we see the big boom in LNG as a fuel. And we have a long experience working on these systems, developing these systems. So we've been working on low pressure systems, free flow systems for 4-stroke WinGD applications. We have done for MAN, MEGI systems, high pressure systems. We've done LPG systems, ethane systems, and we've also done conversion systems. So we have a very, very good insight and know-how how to build these projects and to develop these projects to the best interest of the ship owners and operation. It's worth mentioning, in these years, we've seen significant amount of different companies trying and failing on doing these systems. It may seem simple, but it is complex, and it is more complex than at the first sight. And one of the things that makes this complicated is something called boil-off gas. Because when you're transporting gas, a lot of you will know, in transport of gas you get boil-off gas. And when you're transporting this as a fuel, you will get boil-off gas from the tank, from the heat ingress to the tank. That's a natural boil-off gas that is needs to be calculated when you do the project. And with TG, we've done more than 450 Type C tanks and installation, so we have a very, very good insight and expertise how to calculate this. And you always need to consider sufficient insulation, the quality insulation, and also the companies doing the insulation. So we are an engineering company, and or actually EPCS, that means engineering, procurement, and supervision. So we do very thorough supervision during all the installation work, and we see there can always be taken shortcuts. It's always easy to say this is simple and easy, but the result may not be that good. So as mentioned, this insulation application is extremely important, because if you do this wrongly, then you have to pay afterwards. When the boil of gas production increases, you need to do something with this boil of gas, or you may actually have to go back in and do re-insulation of your systems, and you don't want to do that. You don't want to take the ship to change insulation. But then you have another part of the boil of gas that can sometimes be overlooked. That is, you also have boil of gas produced during operation. And that is boil of gas coming from operating of pumps and compressors. And we can see that is easily overlooked during the engineering, during the process, because it may be not considered. It's considered that you have a boil of gas during from the tanks, but then you have additional boil off during operation. And then it's a big slide, and maybe not easiest to read, but this goes back to the approach of TGE. We like to talk with ship owners, ship designers in a very early phase to understand how will this ship operate, what is the sailing distances, what are the port calls, what times do you have idling, because when you are using your pumps, you produce a boil of gas. When you're running the engine, you get production of return flows. All these things need to be taken into consideration. How do you handle this? And what we see, there can be significant savings on operational cost by doing this in the engineering phase. Is maybe difficult to read, but we've done studies where we over a 5-year have made savings of $3.5 million in fuel. So it is significant, but if you don't do these measures early on, it's difficult to do after. One of the things we have developed a reconomizer system that is especially good to use for high pressure systems, because during the high pressure system operation, you get a return flow of warm LNG. And this typically goes back to the tank and adding to your boil of gas production. What we do with our system is that we take this flow and we don't take it back to the tank, we will take it back into the streamline up before pumps and back into the system, reducing the boil off rates. And these systems actually can not only save operational cost, it can also save the capital cost in installation and in buying. But it's important, so extremely, I cannot say that enough times, it's so important that this is done before this go to shipyard for pricing, because then it is selected typically by shipyard and they go for low-cost suppliers in easy to install or easy selection. But for ship owners, this is very,
Jakob,
very important.
2 minutes.
2 minutes. I will speed up. Then, the transition. It is ammonia. We are moving into the new era of green fuels. In TG, we focus on ammonia because we believe that will be available in amounts needed for shipping. And well, the approach for TGE in ammonia is a bit similar. We develop it on the ship owners' needs and requirements. We've been working on this since 2022, very much with Höegh Autoliners, which has decided to move for ammonia as a fuel. And in this, we have come in a situation where we have a system ready. The system is ready with everything needed for an ammonia fuel system. What is at the moment missing information is from the main consumer, main engine. We do have a very close cooperation and talks with the main engine suppliers. So this system, we know and believe this system will be a very good system. And as soon as these vessels will be delivered, we expect them to be operated on ammonia. So then, since I only had 2 minutes left, maybe only 30 seconds. So also a very, very core business for TGE, and it's been actually since our beginning, carrying of energy and gas and bunker vessels. So at the moment, we have 5 LNG bunker vessels in operation. We have 9 LNG bunker vessels under construction, and we have advanced discussions ammonia-ready bunker vessels. So for any aspect of carrying liquefied gases or using any liquefied gas as a fuel, please contact us. I know I overstepped my seconds. And of course, for any questions, anything you would like to know, you can contact our representative at Sea Powers, or you can contact us directly, but then include Sea Power. And thank you.
Thank you very much, Jakob. Our next speaker, or rather speakers, will be Mr. Stelios Kyriakou, Chief Technical Officer of ERMA First, and Mr. Frank Paleokrassas, Chief Product Officer, MITIS. They're going to talk about energy-saving devices from constructions to savings. 15 minutes. Thank you.
Good morning, everybody. I'm delighted to be able to speak at the Eugenidio Idrima yet again. My last presence here was approximately 9 years ago on a totally different topic. Today we will speak about energy-saving devices. In fact, energy-saving devices is nothing more than what it says on the tin. They are devices that deliver energy efficiency as well as reductions in the greenhouse gas emissions on ships. There's a multitude of reasons why we wish to do this, primarily driven by the GHG strategy of the IMO. It is, at the moment, one of the most highly discussed topics in all the press worldwide, especially with COP29 taking place today. It is very clear that the anthropogenic, as it's called, greenhouse issue is something that has to be tackled as a matter of urgency. I was very interested this morning to in fact see that the International Chamber of Commerce did announce that the overall cost of the impact of environmental changes and the climatic impact in economic terms has topped 2 trillion dollars. Let's remember that's how everything is valued. In any case, energy-saving devices have to contribute in that as a means of providing us with innovative, practical, technical and economic solutions to shipping of how to overcome the difficulties of substandard ship designs, let's call them. I'm not going to call them bad ones. Substandard ship designs where the efficiency is not up to the mark required. These days, it is important to consider that ESDs exist in a variety of formats. However, for the purposes of today, I would like to classify this in 3 different families. Primarily ESDs that are dealing with skin reduction systems, renewable energy initiatives, and PIDs. PIDs have been asked before what that means. It is propulsion improvement devices. Essentially, if we are looking at the skin friction reduction, the options available to us is very clearly the novel and rather very interesting bubbles I refer to usually, but the air lubrication systems. As an alternative to that, there is also options related to the use of novel coatings, low friction coatings. And of course, from the point of view of practicality, there is an issue of practices that can be adopted by industry to improve the energy efficiency, this through the means of maintaining the hulls clean, therefore hull cleaning technologies. On the other hand, we have got the currently new technologies that have emerged over the last few years, making a lot of noise, and this is the WASP technologies, which is wind-assisted propulsion systems. We have sails, rotors, and kites. At this point, I would like to also mention that with regard to the Flettner rotors themselves, there is nothing new, although we believe that they are new. If you were to research the history, you will find that were approximately 100 years ago, the first demonstrator of Flettner rotor was carried out in Finland. On the other hand, with regards to sails, I don't have to mention anything. The use of sails in maritime has been in time immemorial. Even our ancient ancestors were actually using them, so there's nothing new there. Further to that, I would like to go down the route of the PIDs. We have various options available to us, and each one of those serves a different purpose. Primarily, the PIDs that I'm displaying on this slide, they all have the same effect. In reality, they are impacting on the flow of water surrounding the hull, making various modifications in the flow in the region of the stern as a means of improving the performance of the propeller. There are some simple devices that are called fins, and they have been used for the purpose of aligning the flow to the stern. The crew spoilers, a little bit more sophisticated in a way, but they're nothing more than small fins attached to the stern, providing us with an alignment of the flow to the propeller. That also introduces an element of efficiency through improved thrust. More sophisticated devices have been developed, a pre-swell status that are unevenly distributed to the stern, accounting for the irregular flow around the stern. We have got other devices such as the Schnickeluth wake equalizing ducts. There are also systems that are aligning the flow. However, they also include an element of additional thrust that is generated due to the fact that the rings themselves, they do have an aerofoil section that introduces an element of internal pressure that is translated into additional thrust. The Baker Marine Systems MEVIS duct is actually a combination of the pre-swell stator and the Schnickel wake equalizing duct. Between them, they provide us with a very good solution. Typically, that the MEVIS duct is utilized by ships that they have got either twin screws, or on the other hand, they're of a faster speed than usual. And of course, we also have the flex cap of the Ermafest flex cap. Of course, is something that has actually existed for a number of years in the form of the PBCF, as is known. However, the Ermafest flex cap, we're proud to say that it is a development, manufacture, and design by a Greek firm, Ermafest. It is rather unique in the fact that it does include innovative features with regards to a modular construction. Looking at the devices overall, it is worthwhile examining the benefits that are potentially extracted by the use. With regards to the hull-oriented technologies, we have a very impressive performance of advanced coatings in the range of 1 to 5%, an even more impressive performance that can be achieved by the air lubrication systems. Propeller and appendages provide us with performance enhancements to the range of 3 to 10%, and the pre-swell devices as well as post-swell devices 2 to 6%. And as a means of a reality check, I would like to offer to you some statistics with regards to where these technologies are used. In fact, they are not as rare as we really believe. There are already tens of thousands of ships crisscrossing the oceans that already have included some kind of technology of this form. This slide is self-explanatory. I don't have to talk to you about this. it's very clear that there's a popularity of different types of technologies for different types of ships and for different reasons, simply because we have to always consider the compliance of the device to the design of the ship. Finally, and in conclusion, I would like to tell you the obvious, that it's very clear that there are several options that can be adopted in order to achieve energy savings. It is very unlikely that one can actually use only one solution in order to achieve the desirable objective of energy reduction, and it's very unlikely also that you can find a solution off the shelf. So if you're a manager considering ESDs, it's worthwhile considering some time for evaluation of a possible design before you make a decision. And obviously, at the end of the day, it's very clear that all the benefits of the ESDs and their application on ships have to be somehow measured and evaluated. This is not my field. This is the field of my colleague, Frank Paleokrassas, who will take you through his presentation. Thank you.
Hello, good morning. So I'm going to simply dive straight into this. All right, so Metis, as you might know, is a telemetry-powered fleet performance management company, and we are lucky enough to have quite a few ships with energy-saving devices on board. So we have been in a situation where we're able to measure what's happening on board. And I would like to show these savings with you. So first of all, wing type sails. We're talking about the big rigid sails, as Stelios talked about before. And here, what we have seen is savings up to 10%. Now, this is not always uniform, right? We have cases where the ship was going at ballast at 2.4 tons per day saved, and others where at laden was saved up to 4.7 tons. Here we're talking about big bulk carriers in the region of 200,000 tons deadweight. So the savings are not constant. They're dependent on the wind. So these devices are turned on or turned off, and this is how we actually measured the savings at the end of the day. But how they're operated matters a lot. So in one case, we saw, for example, that during the laden voyage, which was 58 days long, the system was on for 1,100 hours, but it was off for 276. We'll come back to that complication later. Where it gets more complicated is with air lubrication, which, as you know, there you have quite complicated technology where you're using massive air compressors to send air down below the hull, right? So here we actually saw some pretty significant savings in terms of power, up to 9%. But when you start factoring in the power that you use for the compressors, the picture changes significantly. And what I would like to show you in this particular case is that we had the compressors operating at 700 kilowatts, and we actually had an overconsumption. So you end up putting more energy into the system than actually saving out of it. It's not an easy balance. And I can tell you that from my previous work, I also saw that as a result, air lubrication is not used as frequently as you might expect. When we come to the other type of wind sails, talk about the Flettner rotors. So here, again, the savings are more moderate in the range of 5%. But what we also saw kind of beats conventional wisdom. In conventional wisdom, you would expect that the more energy you put into the system, the more savings you would get out of it. But it doesn't actually work that way. So we saw that in a laden voyage here, we end up saving more while operating the Flettner rotors at nearly, well, less than half the power than we did when operating at ballast. When you talk about propulsion savings, though, the PID devices that Stelios mentioned before, it's a bit of a easier topic because ultimately you just fit a device that gives you some decent savings. In this case, we saw savings of about 4%, and they're just more or less uniform throughout the operating range of the ship. Now, coming to the challenges of it all, which, as you can see, is not the easiest of exercises, evaluating whether an ESD is worth it, actually, or not. Now, when you're analyzing the performance of the ship and the performance of the system overall...
2 minutes, Mr. Palokrasas.
Thank you. So, you have to look at the effect of weather and the ship's operating profile, you know, different speeds, different drafts, as well as the hull condition, which continues changing throughout. It's a living system, right? And ultimately, the critical question of measurement and accuracy of that measurement, which I can tell you, I think most of you already know, that measuring the performance of these type of systems using NUN reports and manual measurements is challenging at best. In my previous work, this was 10 years ago, we did a massive retrofit of a 7,000 TEU container ship, changed the bow, changed the propeller, did a few things anyway, and we only realized the complexity of measurement thereafter and ended up installing telemetry afterwards. Nowadays, if you have a system like METIS, you would be able to handle these kind of challenges rather easily because we account for these problems. But when it comes to the ESD operational demands that we talked about before, it's not as easy. It doesn't seem very clear-cut on how to optimally operate each ESD. It's a matter of learning, of trial and error. And then the systems themselves interact with each other in a rather complex manner. So you cannot expect that you're going to go take a ship to a shipyard and install 2 or 3 ESD devices and expect that the savings are simply going to pile up 5% here, 10% there, 5% there, 20% overall. And more than anything in all of this is the problem of establishing a reference condition. We have seen it time and time again that ships get taken to dry dock. They do have 2 or 3 ESDs installed at the same time, maybe a low friction coating as well. And then a system like METIS, a telemetry-based performance system installed afterwards. And then the ship owner comes and says, okay, what am I saving from each one? It doesn't work that way. You have to approach this in a more scientific manner. You have to be more prepared to do the proper tests and understand exactly how each of these perform before and after. Otherwise, you end up just measuring the benefit of the dry dock at the majority of the savings, and the rest comes later. So, more than anything, I would say that if you are in a situation where you want to install ESDs, do talk with a performance management company, do run the trials before and after it's done to handle this in a systematic manner. That's all from my side. Thank you very much.
Thank you very much, Mr. Palokrasas and Mr. Kyriakou. Mr. Jonathan Shaw is the next speaker. He's the Managing Director of Stone Marine Propulsion, and he's going to be presenting optimizing ship propulsion, the Stone Marine new profile technology. Mr. Shaw, 15 minutes.
Thank you very much. First of all, I'd like to say thank you for inviting me to this very interesting conference. I'm also delighted that you managed to arrange the weather for me, so I feel right at home. So it's typical UK weather out there, so I'm delighted about that. Yeah, I do feel very much at home. My talk is about optimizing ship propulsion, the Stone Marine NPT. A little bit about Stone Marine, first of all. We can trace our history back to the very beginnings of marine propulsion, back to the 1830s, and our founder, Josiah Stone. Our company has gone through a number of iterations since then, but we are essentially still the same company. Over the years, we have designed, manufactured many different types of propellers for all types of ships, some incredibly famous ships. We are now part of Langham Industries. Langham Industries is a family company, a UK family company. It's a marine engineering company. Within that group, we have aerospace engineering, we have marine engineering, we have Stone Marine Propulsion, obviously. We have Stone Marine Ship Care, who looks after the repairs of propellers. We have Stone Marine Services, which looks after deck machinery servicing. We also have Brunton's Propellers, which looks after smaller propellers. And we think we're probably the only propeller company in the world that goes from the very small folding propellers for sailing yachts right through to 11-meter plus propellers for container ships and the largest bulk carriers. The NPT was first developed in its first iteration in around 2007, and since then we've supplied over 200 of these unique designs. It remains to this day the most advanced propeller design that is available, and it's been successfully applied to different types of vessels, container ships, carriers, drill ships, tankers. I think the smallest one we've manufactured up to date is about 4.7 meters. It could go smaller, but that's the smallest size we've done so far, and the largest is about 10.5 meters. We also supply if it's required, a Stone Marine cap fin, a PBCF post-swirl device as well that will be mated to that NPT propeller. What benefits do you get from an NPT? Typically and realistically, 2 to 6% efficiency improvement. We typically see the design characteristics of the NPT results in a smaller optimum diameter, and we see significant weight and inertia reductions. We also see typically an improvement in the vibration characteristics, so the pressure pulses to the hull from the blade tips are reduced. What we don't see an increase of is cost. It's the same price as a conventional propeller. We can see an additional increase over the NPT of a cap fin of, again, realistically somewhere in the region of 1 to 2%. Incredibly difficult to measure, as Metis has already pointed out. And one of the things that can be a huge help for a ship owner is the recycling of the existing propeller. That can offset the cost of the new propeller significantly, and I'll talk a little bit more about that later. How does it work? How do you get the improvement? Well, there's some characteristics in there on the design of the sections of the propeller. It improves the cavitation performance, and it improves the lift and drag properties. Essentially, it's a way of improving the efficiency and reducing the frictional resistance of the propeller. The effect of the NPT is to reduce the blade area, reduce the diameter, and increase the propeller efficiency. The less propeller that you're trying to turn through the water, the more efficient it will be. The benefits of a post-swirl device: lower fuel consumption. They are a direct retrofit, so the existing cap is simply taken away, recycled, and the new one, same bolt, same everything, is bolted on in its place. And as I say, the propulsion efficiency increase is roughly 1 to 2%. And in cases, we have actually supplied a cap fin on its own, not to our propeller, but to a particularly old propeller, and seen significant increase over and above 2%. But a correctly designed propeller, it will gain 1 to 2%. And it does that by reducing the rotational losses and converting those losses into energy, so the slipstream into thrust. And for our Stone Marine cap It is specifically designed for each particular application. There is no one that's same as the other one. It's part of a amalgamated design process. Some current examples here. The interesting parts there are this is a Greek-owned 10,000 TEU container ship. It's gone through a deration exercise to comply with EEXI. The power has gone from 68,000 kilowatts down to 37,000 kilowatts. The propeller has gone from a 6-blade to a 5-blade. The diameter has reduced slightly. The blade area has reduced. But the big difference is the weight. We've gone from 99 tons on the propeller to 66 tons, and a corresponding significant reduction in the inertia of those propellers. The gains that we got on this particular project through the service operation speed range were from around 5.5% to about 6%, all the way through from 10 to 20 knots. And some interesting commercial numbers on there. Those propellers had a cost of about $977,000 US. As my colleague said, everything's measured in US dollars. There's also some logistics costs getting that to the shipyard. There's also some blue fitting costs, making sure that that propeller fits on the shaft. So you're talking something in the order of $1 million for a propeller. But to offset that, there is a payback of roughly 640,000, so roughly 2/3 was realized in the value of the replaced propeller. Typically, the value that a ship owner would have to actually invest from the smaller propellers, 20-ton propellers, would be probably 2/3 of the cost. 1/3 of it would be covered by the old propeller. To the larger propellers, somewhere between 2/3 would be able to be recovered. A very hot off the press recent project that we have been involved in that there's somebody in the centre here who's quite interested in. We have just done a very exciting and very successful project with Neptune, Hellas and Foss. They have been retrofitted in China with a Stone Marine NPT, a Stone Marine cap fin and a pre-swirl device. The vessel at the time has gone under a deration. Not a big deration. It's gone from 11,500 kilowatts to 9,500 kilowatts. And the initial reports that we've had are that we are looking at a power saving demand of about 6% at the service speed, increasing to 7% at higher speeds, and maintaining a light running margin of around 5%. A very interesting project. You can see the before and after on the chart there. You can see it's actually getting better as the ship speeds up. So the MPT reduces the required power curve, and in a deration situation, it changes the reference speed. It is additive with similar technologies, air lubrication, pre-swirls. However, the propeller ultimately is the only thing that's converting the power of the engine into thrust. Everything else is trying to assist it, but the propeller is the only thing that's actually creating the thrust to drive the ship. When we're looking at projects, there are a couple of ways that they can be validated. We initially produce a feasibility study. Companies come to us and they suggest a project, and we look at what might be available in terms of gains, and then the ship owner has the option of validating those gains independently. 30 years ago, it used to be by tank tests. These days, it's probably 95% by CFD analysis, and that can be done at an independent CFD facility. We've got projects going through at the moment with Bureau Veritas. We've got projects running with Lloyd's Register. So whilst we come up with a feasibility study, the ship owner then validates those savings before putting the investment into their asset. If there are a number of technologies being considered for energy efficiency improvement, then we will work with everybody who's involved such that we have a system that works together to produce the maximum efficiency gain that we can. And we will do that by initially producing the 3D model for the preliminary propeller. We will supply that to the pre-swirl designer. They will then run that in CFD and provide us with the wake fields that will, before the pre-swirl and after the pre-swirl, we can then fine-tune that model that we've produced and again supply it back such that the pre-swirl can be fine-tuned such that we have a system that's been designed to work in harmony together to extract the maximum gains that we can possibly get. As a company, we have to operate all the way around the world. Most of our projects are in China, obviously. A lot of the retrofits are done in China. We organise the logistics and we also organise the Bluefit team. We can do that anywhere in the world. We've had projects this year in Dubai, we've had projects in Turkey. Unfortunately, I don't think we've had one in Greece as yet, but let's hope it's soon to come. And in each of those cases, we have organised everything such that the propeller arrives at the shipyard when it's entering into the dry dock. We have the Bluefit team there ready to make sure that it fits correctly on the shaft. They also assist with the installation, and they then also organise the removal of the old propeller, and we then recycle that. I'm also pleased to say that we have exclusive arrangements with our very good friends Ocean King, who look after all of our projects within Greece and Cyprus. And I guess we'll be taking any questions later. Thank you.
Thank you very much, Mr. Shaw. You don't only save energy, you save time as well.
Trying to. Trying to make the job easy.
Our next speaker is famous for his cinematographic and musical presentations. It's Dr. John Kokarakis. He's the technical director of BV, Bureau Veritas, and he's going to be presenting us with design dreams versus reality, practical tweaks and wild ideas, meter measures that actually make waves. The floor is yours, Dr. Kokarakis.
Thank you, Harry.
10 minutes.
Thank you very much. Good morning and welcome, everybody. I'm here to share what is lurking in the shadows of decarbonization. The scariest thing in the shipping world is not the skeletons, the ghosts or monsters. It is an unexpected carbon tax. We have been treated to the short-term measures, CIIs, and etc. Now the time of mid-term measures has arrived. They are promulgated as the means to decarbonize shipping. These are the dreams. What is the reality? Ladies and gentlemen, as we dive into assessing our current position, remember that navigating these new regulations is like trying to read a ghost story by candlelight. Just when you think you understand what is on the page, something shifts and you're left in the dark again. The challenges. We are facing a significant lack of clarity with critical details missing. There is an incomplete impact assessment, the CIA, the comprehensive impact assessment that comes with the measures, particularly when it comes to food security. Risk assessment remains challenging. Ongoing debates are creating a landscape filled with diverse options, but no consensus. Multiple candidate proposals are being considered, yet alignment is elusive. We started with 8 proposals. The proposals, each proposal, not necessarily both, but it consists of an economic measure, the so-called levy, price on the CO2 emissions, the carbon tax, like the EU ETS, and also a technical measure which is the fuel intensity. Carbon dioxide, greenhouse gas emissions, not only carbon dioxide, also methane and nitrogen oxide, per energy consumed. These are coming into force presumably sometime in 2027. They must, 176 countries must agree on this coming April. The Secretary of IMO, Arsenio Dominguez, has promised that he's going to lock the doors until the delegates of the working group are going to agree. We cannot afford not to agree. Currently, we have 4 major proposals, or maybe 3 major proposals on the table. The EU GFS Global Fuel Standard Plus levy, proposed by the European Community, supported by others as well. I believe the International Chamber of Shipping is between them. The Chinese proposal, IMSF and F, without levy, which is, I can call it the BRICS proposal, and the Pacific levy proposed by the Virgin and Pacific Islands, the small island developing states. Notably, the European proposal is the most stringent one. You can see the lower the curves, the most stringent. I have plotted here the Fuel EU, the top curve, which is top because it is actually based on the previous IMO strategy of 50% reduction. The lower curves are 0 CO2 in 2050, and in between is the IMSF and F proposal. It is the lowest severity. These numbers come from submitted examples in the intersessional working groups. Some tables, the IMSF and F is the most shipping friendly, focusing on the fuel intensity as the primary metric. Fuels are considered only tank to wake and not well to wake from the other proposals. They have reason for that, and it's a very reasonable. I find their reasoning very reasonable. They say that the carbon dioxide in the countries that the fuels are produced is already credited in the inventory of carbon dioxide of the country. They also claim, and they are right, the life cycle assessment is at its baby phase. We need to do a lot more for the state to enhance the state of the art. We don't know all the emission factors for the pathways. In contrast, the EU proposals has both fuel intensity and the levy. The Pacific levy has a fixed charge of $150 per ton of carbon dioxide equivalent with no consideration. It has not been defined, the fuel intensity. All 3 proposals give you credit for wind-assisted propulsion. Some details The baselines, of course, what I mean by baseline is the required fuel intensity, which you saw in the graphic, are defined in the beginning and they are reduced every year as we go to 2050. IMSF-NF focuses on bunching and pooling with a fee-based system. The idea of these midterm measures is to bridge the gap to encourage the use of alternative fuels. I've heard a new term at IMO, the ZNZ, means zero, near zero fuels. Near zero means less emission factor intensity, less than 10 grams carbon dioxide equivalent per megajoule. Now, the Chinese proposal has $75 per surplus. Surplus means that it's credit that the ship earns when its attained intensity is lower than the limit. And the remedial unit, when it's higher, is priced at $100 per remedial unit. In contrast, the EU GFS and levy use $100 per ton of carbon dioxide and no offsetting, and remedial unit price is assumed, nothing has been fixed yet, don't be scared, of $400 per ton carbon dioxide equivalent. Notice that in all cases, the remedial unit price is higher than the fee-based and the remedial, the surplus unit.
2 minutes.
Why do we have that? We have it because we need to make economically attractive to invest in greenhouse, in energy-enhancing technologies. Now, let's walk fast through through a few cases. In an LNG carrier traveling from France to the United States, in the gas mode, we're going to see with the EU proposal up to 4 million per trip, per round trip, 31 days trip. We have about 11 trips per year. The Pacific levy around 1 million, and the IMSF-NF less than 500,000, all in the gas mode. Now, this includes the cost, this curves includes the penalty for the midterm measure and the cost of fuel. In a container ship, we have similar measures, even tougher, because containers are burning a lot of fuel. So we have the fossil fuel scenario where we have over 43 million per year. This is a high number for the EU proposal. In the biofuel scenario, it is a green fuel, it's a environmentally friendly fuel. With IMSF-NF, the cost drops to zero for non-compliance due to surplus bunching. For an Ultramax bulk carrier, the fossil fuels lead to under-compliance cost of 49% to 343% of the total fuel cost. Similarly for the biofuel, like in the container ships. To finish my presentation, we have the $1 million question. In 2027, when the measures are going to come into effect, will the EU withdraw its existing regulations, including the EU ETS and the FuelEU Maritime? This decision could be a turning point in our industry. Thank you, and let's dive into your questions and discuss the path forward.
Thank you very much, Dr. Kokarakis. Our last speaker will be Mr. Stig Leirer. He is the manager decarbonization solutions for ABB Marine and Ports. He's going to talk about ABB Dual Fuel Electric Plus solution for LNG carriers. 15 minutes, please. Thank you.
Thank you. And first to the organizers, thank you for inviting me. And dear audience, I will give you an introduction to ABB's DFE Plus propulsion system for LNG carriers. It's basically a reintroduction of the dual fuel electric propulsion system that we had quite a good success with 15 years ago. But now we saw that the technology has evolved. First of all, there has been new four-stroke engines in the market, but also on the electrical side, we have the ABB Dynamic AC. See. Yeah. So in about 2 years ago, we signed an agreement with the MAN four-stroke department that we should develop and market together the concept. And we also did plan to do internal simulations and development of the systems. Very soon we saw that we needed a third party to verify our findings. So we engaged DNV in Athens, and they were running simulation using their Cosmos tool. And I will share some of the results with you later in my presentation. Since we introduced the concept, we have met a lot of ship owners, charterers, and shipyards. And just recently now, we have started working with a ship owner on a specific project. And we hope, of course, that that will go into a ship being built with this system. And of course, the motivation behind all this, I think John, he explained very much what the motivation is, and that is, of course, all these new regulations coming up. So we have to look at new concepts that gets the fuel consumption down. And the highlights of the DFE Plus concept. It gives an overall energy consumption improvement between 6 to 7.5%. I will show you the result from the DNV simulation later. It is flexible. It's maintaining the efficiency throughout the speed range. And especially these days, we see that there is a tendency to lower speeds. The vessels are traveling in lower speeds. So this system have a very good efficiency also when you go down to 15 knots, 30 knots, whatever, that will be the future. There's a potential for extra space for cargo, up to 6%. And there's actually now, there are 2 shipyards, one Chinese and one Korean shipyard that has a design ready, showing that how to go from 174,000 cubic meter LNG vessels to 183,000 cubic meter in the same hull. Of course, it's redundant when you have 3 to 4 engines and a battery. It's redundant. And it's also very flexible for future adaptations. In the slide here, we have shown 3 engines and 2 fuel cells. So whatever will be the future, if it's solid oxide fuel cells or whatever it will be, it is very flexible, so you can replace one or several engines. And of course, it can easily be prepared for future FSRU operations. And the main components in our system is the ABB Dynamic AC, meaning that we allow the frequency on the electrical plant to vary between 48 to 60 hertz. And that will allow the engines to run on a variable speed, and that gives benefits when it comes to efficiency, but also methane slip. We have improved the control system, the power and energy management system. We have introduced a battery pack for peak shaving, and also spinning reserve. We will have permanent magnet motors for better efficiency. And also as an alternative, we can also offer ABB's Azipod propulsion, where that is applicable. And these slides show the principle of the dynamic AC and variable speed for the engines. The upper right chart there shows how you are running a system on a fixed speed, and the lower one, the green line going through the optimal fuel consumption point, shows what you achieve by running the engines with a variable speed. And that will, of course, give you the best benefit when you are running on a part load. Yeah. And this is a more artistic single line diagram for the more technical savvy in the audience. But it's showing that that we allow the bus bar, main bus bar running on 48 to 60 hertz, and then the engines can run on variable speed. Yeah, and that gives some, of course, benefits when it comes to efficiency and also methane slip. And we have actually given offers already with a 3-engine solution and a 4-engine solution. Now, I will not dwell much with these because they are quite technical slides. As I said, we have signed an agreement with the MAN 4-stroke department on the development, and this is their new engine, the 4960 engine, 4-stroke engine. It's significantly improved compared to their older generation, the 5160, and it's up to 6% improvement in fuel consumption at full load. And this is also then at some curves from a test bed of this engine, where to the left you can see that we are allowing the engine to run from 480 to 600 RPM. And then the result is that you can see from part load, we have a saving at 50% and at around 5% between constant speed and variable speed. And also the methane slip is significantly reduced for part loads when you allow variable speed on the engines. Another important feature of the DFE Plus is that you have a significant space saving for cargo. And as I said, there are already 2 shipyards, one Korean and one Chinese, that has a design, a total ship design, showing that they are able to utilize this space to transport more gas. Yeah, and there's also some other benefits, of course, in addition to the one I already mentioned. But with a dual-fuel electrical system compared to a 2-stroke system, you have low noise and vibration. You can do maintenance on the engines during vessel operation. It's very stable operation in gas mode. And it's future-proof towards 2050 by the modularity that you can replace one engine with a fuel cell, or you can replace you can have one engine running on alternative fuels, while the 2 others or 3 others are running on the boil-off. It has reduced methane slip, and as I also mentioned here, it's an ALS interface. MAN is working with one of the suppliers of air lubrication that are actually using the excess air from the turbochargers to make the bubbles in the ALS system. And by that, saving also energy. You don't have to have the compressors. And then this I will show some slides from the simulation that was run by DNV in Athens using their Cosmos tool. So what we did, we took a ship with the DFE Plus concept and used a two-stroke XDF 2.2 LNG ships, used that as a benchmark, and that is a state-of-the-art two-stroke with the ALS and also shaft generator. And they looked at two different trading routes, one from US to Europe and one from US to Asia. And they had DNV had the speed profile in their database, and they used that both for laden and for ballast. And the finding was that if you take into consideration also the cargo space saving and look at how much energy do you need to transport a unit of gas 1 nautical mile, then their findings was that it was up to 6.8% savings compared to a two-stroke solution. And they did also two different simulations. They did the one with C margin 21, meaning a hull that was very dirty or grown, or a C margin 0, where they have a totally clean hull, where you get slightly better results, but around 7% better efficiency. And this is the statements from the DNV report. I will just ask you to look at the last one, so we can save some time here. That they are saying that the saving is between 6 to 7.5% compared to the two-stroke dual fuel system, and that is the DNV finding and not from ABB or MAN. Yes, and one of my last slides here. This is showing more an artistic way for how we see the future. As I said, the DFE Plus is a very flexible system. It's modular, and as I said here, the first kind of adaptation could be that you run one engine on biofuel, and you run two others on the boil-off, because what's specific for LNG tankers is that you have the boil-off gas and you have to utilize it because you have the free fuel. Other option could be that you insert or you replace one engine with a fuel cell, or you have a hydrogen reformer and you inject hydrogen into one or several of the engines. So that's one path towards a very low emission system. And finally, my last slide here. ABB, we have a very long reference list of delivering power and propulsion systems throughout history. We have delivered to more than 143 LNG carriers since 1995. And we think that the DFE Plus concept is a natural continuation of this proud history. Thank you.
Thank you very much. We will have some questions and answer session. Before we turn to the floor, I would like to ask a few questions myself. First of all, I would like to ask Dr. Kokarakis, is there a majority between the IMO member states, and I remind everybody here that Greece has 1 vote, Tuvalu has 1 vote, and Vanuatu has also have 1 vote for the 4 proposals, and do you anticipate that there is room for changes for the existing proposals? Thank you.
Thanks for the question. It's a kind of one of these critical, hot questions, because we have 176 countries. Greece has to follow the policy of the EU. That means the decisions of maybe Netherlands and Germany. We cannot deviate. We don't decide. But you're right, Tuvalu and Kiribati and Vanuatu and etc. have same. What I see is a fight between the Chinese, the BRICS guys, and EU. These two guys are going to prevail. And inevitably, a lot of countries support the Chinese proposal as well. Latin America, a lot of developing countries, Africa. So it is going to be a compromise. In my opinion, what I see is the disappearance of the levy. And this is just a prediction. And then the two proposals, the two strong guys are going to agree on the fuel intensity. So what I presented, more or less forget it. Forget what I presented, because there is nothing defined yet. Remember the story of locking. The doors will be locked by Mr. Dominguez, and see what happens. It's going to be a very interesting meeting in April, and two intercession working groups preceding that. So it is, what I can say, a boring, long days of deliberations, and hopefully we're going to have a result. We cannot afford not to have a consensus. We must have a consensus, because I believe it is unfair to pay taxes 2 times. I'm looking forward, and I pray that the regional regulations set by you are going to disappear after 2027. This is the reasonable thing to do. Thank you.
Thank you, Dr. Kokarakis. One question for Mr. Shaw. Apart from redesigning the propeller, what can you do for the less rich ship owners regarding with their existing propeller? Will trimming be a solution for them?
A less rich ship owner? Trimming is always an option. What you mean by trimming is taking away some of the trailing edge of the propeller. What that primarily does, and we have our own company that does that within our group, Stone Marine Shipcare does that around the world. What that does is increase the light running margin of the ship. So as the ship gets dirtier, typically, and over time, its light running margin reduces such that the engines overload. You can maybe gain 1-2%, maybe 3% of light running margin back from trimming, but trimming will not assist in an engine deration situation typically. It's not substantial enough to do that. If you're looking at an engine deration, you need to re-optimize the system. So yes, for the less rich ship owners, if they are struggling with engine overloading, they can trim the propeller, but if they're looking at a thoroughly engineered deration situation, then they need to be looking probably beyond that.
Thank you. One question for Mr. Kyriakou and Mr. Paleokrassas. Yesterday I asked ChatGPT what will be a solution which is not going to be very expensive for bulk carriers, what kind of energy-saving devices they propose. And they said for bulkers, they propose a combination of PBCF, pre-swill duct, and advanced hull coatings. Do you agree with that, or should we go for something more specialized to get a reply?
Are we dealing with rich ship owners or ship owners that are impoverished? I think, as I mentioned in my presentation earlier on, it is most unlikely that a single selection of an ESD will provide you with a desirable outcome. Therefore, it's hardly surprising that ChatGPT, that I use frequently to fill with a lot of information, has actually given you the answer that we desire. That means, yes, realistically, you will have to consider the PBCF or hopefully the ERMAFEST flex cap. as a solution, because that immediately will provide you with savings. The introduction of pre-swell devices and other DACs will also do the same. And ultimately, Mr. Paleokrassas will be able to measure it and prove to you that your investment has been worthwhile.
Yeah, I mean, just to chime in myself, I would say that for me, having gone through the retrofit process from the ship owning side, I think the most critical part is doing a proper study, not just picking something off the shelf and basically just accepting the marketing stated savings. This is the one end, and then of course the other end is installing a proper performance management system so you can actually measure the savings, measure the value, and ultimately your ROI as a ship owner, as an investment.
Thank you very much. Are there any questions from the floor? Mr. Tsalapatis. You can use the microphone.
You have indicated that the retrofit you mentioned from 6 blades propeller to 5 blades propeller. And of course, the engine, as I noticed, it was derating. However, I have a question. How you can propose a 5 blades propeller? Do you have investigated the vibratory behavior of the 5 propeller in relation to the hull?
Yes, when we're looking at a feasibility study in the very first instance, obviously we take the ship data that we're given by the ship owner, and that typically includes model tests. It might include some CFD analysis that's been done, and we will actually run calculations based on a number of propeller blades. And we will look at what the outcomes of those are before we then suggest an optimal solution. Typically, if we are looking at changing the number of blades, then we'll also be looking at a torsional analysis as well to make sure that we're not going to be in trouble with the damping on the system. So in answer to your question, we look at a range. We have looked at 3 blade up to 7 and 8 blade. And then we will look at what the results of the efficiency improvements are through that, and then propose a solution to the ship owner. Thank you. You're welcome. Good question.
Yes, Mr. Zachariadis.
I have a question for Mr. Leira. What is the extra capital expenditure of your scheme compared to a conventional engine room, without considering the benefits, of course, the payback?
Yes, that's also a very interesting question. 2 weeks ago, I was in Korea meeting all the 3 big shipyards there and discussing exactly that with them. I would say from our side, we don't really see that there is a large capex deviation. Maybe $2-3 million from our side, but the shipyards are claiming more because they are now turning out a huge number of 2-stroke ships like a factory, and they don't see any point of or they have a willingness, not a strong willingness to change, but they indicated some, I would say, 5 million plus.
Okay, thank you. Mr. Chairman, would you like my prediction for the midterm measures at IMO?
Yes, please.
Okay. So the money from EU ETS and FuelEU goes to the European states. The money for any IMO measure is going to go to IMO. Do you think the EU is going to stop so easily their own measures? I don't think so. So that's number one. Number two, on what's going to happen with IMO, especially now with the United States. The United States is always against the levy. And it's many people who are against the levy. However, you have to have a levy to give money to the small island states that's supposedly needed. But this is the thorny issue. They cannot agree on this. So, but they are going to have they need to have a measure to apply by 2027. So what's going to happen, in my opinion, is that they will agree to a fuel standard and they will continue the discussions on the levy. That's what I think is going to happen. So either it's going to be the fuel standard from EU or from China, but no levy for the time being.
Thank you. Is there any other question?
Okay, we will have a coffee break now. This is sponsored by ABS, and we should be back in 20 minutes. The second session is about improvement in efficiency and navigating the geopolitical turmoil in full gear. And we have a full reach session of speakers that will talk about these subjects.
Well, good afternoon, everybody, and welcome to this session of the Greener Shipping Summit of 2024. I will start by going a bit philosophical. Socrates in ancient Greece was saying about the three filters that one should apply in everyday life. First filter, he said, was the truth. The second filter was the goodness, and the third filter, which I think is very applicable to this session and to this summit as well, is called the usefulness. So I think that my colleagues here should demonstrate the usefulness of their presentation for achieving the results that we all want to achieve. And first of all, gentlemen, Mr. Matthias Reichmann and Mr. Giulio Corallo from Acceleron, they're going to start. And gentlemen, you have 15 minutes. Please go ahead.
Hello. Good afternoon, good day to everyone. Thank you, Christos, George, and Natasha for the opportunity to present for Acceleron, the company which did 2 years ago the spin-off former company ABB Turbocharging. As the delivery time for all the new green new-build vessel is long today, it's pivotal to improve the existing fleets today to achieve all the stringent target of the IMO we have seen today. To achieve these targets, there are two types of measures. The bigger ones with major conversions, with highest potential but also very high cost, and a very long off-hire for all the vessels out in the field. And then there are other types, which Giulio and me will present today. I will present the EPLO, engine part load optimization, and Giulio will present a FITS2 solution, a turbocharger flexible cutout system. These both measures are more simple, easy to implement. Okay, maybe less benefit, but the return of investment is quite nice once it comes to the projects. EPLO, engine part load optimization, is a product I'm very proud of being the product manager. Following the slides, I hope I can give you a very quick pitch for EPLO. And if not, I'm very happy that I can share a little bit my enthusiasm for EPLO. Under the presentation headline, you see hands-on. Under the headline of the presentation, you see hands-on. Engine part load optimization, I'm the product manager since the early beginning, and I can inform you that I'm so far followed every vessel which went for engine partlet optimization project. And I'm very happy to answer all your questions also later during the networking time. And the figures you will see in this presentation are not only promises, this is measured and proven on many, many projects so far. As a just quick nutshell for this product, it must be mentioned that we are talking about a fuel oil or CO2 savings around 3%. With this 3%, you can then combine this energy saving device with all the other measures you may see or have already seen today. As Accelleron, we are supporting not only the turbocharger, we are also doing this partlet optimization, and therefore we are applied on all two-stroke main engine on the market, as you can see with 1 or 2 turbos. So if you have more than 2-hour turbos, maybe Giulio has a solution for you later with his FITS 2. The idea is we take the existing two-stroke main engine, we do a derating, so reducing the MCR, the maximum continuous rating or the power of the main engine, and we then tune it for the part load, which is the demand for the future. Then, once it comes to the project, the turbochargers are rematched. I show you later a picture. And then we do the adaptation of the main engine to the new turbochargers parts. And now, this is the big difference between derating and EPLO. Our project comes from the turbocharger. There is no shims change needed for changing the geometric compression ratio on the main engine by means putting shims below the piston, and this would cause taking a disassembly of the complete main engine, and you need to do this cylinder honing. So in our project, we only change the turbocharger parts, and then we adapt the main engine tuning to the new turbocharger parts. So you see, the package is standard, but what we can do, a scope which is very individual. Again, the key figure takeaway is the 3% in CII improvement, fuel oil savings, fuel cost reduction. If you have special demands, we can also reduce the auxiliary blower switch point, as by default changing these parts will increase the scavenging air pressure. The payback time normally is 2 years, but sure below timing of 3 years. And then the simple and easy implementation. So you have seen we are talking about two-stroke main engines, and if we are diving deeper, they are really, really different once it comes to the main engine adjustment. At least we need to change the injection timing, and then you have several different variants on the market, like the MAN-MC engine with variable injection timing, mechanical or electronically controlled VITs. Then we have electronically controlled main engine, makes it much easier to do the commissioning, but much more complicated once it comes to changing of the software. So simple and easy, as we have enough time to prepare for the project. And once it comes to the commissioning, you can trust us, we will adapt the main engine to it. Just an example case, how it could look like in terms of 3 variants. What you see here is the specific fuel oil consumption curve of a standard two-stroke main engine built 10 or 20 years ago, optimized for the lowest consumption, around 70 and 80% of the power. Then we can change, for example, 1 or 2 parts on the turbocharger, increasing the scavenging air pressure. By help of increasing scavenging air pressure, we increase the compression pressure on the cylinders. Thanks to that, we can also adapt the injection timing for higher firing pressures. And these higher firing pressures, again, lead to the reducing of the fuel oil consumption. Variant number 1, 2 grams, approximately 1%, is an idea for a variant we can apply. The 85% derating is then to avoid the overspeeding for these smaller turbocharger parts. Second idea would be including also a compressor wheel, double the savings, or if we can also change the bladed shaft to a smaller size, then we are talking about this 5 grams, 3% on main engine consumption. This is just an explosion drawing of the turbocharger showing the air diffuser nozzle ring, compressor wheel, bladed shaft. Means housing, connection to the engine remains the same. We only exchange the turning parts, which are, by the way, stated in the NOx technical file and need a recertification. With this page, I only want to mention quickly, this can be done during a normal port stay and don't need to be done in a dry docking. First of all, we do the engineering and the turbocharger parts production approximately 6 months before a project. But once it comes to the start of the installation, you see we are taking 2 to 3 days for the TC turbocharger labor, and same time we do the engine adjustment. Sea trial can be done on the next voyage, so also this 1 or 2 days commissioning we can do during service and not additional off-hiring. And during the complete project phase, we then do discussions with the class for the approval. That's a quick overview for engine part load optimization, and therefore I want to hand over to Giulio.
Thank you, Matthias, and good afternoon also from my side. The second product we are going to present is FITS2. That means flexible integrated turbocharging system for two-stroke engines. So first, I would like to start with customer feedback, an important customer. They see first high pressure to decarbonize the market. They see stricter regulation, increase of costs, specifically for the fuel cost and the EU ETS. Then they see as a key value the flexibility of operation. We see different routes, longer routes, like the Red Sea, due to the Red Sea crisis, for example. And they need really solutions that are flexible. Another important point is regarding the crew on board. They see more and more tasks for the crew, and they want to have solutions that doesn't add so many tasks to the crew. And the last important point is the vessel off-hire. Has a really important and huge economical impact on the company side, and they want solutions that doesn't impact the vessel operation and doesn't add downtime to the vessel. So our reply on this is called FITS2. It's basically a dynamic turbocharger cut-out, cut-in system. What we do basically is to switch on and off a turbocharger automatically. So it's applicable for large engines, two-stroke engines with multiple turbochargers. To do it, basically we have a PLC, a control unit that has a continuous communication with the engine control system. We are able to read the engine load, the engine speed, and we can adapt dynamically our system. Regarding the flexibility, we have 2 key features. One is basically a fail-safe system. That means that even in case of failure or missing of any air pressure or electricity part, what happens is basically that we are able always to ensure that the customer is able to run with all the turbochargers. We have also a daily FITS2 gymnastic. We call it like this. Basically what we do is opening, closing the valves, is 1 cycle per day, and this is useful to avoid that the valves get stuck. Last important point regarding the vessel off-hire, we provide this as a turnkey product as Accelleron, and we implement it without the disruption of the vessel in operation. So after our proposal, we get the request to implement this product, but the request was to implement it during normal operation, so port calls. We did it, but of course, thanks to a really a strong collaboration between us and a strong team in Accelleron, very lean and able to really cope with all the uncertainties of the port calls. So just to give you an overview, this is the system, how it looks like. So we have 2 main pneumatic valves, then we have the control unit and of course all the cablings to enable the communication with the engine, with our control and with the valves. The activity is made in 3 steps. We do first the turbocharger modification to enable the cutout system basically, and this we do typically in the first port call. Then we leave the vessel sailing to the second port call where we do the main activity. So we install the 2 pneumatic valves, and then we install also the control unit and all the cables. Then the last step is the commissioning that typically started during the same port call and continues during sailing. So I would like to conclude with a success story now. We have a large container vessel with MSC that is sailing for more than 1 year now with our system. It's running smoothly, and then they are reducing their fuel consumption, and also they are reducing their emission. So to summarize, the values of those products are 2 mainly. So first is the fuel savings. So we can reach, if we consider an engine, a large engine, 2-stroke with 3 turbochargers, we can reach up to $110 per hour. Considering the main engine first, the auxiliary engine, because we reduce the use of auxiliary blowers due to higher scavenger pressure, and also we consider the EU ETS compensation. So with this product, we can have a competitive payback period due to these aspects. And the second key value is the flexibility. First, for the installation of the product, we do not disrupt the vessel in operation. And the second point is related to the flexibility of the use of this product. So no additional tasks for the crew. As I said, is fully automatic. And also the possibility to use or not use this product. We've also have these failed functions and also this gym function that avoid that the system gets stuck if the customer is not using it for a long time. So thank you very much also from my side. I think the question will be later on.
Thank you very much for your presentations. Very, very interesting, and also for keeping the time, or within time. Next will be Mrs. Helle Elberg-Duke, from a commercial product manager from MAN Energy Solutions, and she's going to present a paper, namely Digitalization to Improve Effectiveness and Adaptation in the Changing Worldwide Market. You have the floor.
Thank you. Welcome to my presentation on digital solutions that are designed to support your operation. When we say off-hire risk reduction, this is exactly what we aim to do, that by giving you insights in the operation, be able to react in due time and reduce the risk of off-hire. When we embarked this digital journey, we had a very clear vision that we wanted to go deep and not wide, meaning that as an OEM, we believe that digging deep into our domain knowledge and develop from there, we could provide you with the most value in the solutions that we bring. Since we introduced our first solution, known to more of you as PrimeServe Assist, the focus has been performance optimization. And we do this based on real-time data. We receive up to 500 data points per minute per engine. And for those unfamiliar with PrimeServe Assist, it connects the engines to a Mansion cloud. And here it's monitored by the Remote Operations Center in Copenhagen. The Remote Operations Center is available 24/7, giving technical guidance and are there to ensure that you have the support round the clock. And I just want to show you 2 features that we have released to this interface, because that's also a part of the PrimeServe Assist. That's visualizing the data points that is received from the specific engine. And last month, we introduced 2 new features. The first one is a fleet overview, giving you the possibility to monitor the fleet and benchmark the performance of your fleet, see which vessel needs the most attention today. And this is again done based on real-time data. Another feature is the document search, this is an integrated part of Prime Service Assist, and you simply write the issue. Here I wrote how to dismantle a piston crone, and the system provides you with the most relevant documents, searching among manuals and service letters and installations. So here you are provided with just the specific documents that you need. And early next year, a new performance interface will be introduced. Here, every single subscore is monitored, and you can see the performance of that directly, making it much easier to identify where could be potentials for optimization. Besides this solution, we also develop other solutions, either partly part of this or standalone solutions. Performance and efficiency is, of course, continuously a focus area. Alongside this, we also focus on maintenance, on operation support, and troubleshooting. These are the main areas that the development goes in. And with our experience, we also have two personas in mind. And depending on your strategy, one of them can be of your favor. There would be a virtual superintendent to support the technical organization on shore, and a virtual chief engineer supporting the chief engineer and the technical teams on board. I will show you a few examples within each category. In the performance and efficiency category, again we see a fleet view, but in this time it's MAN that does the benchmark across all engines of a given type. So if we see an issue coming up in an engine, and it's not specifically for this engine, but more for the engine type, and it's analyzed, then you will be warned in good time to take the right actions. We're also looking into, when it comes to lubrication score, into more specific algorithms that might be able to feed your own systems. With just one indicator, is my lubrication okay? So based on the data, it turns that into a simple indicator to see if everything's okay. And the same goes for the engine condition score. When we look at the maintenance part of it, then we are looking into forecasting a potential component breakdown. And that is by using AI and advanced algorithms, identifying the real wear of a component, so holding up the running hours together with data that we have from the specific engine operation over time, and estimate and forecast if anything is at risk. And if we consider a component to be at risk, then warn you in due time so you won't have a breakdown. And spare part planner goes within the same for a repair job to make sure that all parts are there at the right time in the right spot. The last, smell, listen, observe, it's a bit further out in the future. The idea is to have sensors installed that can register the smell, the sounds, the vibrations, all characteristics from the engine when it is brand new. So in the very beginning of the service, monitor and logging that to have a reference line on the characteristic for this specific engine. So at a later stage, just like an experienced chief engineer can smell or hear if anything is out of the normal. Operational service, that is more in general with the data-driven insights. You can design a better operational decisions for your entire fleet. Also, for instance, if the commercial department requires a special trade or load patterns, again, you can have the data served for that. The 3D animated instructions, for the time being, we are mostly using them as a training tool, but can see how well received that is when a complex situation can be more explained and more alive for the training. So this will for sure also be rolled out. One of the big things that we are looking into with the troubleshooting right now is image recognition of components. So here the experts are training the models in how does good look like, so we can have a vast database ranging from good over failing to very poor. And when you upload a photo, the model will take this photo and compare it, place it into this line, and you will have a feedback on what to do. Is this crack severe or is it okay? And automated diagnosis of data, it goes, we are moving again a little bit towards the chatbot, also when we say with the document search. So it's training models with the knowledge of all our experts to move it more into also being an automated support to you. This one is my personal project this month. We will, by the end of November, start a test of remote support. And the idea is that the Remote Operations Center in Copenhagen can have a live transmission from the vessel to the chief engineer on board, supporting directly from the Remote Operations Center with all kinds of different issues. The images on the left-hand side illustrate a handheld device in the engine room. It's independent of hardware, just need to have a microphone, a camera, and Wi-Fi coverage. And the computer is illustrates what we see in Copenhagen, and with notifications on the screen and with icons, the green one, we can guide the chief engineer to have the focus on the right places and then support them directly. This can be with a team of experts from Copenhagen, and of course, if it's one of your engines, it can also be with participation from the office. So everyone will then see what is on the PC screen, and we have running some tests. It could be, for instance, conditions of a component. Is that reusable, or is it how severe is this damage? It could be inspection of a scavenger port. So different things where the chief engineer could need some direct support. I've talked mostly about solutions that MAN is developing based on data and based on domain knowledge. But many of you have also own programs. And this is just to say that the data can, of course, also be exported to the systems. They come in two different packages. There's raw data, which is essentially the measurements from the sensors, and also process data that are values of results of the calculations. And as I briefly mentioned earlier, it can also be a specific algorithm giving you an indication of something that you would like to follow on one of your engines. What I have not talked about is cybersecurity, but as a closing remark, I just want to say that cybersecurity is, of course, an integrated part of all the design we do. It's not an afterthought, and that goes all the way from the hardened hardware on board to encrypted transfer and to professional hosted platform. And we are on this journey together with you, so we also like to cooperate and have input. Thank you very much for your time.
Thank you very much for your presentation. Next speaker is Mrs. Eliana Apostolidi from Lloyd's Register. She's going to talk about measuring digital maturity in maritime. I'm very curious to hear what she has to say.
Okay, so it's a great pleasure to be here with you all today to talk about digital transformation, digital maturity, and the links with efficiency. Actually, I was very happy to see efficiencies as a topic in today's program, and somebody can argue that digital transformation can definitely lead into efficiencies. But I'd like to take a step before that and say, in order to be able to talk about efficiencies and in order to be able to talk about digital transformation, it's important first to be able to measure. As the saying goes, if you can't measure it, you can't improve it. And the case is no different for digital transformation. So how digitally mature are we really, and how can we measure that? Because obviously there is a lot of talk about digital transformation, but there is no structure around it. Digital transformation is already here. As an example, just the AI, artificial intelligence maritime market, has tripled in the last 12 months, exceeding the $4 billion. So obviously, the maritime industry, although considered relatively more traditional to a certain extent, is already embracing this new technology with remarkable enthusiasm. But with tech come questions. Are we ready? What's the right next step for me? How can I make most of it? Obviously, there is an abundance of solutions, but what's the right next step? And the question remains, I guess, how digitally mature are we? Shipping companies are already on a digital transformation journey, but where they are exactly on this journey is very unclear. This is because the digitalization in the maritime industry is highly fragmented, and at the same time, there is an absolute lack of benchmarking. By not knowing, the risk is that we may stay stagnant in a moving competitive landscape where competition is moving really fast and technology runs really fast. And by not knowing, we also risk not knowing what's the right investment for me, because my digital maturity level is to a certain extent my investment readiness level. So what's behind the heavy term digital transformation? Digital transformation is not just about technology. Digital transformation is about process, technology, people. Process is about changing the way we do something. Technology can underpin a meaningful process shift, but it will all collapse if people don't feel engaged to deliver a digital transformation. So if we were to develop really a model to measure digital transformation, what should it look like? What would be the main enablers to consider? First and foremost, we would need to think of a digital strategy. The strategy is no different than saying why we need to do something, what is the right thing, in what sequence, and how it all comes together for a meaningful outcome aligned with business objectives. Then, of course, the human element. No matter how high the investment in technology, if you have unengaged or even threatened by technology employees, it will most likely going to fail. At the same time, a data-driven, collaborative, and cybersecurity-aware workforce can make a huge difference. Then we need to consider digitization, standardization, integration. How do we keep essential information in digital or hard copy format? Are our systems interoperable, and in other words, do they talk to each other, ensuring smooth data flows, or no? Then connectivity. There are already solutions in the market that have significantly increased vessel on speed, making it a critical player on a company's digital transformation, if not the protagonist, let's say. Cloud storage and computing, where do we store data? In the cloud or in local servers? And of course, all the cybersecurity aspects that come with it. This could be the so-called enablers, so without those, any further investment in digital transformation technologies will most likely struggle or not realize its full potential. For example, imagine of a company that wants to install sensors on the vessels with poor connectivity. It will most likely not going to work as expected. Similar is the case with all the other fundamentals you see on the screen. Then moving on, we would need to consider the digital technologies that are already here and have already started reshaping the way we operate in maritime. Here we have AI and analytics that has the opportunity to process vast amounts of information and convert them very, very quickly into meaningful outcomes. Automation that can be as simple as using a company's ERP to automate some reporting and can go to much more advanced applications like hull cleaning robots or even autonomous vessels. IoT devices, in other words, do we have sensors on the vessel transmitting real-time data, or we have crew manually submitting this information? Virtual reality that brings new aspects in crew training, navigation, and more. And a little bit futuristic for today's business environment, but already here, digital twin, a virtual replica that in its dynamic format can even enable us to test how the vessel would respond in certain scenarios using simulation software. And again, a little bit futuristic, but for sure already here, blockchain, that once we have this fully implemented, it has the opportunity to completely change the way we do contract management, bunker track and trace, supply chain monitoring, and more. But how does it all come together? In Lloyd's Register, we believe it's our role to support this digital transformation by fostering collaboration and driving transparency in the market, of course, connecting all the dots. So we took the last year or so to work on developing a model that can help companies assess their current digital maturity level. Always with the overarching main enablers in mind, we also worked on developing almost 50 maritime-specific use cases, so actually taking examples from day-to-day operations, making sure that the model is relevant to the maritime industry, and then assessing how the digital technologies have already started revolutionizing the way we operate in maritime. The outcome, it's a digital maturity framework, an index, that has the form of a self-assessment exercise. The exercise is open to all shipping companies, and the platform has just opened for the Greek, Balkarian, and tanker community, and of course with more segments and more key locations following right after. Once a company has the opportunity to take this exercise, the self-assessment exercise, they have the opportunity to better assess where they are against all key aspects you see on this screen, and eventually has the opportunity to generate a scorecard, actually a report that helps them see what is their current rating in a defined scale, and how they also compare with the industry. To take a closer look into this one and understand what's behind the value of benchmarking here, here you can just see the 6 main enablers we just spoke about. Somebody can see how they currently perform. This is the orange line. In the purple line, you can see how the industry performs. So it's easier to understand if you are ahead or behind. At the same time, the model is designed in a way to let you know how far there is to go. Eventually, somebody can make better decisions by understanding where they currently stand, and at any time can monitor performance also versus peers. And this can eventually help us understand where we are in the digital maturity spectrum that in the specific case could range from foundational to visionary levels. It's important, however, to say that this is not a race towards a maximum score. Each company is different, has different dynamics, different strengths, opportunities. It is, however, an effort to use data in order to reach thoughtful, tailored digital advancements. In closing, digital maturity is not about reaching a fixed point. It is about, it's an ongoing effort towards growth and adaptation. However, knowing where we are allows us to identify the most impactful steps forward. Eventually, each company is going to have a unique journey towards digital transformation, but all these journeys together, collectively, help us form a stronger, more digitally advanced maritime sector. On your great question, Mr. Hadjigeorgiou, about the usefulness, indeed, whether this framework we propose to start putting some structure around digital transformation or no is useful or no, I guess it's something that the esteemed audience in this room will have the opportunity to respond to in time, and we will be here to get the feedback and act accordingly. Thank you for listening.
Thank you very much, Ms. Apostolidi. Next speaker is Mr. Stavros Sklavounos of Hempel. He's going to talk about full picture hull management. Mr. Sklavounos.
Thank you very much. Good morning, everyone. Can you hear me? And I'm Stavros Sklavounos. I'm Hull Performance Solution Manager from Hempel Coatings, and today I'm going to talk about full picture of hull management. Starting from something that most of us here are already aware about, the fact that how biofouling is actually affecting vessels' operations, vessels' efficiency, and how important it is to address that 40% of your vessel spends most of the time below water, is susceptible to wear, deterioration, and biofouling. And we know that biofouling increases both fuel consumption and greenhouse gas emissions in one hand, but also on the other hand, biofouling on ship's hull is actually the largest vector for the introduction of invasive species. So the industry currently is sitting in a very big dilemma on how we can counterbalance anti-fouling performance in coatings, and also how coatings can reduce operationally the emissions of the vessels due to fuel consumption, but at the same time be able to minimize the environmental impact that we see from coatings in terms of either VOCs, in terms of polishing biocides and microplastics in water, and of course from the waste material that is a byproduct of cleaning operations. In this framework, we believe that it's really important to address and identify, first of all, what is pragmatic, meaning that we need to find solutions that first of all can work, can effectively address the biofouling management needs of most of the worldwide fleet out there, but on the same time being able to do it in a way that we are also reducing the in-water emissions mainly at this point. And by that, I think that it's really important to provide to the whole industry, to the whole ecosystem, solutions that are proven, that are also backed up with performance data, and that can be actually utilized so that everyone can make better decisions based on data. In this respect, I would like to say that we are proud to have a technology based on silicon. Actually, it's a combination of silicon technology with hydrogel and biocides, which have been proved for the last 10 years to be the one that has been most consistently delivering the best results in terms of fuel efficiency and biofouling protection for the vessels out there. We have been very recently validated by DNV about our performance claims, meaning the annual speed, the 5-year speed loss that our Hempagard series can provide to a given vessel in the in-service period. We have also been validated about the silicon effect, or what we'd like to talk about as out-of-dock effect. So how can the superior surface properties of silicons actually provide instant savings when compared or upgraded from a previous self-polishing coating. And also you can see that in the 5 years period, in a service period, an average of 19% in fuel savings is expected when comparing such a scenario, such a coating, with a market-based, with a market average SPC coating. At the same time, we have more than 4,500 applications in all major types of vessels, showing and illustrating at least for the last years, and highlighting something that has been a main blocker or a challenge for most of the ship owners out there, that silicons have been proven to work only in specific types of vessels or only specific trades. And we would like to highlight the importance of the advancement that we were able to do in the technology with the introduction of biocides, secures that a vessel with a silicone coating can still perform, of course, when sailing, but also can very well protect the hull from biofouling, even during very long idle periods. At the same time, as we said, in one hand, we have a proven solution in terms of what it can deliver in the part of, let's say, air emissions reduction. And we are also really proud to be able to manage to achieve that with a solution that actually, when it comes to biocide content, which is one of the most important, let's say, in water emissions coming from the hull coatings these days, we can see that the biocide content in our silicone solutions actually are 90 to 95% less than when we could compare it with an SPC coating, even when we talk about what is called premium tier coatings, but still self-polishing coatings. So right now, we are able to provide a solution that can address the two important needs from the industry. And we really believe, and we're really also working on how to further optimize these technologies. Very recently, we have managed to make Hempagard's technology and make it go one step further with a new product that utilizes both a biocide containing layer, but also a non-biocidal layer. It's actually the one that you can see with the least amount of biocides, meaning that we are in a track where we can continuously reduce the biocide content and also increase efficiency and ability of the coating to manage biofouling in vessel's hull. The next part around hull coatings, which I would like to touch upon, and in the previous session we had a lot of discussion about energy-saving devices, and I think that in most people's perception nowadays, hull coatings sit somewhere in between, let's say, energy-saving devices or operational measure. I think it's really important, and it's one of the key activities that we're trying to do in Hempel, is raise awareness in the whole ecosystem that silicone hull coatings can actually provide what we call before out-of-dock savings, meaning that they can immediately improve the efficiency of the vessel in the design, let's say, in the design efficiency of the vessel, whilst at the same time they can also provide what is the traditional, let's say, expectation from a hull coating, which is to minimize or better manage the biofouling protection of the hull. And in this respect, we are actually trying several channels through which we are trying to promote this concept. One of which actually has to do with the importance of low friction coatings, regardless of the type of investments that owners are willing or deciding to take when it comes to energy efficiency. Here you can see three different scenarios which I would like to highlight. So the upper graph actually shows a scenario where someone, an owner, is deciding to invest in an energy-saving device, call it like newest duct or whatever this might be, which is expected to deliver a 5% immediate reduction, immediate power savings, and they still go with what I would like to call business as usual when it comes to coating, meaning that they are not decide to invest in a better coating at the same time. And we can see that if we actually assume that 2026 is, let's say, the first year, it's the application time or the installment period of the ESD, we can see that the vessel is starting with an increased efficiency, a minus 5% in terms of power required to achieve a certain speed. But we can see with, let's say, the evolution of speed loss, of performance over time of a medium tier coating, that this 5% is almost eliminated within the first 1.5 years after the vessel's operation. And in 5 years' time, it is expected to reach an approximately 14% of added power compared to where the vessel was in terms of performance when got just out of the dry dock. In the second scenario, in the middle figure, you can see actually how a silicone coating can provide immediate power savings. This is what we call the 6% power savings, which are coming through the surface characteristics of silicones versus SPCs. So at the same time, with the application of a silicone coating, we can get an immediate power reduction, an out-of-dock effect, as we call it, and at the same time, with the very low speed loss and coating's ability to manage biofouling over time, we can see that the power penalty within the 5 years is minimized compared to the previous scenario. And lastly, if we are, let's say, to do the ideal, which is to combine a low-friction silicone hull coating with another ESD, then we can get significant savings right out after the dock. And also, we can see that we can maintain the effectiveness or the efficiency of these devices along with the coating and minimize the power penalties over time. So this is one part of what coating can do. We know that coatings are considered nowadays one of what we want to call them low-hanging fruit in terms of vessel's efficiency, but there has been a very important obstacle or challenge up until now, which is how you can verify the coating effect, the out-of-dock effect, as we call it, of a vessel, and attribute it to vessels either decarbonization indexes or performance indexes. And in this respect, we have been trying to reach out to all stakeholders within the marine industry, regulatory bodies, and not only, in order to try to promote methodologies out of official sea trials, which is, let's say, up until now, the only acceptable methodology to verify the effect of a coating in a vessel's index. And actually, through this way, incentivize ship owners and operators to adopt further, let's say, upgrades in better quality paints for the vessel's hulls. And as part of these, let's say, activities, we are very happy to have been part of a collaboration success story within the maritime industry. Over the last 1.5 years, we had an open workflow with RightShip about actually how we can further incentivize ship owners, adopt quickly better coatings and technologies that, first of all, are proven to work, but also they are not that easy nowadays to address their effect or impact on vessel efficiency indexes. Yes. So, RightShip last Wednesday has actually introduced new guidelines for how owners can verify the coating impact, the low friction coating impact, on existing vessels design index for RightShip and subsequently their GHG rating. And we have been very proud, to, as I said before, to be the ones that have been working very closely with RightShip and our partners, Hydrus Engineering, in this work stream, so that we have, as I said before, with the common guiding star being how we can accelerate things when it comes to adoption of sustainable technologies and decarbonization, created a framework that right now bulker owners can be rewarded for their investments in better coatings without the needs for official sea trials, but with a procedure that actually is coming from numerical calculations. I would like also to highlight that we were one of the first, or the first coating company to address that every case for us is a vessel-specific case, meaning that whatever we have to propose actually should be fit for purpose, is coming from addressing different needs about ship design, trading areas.
30 seconds.
Operational profile. And then we can provide some ship-specific assessments for each and every vessel about how upgrading coating can impact all the aspects related to the vessel. And last but not least, I would like to highlight very quickly that nowadays it's more than coatings or products that we as Hempel or coating suppliers are expected to offer. So we have a set of different services that begin from the pre-sales, let's say, stage down to the whole in-service period on how we can better support you and advise when it comes to optimum solution for hull management. Thank you.
Thank you very much. Thank you very much, Mr. Sklavounos. The next speaker will be Mr. Philippos Spyris. This will be done through Zoom, and he is going to talk to us about always clean hulls, sorry, I cannot spell it, vessel efficiency, revolutionizing, by combining low-friction hard coatings with grooming robots.
Thank you. Thank you very much. Good afternoon. First of all, I would like to thank Mrs. Vasilaki for the flexibility. It was a last-minute change because I was tested positive for COVID, so I was not able to be there in person. But at least it's good to be able to connect remotely. So the idea today, I would like to continue to the same topic of hull management. The purpose of this presentation is to explore the concept of combining low friction, graphene-based coatings with hull cleaning robots, and basically focusing on what Mr. Hadjigeorgiou mentioned in the beginning, the usefulness of this. And the term grooming here in the title refers to the periodical removal of slime before it develops to fouling, harder fouling. This is a relatively new practice in the market, so I will try to define what grooming is and how it basically addresses the limitations of traditional cleaning practices and also the environmental risks. And especially this is important when it is applied on a coating that it is mechanically durable and biocide-free. I will try also to look at how this concept is aligned with the regulations and the standards that are evolving right now. And in the end, we will try to go a bit deeper into the practical side, meaning how a hull grooming program can be implemented, given, of course, the complexity and the challenges. Now, just to define the problem we're trying to solve here, biofouling, of course, is a natural process. It's an old problem. Organisms like algae and barnacles, they accumulate on ship hulls, and this leads to significant drag and increased emissions and fuel consumption, of course. What is interesting is that it all starts from a very thin layer of biofilm, slime. This is called microfouling because it's mainly microorganisms, like the primary species, basically, that first settle and adhere to the hull. And this can be formed within weeks after the application of paint, and also acts as a foundation for the development of a bigger community of microfouling. And this, of course, can contribute to significant fuel penalty and increase in emissions. Of course, this is very well documented in the industry. The key question for us is how we can intervene early in the process, how we can tackle the problem right from the beginning. Traditionally, we have relied on basically coatings to do the job. The thing is that even with high-performance coating, it may fail under certain conditions. And from our experience, there is a gap between the expectations from the performance of the coating and the reality of the operation, which can be unpredictable. And this is, of course, where cleaning comes in. The problem is that we have three main challenges with cleanings. First of all, cleanings typically are done reactively. So this means that they are done when the vessel has already, when we see drop already in the performance, and when we have already hard fouling. You can see on the graph within year one, 20% power increase due to the bifouling penalty, and then it goes up to 40% in year three. The second challenge is that we basically clean coatings that are not designed to be cleaned. For example, if we clean self-polishing and defouling, we may have a short-term improvement, but we are basically removing part of the paint, including its biocidal content, so we lose the thickness and we lose the defouling property. And at the same time, we increase the roughness because the paint is damaged to some extent, and we see faster growth of fouling. And the third big challenge here is that the vessel relies on divers with all the limitations that come with it, the availability of the divers, the incompatible brushes for the coating in use, the port restrictions, and also, of course, the safety concerns. Today, there is increasing pressure from regulations to move away from biocidal antifouling coatings. The reason is that, of course, there are concerns over the water pollution from the release of copper and the toxic substances, the microplastics. This is due to the working mechanism of the self-polishing antifoulings, but also due to the repeated cleanings of hard fouling, which is the norm in the industry. Korea is at the front of these regulations, and practically from 26 onwards, there will be no applications with self-polishing and defouling. In Europe, we know that the BPR, Biocide Products Regulation, is currently reviewing existing active substances for renewal for 24. So we may soon see restrictions or even bans of biocides used in commercial products. So the trend is basically started to influence the IMO as well to take similar measures on the global scale in the future. But also it's a signal for us, paint makers and ship owners to think out of the box and invest in environmentally friendly alternatives that not only address the CO2 emissions, but also the protection of the marine ecosystems. Another key trend that we see today is a major shift in the industry towards a more proactive approach. And this comes with standardization around biofouling management and also new technology. The biofouling management guidelines from IMO is targeting basically the spread of invasive species, which emphasize the need for a proactive approach with frequent inspections, so we have more chances to detect early stage fouling. And at the same time, there's a distinction between microfouling, which this is a fouling rating 1, as you can see on the screen. And this is where proactive cleaning is recommended. And also macrofouling, which is rating 2 and above, where capture and disposal is required. This is an important first step towards global regulation, and these guidelines will be updated very soon. And the second step in the same direction is two ISO standards that are in progress right now for in-water cleaning, and that will help us have some guidance on conducting and, of course, planning the operation as well as testing the in-water cleaning systems. At the same time, technology seems to be outpacing the standards and the regulation. A lot of startups emerging right now, working on solutions for proactive cleaning with robotic systems. Now, how is grooming different from traditional cleaning? Grooming is basically what you see on this video. We're talking about the proactive removal of microfouling even before we see a drop in the performance. This is basically a grooming operation with a robot using soft brushes on a graphene-based coating 3 months after the application of the coating on a bulkhead. And this, as you can see, restores the coating back to the initial clean condition. Graphene-based coatings are particularly suited for this approach, proactive cleaning, because they are mechanically durable, so there is no degradation after repeated cleanings. The coating stays intact, so there's no thickness loss or roughness increase after this grooming operation. And at the same time, the coating is biocide-free, so there's no risk of water pollution. This is, of course, a completely different concept from reactive cleaning of biocidal coatings that, of course, comes with the negative effects on the coating and the environment. And, of course, in many ports, it is required to capture and dispose. Now, if we adopt a proactive approach with grooming, we also need to have the right coating in place that can maintain its performance before and after cleaning operations. How to ensure that? This is important because we may be talking about the frequency of every 2 months or every 3 months grooming on the hull. So we're talking about the integrity and the longevity of the paint. Lloyd's Register has very recently introduced a new enhanced type approval specifically for this. And at CIT, we are honored to receive the first one. And this was done after extensive testing, simulating years of grooming with different technologies. So what the approval is saying is basically saying that the coating will maintain its performance before and after grooming, provided that the frequency of grooming aligns with the operational conditions and the risk of biofouling. This is a ship-specific exercise, of course, and it's also aligned with the specified brushes or air cavitation that will be used in this case. Grooming is about the operational efficiency of the vessel, which is basically about maintaining the fuel savings that we can get after the application. So the low friction effect is very, very important. That was described very well also in the previous presentation. In our case, this effect of the low friction has been measured and validated based on experimental and also actual vessel data. There was a flow channel experiment at the University of Strathclyde where the graphene-based coating showed the lowest coefficient of friction compared to traditional paint, and this study is publicly available for those who want to explore further. On the right side, you can see just an example of comparing speed and consumption 6 months after the application of the paint compared to the same period after the previous dry dock with traditional paint. And this is where we see 9% fuel savings across the speed range consistently. And this was also done, used to revise the charter party description. Generally, we see very low average hull roughness values, which can translate to significant gains. And now with the guidelines from Ajax on using the coating for EXI, the average hull roughness measurements can be very beneficial, specifically for the pre-EEDI vessels. So our vision for the future, just to sum it up, we're aiming at a solution which basically ticks all the boxes here. Low friction, minimum degradation over time, zero biocides, and at the same time, no downtime for diving operations. And to achieve this, we focus on two key components. First, our graphic-based coating based on patented hard found release technology, which is basically a hybrid that combines the smoothness of soft foul release coatings like silicone with the mechanical durability of the more hard coatings, epoxy-based coatings, so that the coating can be repeatedly cleaned with no paint damage or degradation. The second pillar here, of course, is a hull grooming robot, which is operated by on board by the crew, and this is provided by our approved partners. The idea here is that we have frequent inspections, cleanings on microfouling, and we have a hull which is near to clean condition always. The work is done in port or in transit, and it's done remotely via Starlink or operated by crew. This depends on the technology. The robotic technologies come each one of them with their pros and cons. There are different technologies out there with different maturity level, I would say. Most right now will require some level of crew involvement. The typical semi-autonomous setup is that we need one crew member operating with a joystick the robot, and another one who should be handling the cables. A time for a 200-meter vessel, just to give you an indication, we're talking about 1 or 2 hours for inspection and 6 to 8 hours for cleaning per side. And of course, these robots are able to keep a record log of all the inspections. So
one minute, Mr. Sviris.
Yes. So we can later use with the port authorities. Now, the last one here, this is how we see the implementation of a hull grooming program. For us, the key is to address the two main challenges, which is the human factor, crew involvement, and also the operational feasibility. This requires close collaboration from all the key stakeholders. In terms of the operational feasibility, we do have a structured approach for planning and supporting the operations. I would like to emphasize that this starts even before the dry dock with the assessment of the biofouling risk, which basically defines how often we need the cleanings on the vertical sides and flat bottom. And of course, while in service, we are providing continuous support with fouling warnings, analysis of inspections so that we can adjust the grooming program. At the same time, real-time advice on when and where to clean based on the future port calls. Now, performance-wise, this is what we basically expect from the scenario of graphene-based coating, groomed every 3 months. As you can see, we have the out-of-dock power savings, and then when we reach the threshold of slime, the FR20, as we call it, in the fouling rating, we proactively clean, so there's no paint damage or delamination, so we have an always clean hull. Now, a few things on the company.
Mr. Sviris, please conclude.
Yes.
You're out of time.
Yes, thank you very much. I will conclude now. JIT Coatings is a small, very ambitious company in the marine coatings market. Headquarters in Canada, global presence in the key shipping hubs, stock points in China and Turkey. We started with propeller coatings, now moving to hull coatings, and the mission of the company is to drive change with more sustainable hull solutions with biocide-free coatings. Thank you very much.
Thank you very much, Mr. Sviris, and hope for a speedy recovery.
Thank you.
The last and final speaker for this session is Mr. George Margelis from Tsakos Shipping and Trading. he will talk to us about energy efficiency measures. Mr. Margeridis, you have the floor.
So the subject of my presentation has to do with the measures we implement in the Tsakos Shipping Company in order to enhance the energy efficiency of our vessels. The decarbonization strategy of the company is aligned with the IMO 2030 carbon intensity targets, and we also want to pursue a net zero greenhouse gas emissions by about 2050. In order to implement our strategy, we have various actions that we take. So the first one has to do with operational and technological measures implemented on board company vessels that I'm going to develop in the next slides. We also have established a pathway with the use of the transitional alternative fuels. And finally, we participate in research projects which have to do with neutral greenhouse gas emissions. So at the end of 2030, the company had achieved about 20% reduction of carbon emissions per transport work with respect to the IMO 2008 baseline. In this slide, you can also see per type of ships that the company has, the results that have been achieved. So let me start with the very basic initiatives we have started implementing throughout the years. So the first one, a couple of years ago, was certification under ISO 50001 for energy management systems. We created a very sophisticated energy management plan. We established various energy performance indicators, an energy department with appropriate number of personnel. So this is how we started many years ago, about 8-10 years ago. What we consider very important is to change the mentality of our seafarers and shore personnel. So we have established a very detailed and analytical energy management training where everybody, all seafarers, are getting trained before going on board, and shore personnel also. And we try to verify that they know what we want to achieve with respect to energy efficiency. They know what they have to do on board the vessels and what our targets are. So some operational energy efficiency measures that we implement are very much implemented by all companies: just-in-time arrival, selection of optimum speed, weather routing and voyage optimization, trim optimization, and for tanker vessels, optimized cargo heating management. So for just-in-time arrival, the coordination with the charterers is required. Sometimes there are sub-charterers. So this program, a couple of times, is difficult to follow and have the results that we want. For weather routing, we use a very well-known platform with a couple of thousands of ships in their database, and they claim that we have fuel savings by using their optimized voyages. Trim optimization, we have a special software developed by DNV through computational fluid dynamics. It's applicable to a number of company vessels, and we estimate that it gives a benefit of about 2 to 3% on the ballast voyages when we follow the suggestions of this platform. We also performed cargo heating optimization, so the auxiliary boilers are used at the optimum number of hours in order to save fuels by keeping the required cargo temperature. Other operational measures that we implement have to do with underwater maintenance. Mr. Spheris, the previous presenter, talked quite a lot about it. So our strategy has to polish the propellers twice per year, about every 6 months. Simultaneously, we do with divers underwater inspections, and we assess the hull conditions. Now, for vessels equipped with telemetry systems, we continuously measure any power propulsion increase requirements, so we know the fouling conditions. For vessel older ones that are not equipped with telemetry system, we do perform speed tests underway The vessels are obliged to do it every 6 months. And also, we have developed our own biofouling inspection device. You can see it at one of the photos at the bottom with a camera, and the verticals of the ship can be inspected anytime by the crew members. So we have seen that with this policy, we gain a lot of fuel if we implement it strictly. We're also examining the use of robotic instruments, the renting of such robotic instruments that will be positioned on board company vessels and will be handled by seafarers. Other operational measures have to do with main engine performance evaluation. This is done through the manufacturer of the main engine. We mainly use MAN, so it's a conditions-based monitoring tool. We also have auxiliary engines load management. This program concerns the use of the correct number of auxiliary engines. We don't want the vessels to use more auxiliary engines than are required. And we also monitor the thermal efficiency of the auxiliary boilers of our vessels. With respect to alternative fuels, we use biofuels up to B30, and also at dual fuel ships, we use LNG. So there are also various technological energy efficiency measures that we implement. Of course, is shaft power limitation systems. All companies use such systems in the context of EEXI. We have installed various energy-saving devices on board company vessels depending on their trading profile and design. So we have installed a couple of propeller ducts, rudder bulbs, rudder fins, which also save some fuel. With respect to anti-fouling paintings, which was discussed a lot at the previous presentations, for the time being, we use ultra-low frictional resistant SPC paintings, but we also examine the application of more advanced paintings. We have installed variable frequency drives at the seawater cooling pumps and at the exhaust fans and intake fans of the engine room. And we have a program for replacement of the old volumetric flow meters with newer mass ones. Another measure concerns the installation of manufacturer of main engine devices, two devices. It's PMI adaptive cylinder control and EcoTorque. So MAN claims that we gain something like about 1.2 grams per kilowatt hour by using these two devices out of the specific fuel consumption of the vessels. The first device ensures that each cylinder operates at optimal cylinder pressure, while the second device stabilizes the torque, ensures stable fuel index, and the operation of this engine is within a specified speed range. Our main focus is the new building vessels. So all new building vessels from now on come as dual fuel LNG. We have optimized hull and propeller design. They come with as-built installed energy-saving devices, propeller boss cap, rudder bulbs, fins, etc. Most vessels come with shaft generators, variable frequency drives, and at container vessel, we have installed shore power connection systems. Now, decarbonization cannot come without digitalization. So the most important tool we have, it was built in-house since 2017. So we have a very robust ERP platform that includes modules for vessel performance, monitoring, analysis. Is the most helpful tool we do have, but also we use a number of other softwares and platforms for real-time monitoring of alarm monitoring system for deck equipment, intelligent navigation system, integrated
30 seconds,
system.
please.
Thank you. Prime serve of MAN, and we have telemetry systems installed on board a number of ships. There is the Tsakos Performance Center where all output data from software comes there and is the center of the operation of the company. And final, last slide has to do with our participation in research projects. So we are developing an in-house weather routing and vessel optimization platform. It is based on artificial intelligence and machine learning algorithms. We are partners at the EU Horizon or Shell project for wing sails, and we have developed a Nobel Boss cap design for enhanced propeller performance. Thank you very much for your attention.
Thank you very much, Mr. Vangelis. Now it's time for questions regarding all those very, very interesting presentations. Sir.
Hi. For the graphene coating that was shown earlier, what is the performance in terms of mechanical damages? I don't know if you mentioned it at all, but if that's, is he still available to answer the question, or?
Yes, if you can hear me, I can answer, Mr. Hajigeorgiou.
Yes, yes, please.
Yes, of course. Well, basically, the coating is designed to be cleaned, so there's no paint degradation. There's no mechanical damages, and one of the major investments from our side was to do a number of grooming tests. So we basically have done a number of accelerated tests with different brass types and different pressure from air cavitation technologies. And we were looking at a number of parameters like roughness, glossiness, thickness, and what we basically show is that there's no change in all these metrics after repeated cleaning operations. What is very important is, of course, to in order to maintain the good performance, is to basically groom, clean at microfouling level, that is up to FR 20 or fouling rating 1 based on the IMO rating.
Yes, but my question was more referring to damage to the coating from docks, fenders, or even soft grounding, if there's experience with that.
Yes, of course. When it comes to abrasion resistance, this is a matter of, again, looking at testing the hardness, the flexibility, the adhesion of the paint. All of these things we have tested, and we can say for sure that it is, let's say, at a higher level of resistance compared to other, traditional paints, and of course soft foul release paints.
Okay, thank you. I have one more question, just to those who have implemented energy-saving devices. In regards to their charters, a lot of ships are on time charter. What happens when you apply an energy-saving device and the conversation with the charterer? Do they give you the savings back, or is that not possible?
So they have been implemented during dry docking periods. So usually we don't have any problems with the time charters. We have installed energy-saving devices on time chartered vessels, and in 4 cases we made a special dry dock just for that for a few days, and there was no problem with the time charters. They accepted that they would have also fuel efficiency savings.
Do they give you a higher charter rate?
No, I don't think they give us a higher charter rate. We do it in our account.
Anybody else? Jolepon?
I have a question to Aceleron. You mentioned about the de-rating concept, which I fully agree about the relative improvements. However, the reality of what is happening, it is the relationship thermodynamically, maximum pressure in relation to mean indication pressure. and also an adjustment of maximum pressure to compressor pressure. And I fully agree that the turbocharger have been to rematch to the specified scavenging pressure as well the injection timing. But I have difficulties to understand how you can achieve the compressor pressure without change the number of the seams.
Yeah, thank you for the question. I was waiting for it. No. We can take an example case. It's a vessel of George, the Neptune Hellas, which also is applied with this stone propeller retrofit we have heard earlier from Jonathan John. In this case, we knew that Neptune will install a propeller with, let's say, a lower propulsion power. Originally, this vessel had 11,600 kilowatt at full MCR and will never go above the 9,500 kilowatts anymore, so we adapted it to this 81% of MCR. Originally, or the main engine is a 7S50 MC and has a maximum combustion pressure of 160 bars. And this 160 bars we achieve now at 9,500 kilowatts, so all adapted. What comes from the turbocharger, it is a TPL77 of ABB or Accelleron, having now 0.2 bar more scavenging air pressure, and this is significantly increasing the compression pressure. The compression pressure is approximately 10 bars higher than before, and by adapting the injection timing, we achieve now 15 to 20 bars more firing pressures. And this is the significant difference to a D-rating, which comes from a main engine OEM, where they also adapt the general rating coming from the table by shims and etc. And we can firstly check what is possible on the turbocharger. Then we do the thermodynamic study and calculate how much is the compression pressure higher and what is the mechanical limit of the main engine. So we also not can go over the limit of, in this engine case, 35 bars difference between compression and firing pressures. Okay.
Thank you.
Anybody else? I have actually a question for Mr. Sphiris. Regarding this hull grooming as well as hull cleaning, my experience is that in the majority of ports, you're not allowed to do this hull grooming, you're not allowed to do any hull cleaning. What is your position in that? And actually this is one of the controversies that we face in shipping, because ports do not allow hull cleaning to be done, and as a result we have to perform voyages with very dirty ships. Thank you.
Yes, that's a very good question, Mr. Hadjigeorgiou. First of all, this is grooming, not cleaning. This means that we basically provide the required documentation to the port authorities, and we have started educating them in synergy, of course, with other stakeholders, because here we have two main differences with traditional cleaning. The first is that it is a biocide-free coating, so there's no discharges, there's no release of any toxic substance in the water. And second, we clean on a slime level, so we don't clean hard fouling, we clean microfouling up to FR20. Okay, so this means, based on the IMO biofouling management guidelines, there is no capture that is required at such level of fouling. Okay, this is one thing. The second thing I would like to emphasize is when you look at the robotic cleaning solutions, there are also solutions that can be used in transit. So this means that it's not always a matter of cleaning in port. From our side, what is important, what we are doing is we run assessment of feasibility to evaluate if grooming can be implemented in port. And how we're doing that, we're looking into restrictions in the ports that are visited by the specific vessel. So we do have our intelligence from the ports. At the same time, we are also looking at the time that the vessel spends idle compared to the time that is needed for performing the grooming operation. Okay. So we do have cases, for example, of bulkers with long idle periods at ports or anchorages where cleaning is allowed, grooming is allowed, and this could be a good candidate for a solution in port. But other vessels where they are visiting ports that cleaning is not allowed and the authorities are not accepting the documentation for grooming that we provide, in this case we would have to go with an in-transit solution. Okay.
Okay, thank you very much.
Mr. Hadjigeorgiou, do you allow me to say a comment about this? We face the same problem in our company. We have an extensive hull cleaning program. So many times in various ports we have restrictions and we are not allowed by authorities to perform hull cleaning. However, there are various exceptions. For example, at Rotterdam, there are special barges that come alongside and can suck all biofouling material. Nothing falls into the sea, so this is permitted. Or in many ports where there are restrictions, there are special anchorages close to the port that you can go and perform the hull cleaning works. And regarding the robotic instruments that I mentioned in my presentation, that we want to rent, you can do hull cleaning even underway. We have not tested yet, but the company who provides this claims that we can do grooming up to 11 knots speed. Thank you.
Thank you very much. But my experience is that in places like Brazil, where you have the water temperature and all that is very good for development of barnacles and extreme fouling of the hull. There are practically no facilities over large parts of Brazil. Same, let's say South Africa. In older times you could do it in Durban, now it's forbidden. So there are many, many places in the world that you cannot do hull cleaning, or you could, but you cannot do that any longer. That's the issue. Anyway, thank you very much.
As we are running out of time, we'd like to stop here the questions, and we'll invite you for lunch. The lunch is sponsored by Lloyd's Register, and we'll be back at in 1 hour. So 3:15 we'll be back for the last two sessions of the program.
The third session of the summit this year is about decarbonization and the transitions to cleaner energy. We have seven participants. The organizers have allocated 15 minutes to 2 of them, I don't know why, and 10 minutes to the rest. You have 15, don't complain. Okay. The first to speak is the representative of Drew Ameroyd, Mr. Layson. If you don't have it in your presentation, please say a few words about Drew.
Okay.
Thank you very much.
Thank you, Mr. Chairman. Thank you to the organizers for the invitation to speak to you once again. My name is Albert Layson with Drew Marine. It's based in the USA. We supply technical specialty chemicals. I think many of you that have sailed on ships are familiar with Drew Ameroyd, Drew Marine. So that's my little spiel. But I'll focus more on biofuels, myth versus reality, and I'll just show you the agenda. I will very briefly go over the changes in the ISO 8217, the latest edition that was released last year, or earlier this year rather. I will go into the types of quality and problems with different types of feedstocks, with various types of FAMEs that are created from those feedstocks. I will then dive into the in-depth analysis that I promised in the title, and that would go into the sample distribution of the FAME, the actual quality, as well as a comparison to the existing fuels that we're using now with the IMO 2020 compliant fuels. So first and foremost, the key additions and changes to the ISO 8217 that released in May of this year, you have the four total tables now from the original two that we're familiar with. So you have your DM and DF grades, those are your distillate fuels and distillate FAME. Those remain in Table 1. The new terminology that's used by ISO 8217 is now biodistillate. And that limit of 7% in the previous edition, 2017, of 7% maximum has been lifted, and now you could have up to 100% FAME content. There are two new tables inserted as Table 2 and Table 3. You have the IMO 2020 compliant fuels. Those have been put into a new table, Table 2. And then you have your bioresidual now that are being introduced. Those are in Table 3. And last but not least, the high sulfur heavy fuel oils are now in Table 4 instead of Table 2. So I'm not going to dive too deeply into the specification, but you could purchase the standard and look into it yourselves. But I think a lot of the class societies have already purchased, and there's also some information from CMAC on these. And I'll cover that in the next 2 slides. The biofuel-centric inclusions in the new standard, I mean, they do allow 100% for the bioresidual and biodistillate. So all the FAME that's added has to first comply to the B100 spec. So there's 2 specs for that, and those are listed there. And then some other nuances is if you have a 100% FAME in your residual, bioresidual rather, that has to meet the biodistillate, because you can't have 200 B100s, right? So it has to meet the biodistillate spec rather than the residual spec. And then the blend ratio can be done in either mass or volume percent. And last but not least is the de minimis amount of FAME allowed in the non-bio grades is limited to 0.5%. Now, what to expect? I think the last time I spoke to this audience was pre-2020. So we're familiar with the conventional fuels. We've become very familiar with the IMO 2020 compliant fuels and some of the challenges there. But what are the challenges that are facing us with biofuels? And some of you that have been early adopters have probably gone through this learning exercise already. But you know, there's a lot of published material on what to expect. So those I'm not calling myths, but let's just call that the assumptions. And I'm here to kind of present the details on what are actually true assumptions and what are a little bit off. So what to expect? Again, this is just a summary of something that's already published. You could kind of look at the biomass that's used. I'll go into that in the next few slides on what creates the FAME itself. But it is one of the most readily measures available to decarbonize shipping. That's pretty clear. And depending on the type of biomass used, there's still development on increasing the availability and obviously decreasing the price per ton. Now, when we go into the weeds a little bit here, we have to kind of focus on the amount of unsaturation or double bonds that's in the FAME. That actually affects overall fuel quality. Some of the properties that are listed in this CMAC guideline include, pay particular attention to cold flow, the oxidation stability, and as well as the lower energy density or content. Obviously, as the data will show in the next few slides, the higher amount of FAME in that blend, the more the impact it is on these, let's say, 3 main properties that I'll cover in detail, okay? Now, some of the assumptions that have been, again, widely published are characterized here in the pluses and minuses, the advantages and disadvantages. I'm not going to read them off to you. I think you could see them on the screen. But what I will focus on in the interest of time is just these three here, and hopefully that satisfies kind of an understanding of where biofuel quality stands. Before I dive into the weeds now on the quality itself, let's just have a common understanding on the different type of FAME feedstocks. The three major buckets, if you would, are high saturated fatty acids, the high monounsaturated fatty acids, and the high polyunsaturated fatty acids. Don't get too lost in what these things are called or what they look like. I mean, I showed pictures there to kind of just show, but it's basically looking at the variances in the number of double bonds. So the higher the number of double bonds, the poorer the oxidation stability. So meaning if you have 2 or 3 or more double bonds, those will tend to oxidize faster because the oxygen is already present compared to a single double bond. Conversely, a FAME chain with no double bonds would have very low tendency to oxidize. And again, you could kind of see like there's the pluses in green there based on the various types of feedstocks, and I put icons there to kind of map out the various feedstocks that are now available. But if you look at the cons, it's the opposite, right? So there's pluses and minuses based on the feedstock. So just keep that in mind as you go forward on some of the challenges. And again, if you had more saturated fatty acids, you may have more problems with cold flow, poorer lubricity, and if you had more of the unsaturated, the mono or the poly, you'll have poorer oxidation stability and compatibility. Now, diving deep into the distribution, this is based on 1,000 samples that have been analyzed in the last year and a half. You could kind of see that the majority of biofuels actually had very low biofuel content. So just be aware of that. So is bio or FAME really present in that sample? This is now all biofuel samples. You can kind of see the aggregation at around the B30 range, B24, B30, and then you have the last concentration closer to B100. But this is looking at all biofuel samples. If you look at biodistillate samples as an extract from that, it's about 1/3 of those samples analyzed are actually biodistillates. But here you could clearly see it's more of a dumbbell type distribution. You have the majority of the samples on either side, either at closer to like a B5 and less, and then you have the rest that are closer to a B100. Just for clarity, a B100 has to have a minimum of 96.5% FAME to be considered a B100. Okay? And then the 2/3 that are bioresidual, those are your typical, let's say, VLSFO bio residuals. Those are concentrated between the B24s and the B30s, as you could see there. And then there's actually more samples that were analyzed with less than a B5 concentration of FAME. Okay, now I'll dive down deeper into the rabbit hole here. So let's look on cold flow specifically. If you look at this cloud point distribution curve here, it's not terribly interesting to look at. But cloud point, as many of you know, is when the waxes first start to crystallize in the sample during the analysis. When you look at the cold filter plugging point, you could kind of see a peak at the -9 to -6 bucket, and the rest of them are distributed across from less than -15 all the way up to +12. And when you compare it to pour point, that's the one that we're most familiar with. That's when the flow actually stops. I mean, and I used to work for VPS. You would take the tube and you'd tilt it over, it wouldn't move. So that's pour point, right? You can see I marked in red that it would exceed the DF grade specification of 6 degrees there. So it is true then that you do have to pay attention to cold flow properties when it comes to your biodistillates. When you look at, when you put them all together, you can kind of see the number there on a clustered column. Again, you could have a copy of this presentation to go in more detail, and I looked at it various different ways. You could look at it from a scatter plot to see if there is any type of relationships between the three of them. And again, now this is focusing on samples that had FAME more than 90%. And the reason why I mentioned earlier is the more FAME you have, the more impact that FAME would have on these properties. And a new property that's been introduced during biofuel testing is iodine value. This is probably new to many of us. It was new to me. Iodine value is the how many grams of iodine is actually absorbed into 100 grams of oil, which is directly proportional to the number of double bonds in the FAME. So the higher the iodine value content, the higher the number of double bonds, the better the cold flow. And that's what the statistics show here for all three cold flow properties, for cloud point, cold filter, plugging point, and pour point. Okay, so I'll just go consecutively through that. But you can kind of see that the slope is more or less the same. And then for bio residuals, the properties that are tested there are typically the wax appearance and the wax disappearance temperature. Again, more statistics for you to show, but you kind of see that there's a delta between the wax appearance and the wax disappearance of roughly 15 to 20 degrees. So, if we jump right into the next parameter of interest is stability or oxidation stability, we'll look at the biodistillates. There's several parameters that could impact the stability of the fuel. So the first one is water. When we looked at the samples for biodistillates, you could kind of see that the water was not really an issue, even though biofuels tend to have an affinity for water. But I think once you receive the fuel on board is when you should actually monitor it. That would be some advice there. So when it's delivered, it actually meets the specifications. When you look at the bioresiduals, you could see that marked in red that it has exceeded the specification of 0.3, but the majority of them are actually below the specification. But again, pay attention to the water once it's actually received on board. And if you're keeping it for any extended period of time, it's good to monitor the water regularly. Obviously drain, do all those good fuel management practices. The other property that's we're familiar with is total sediment testing, and here's some statistics there. It does meet it, so not really surprising. Total sediment existing, same thing. It does meet the 0.1% maximum that's allowed. Acid number is another one that could contribute to poor oxidation stability. And if you look at the acid number there is a number of samples that exceeded the specification limit for DF grades, but the majority of them do meet the acid number specification. And then for the RF grades, there's, again, some samples that exceeded it, but the majority of them do meet it. So is it a concern? Is it not a concern? I think as more samples are submitted for analysis, we'll see what it actually shows over time. And then the oxidation stability test itself, you could kind of see, this is the number of hours that it's stable for. You could see the big chunk in the beginning that is actually less than 8 hours stability. So I think this is the more critical parameter to monitor when you're switching over to bio fuels. Okay, so again,
you have 1 minute to complete.
Yes, thank you. Again, and there's just more statistics beyond statistics, but the trend is that the higher the FAME, you could have the oxidation stability get worse. On energy content, I'll just summarize it here. The DF grades are roughly not 10%, but actually almost 13% lower energy content. And then for the RF grades, compared to conventional VLSFO RMs, they're about 4% less. So it's not your typical 10% less energy content as previously published. So in summary, we've covered, again, I encourage you to look at the ISO 8217 standard, look at the CMAQ guidelines that have been published. You see the breakdown of biofuel distribution by distillate and residual FAMEs. And then if you look at the saturation levels, the more the FAME has, the more impact on quality, the higher the iodine, the better the cold flow, the worse the oxidation stability, and then the energy content summary. Thank you.
Thank you, Mr. Layson. Second in the row is Mr. Koukoulopoulos, Regional Decarbonization Specialist for DNV. During the break, he told me that he never uses wood in his fireplace.
Correct?
Thank you for this great opportunity for presenting here today about the importance of energy efficiency in making maritime more sustainable. This is not going to be another presentation about regulation. There is a separate section about this one, but regulatory pressure is here. We have ETS having started this year, 2024. Directly the next year, FuelEU is coming, being the very first regulation to apply a complete well-to-wake perspective on the fuels we are using. And at the same time, IMO has now a clear target for 2050 for zero emissions, but let's be more concerned about the intermediate targets of 2020, 2030, and to highlight here that all these numbers are also under a well-to-wake approach, the 20 and the 70% reduction target in between. Here in this slide, in this year's maritime forecast by DNV, we have done an analysis in a database of all the existing and the upcoming projects for carbon neutral fuels, and we have created two scenarios, a low scenario and a high scenario, outlining this green area on how much of this fuel is going to be available until 2030. It is 2030 because 2030 is the difficult target of 20% reduction, and in this blue line at the right, we have two scenarios, two simulations for how much energy use shipping should cut in order to achieve this target. And we have a range between 4 and 16%. And comparing these two, from one side the supply and from the other side the demand for the regulations, we see a great variation. And this is exactly the reason of why energy efficiency is important, because the more we invest on that, the less carbon neutral fuels we are going to need. Of course, energy efficiency is important, but alone it is not an adequate measure to achieve compliance, especially for the well-to-wake regulations like FuelEU and the upcoming greenhouse gas fuel standard of IMO. So once carbon neutral fuels are available at the adequate quantities, it is going to be there, and in between we are going to have other technologies and transitional fuel like biofuel, where we had a great presentation before. But again, the more we reduce our dependency from those fuels, easier it is for shipping to cope with the competition that exists from other industries. So practically, what can we do today, what we are already doing today, shipping companies? Taking the example of a large vessel with a typical two-stroke engine, we know that around 50% of, only about 50% of the energy content of a fuel is converted to shaft power. And even less than that results in the power that moves the vessel through the water. This means that by attacking all possible losses in this chain of energy, of this energy transformation, either it is from the prime mover, the main engine, the propeller, or the hull, we can gain the maximum benefits from our vessel now. Another way to look into the available measures is to start from what we can do now. We can improve as much as possible the operation of the vessel and optimize the way it trades, but of course this demands a lot of communication and collaboration between stakeholders, hydrodynamics and machinery. The more and more we do, the less fuel we are going to burn. And this is not only an adoption order that we are going to see this in the timeline, but all these things together, at the end of the day, will need to work together, because the less energy we use, the less carbon neutral fuels are going to need, the less carbon capture we are going to need. Now some typical examples of what we are doing already, and more ships are now implementing and installing. From the hydrodynamic side, we have more efficient propellers, a lot of retrofits taking place in this respect. PBCF, the Bosch cap fin on the propeller, almost a standard in new buildings, and a lot of vessels are already installing as a retrofit. Other flow improvements like ducts, ultrasound propeller defouling in order to extend the period of time to clean our propellers, and even low friction coatings, another very promising technology. leaving the hull and moving in the vessel, in the engine room. What we can do from the machinery side, there are ways to optimize, reduce actually the specific fuel consumption through electronic auto-tuning for electronically controlled engines mainly. Waste heat recovery, this technology is quite expensive, but we see a certain comeback from this one. To install economizers even for the auxiliary engines in order to maximize the steam output from the vessel, from the engine room. Self-generator in the form mainly of power takeoff. Again, this is a technology more popular in the past, but now there is a lot of pickup for new buildings and even as a retrofit, we see this recently. And VFDs, variable frequency drives for the largest motors on the vessel, like engine room fans or cooling water pumps. Some examples. We have talked a lot about energy efficiency because it is important, but it is not alone enough to reach the targets of FuelEU. And we're currently on a transition that it is also reflected in the order book. About half of the vessels in the order book now, they can burn another fuel apart from the conventional fuels, mainly LNG, methanol, and even ammonia. Of course, what we see here is that the lion's share belongs to LNG. And this is because it has been seen as a solid transition option to reach compliance between 2035, 2040, and until that time to also help other vessels, pull other vessels, and potentially to switch to bio-LNG at this point in time and continue the compliance journey. There are, of course, other technologies, more promising, more large scale, that we are going to see more in the future because they need more research and more development, and also to understand how much energy efficiency they can give us. We see shore power as one of these, because what we see here is a comparison between taking energy from an onboard engine, taking electricity from shore, or burning electrofuels. And what we can see here that taking electricity from shore, even if the grid of the respective country is not carbon neutral, it is much more efficient because of the minimum energy losses in this chain. And comparing this with burning fuels that have been produced from electricity, this electricity needs to be much more green than the direct use of electricity, because of all the losses that are entailed in this transformation of energy. And it is another interesting statistic is that around 7% of the energy used by the world fleet now is in ports. And for some specific ship types, like cruise vessels, passenger, it makes sense, it can reach up to 15%. So if we target this number, we are going to see this will support in the overall reductions. Other type of technologies, air lubrication systems, still this is not an option for all vessels. There are differences between ship types and operational profiles for this technology. An example that for deep draft vessels it may not be such a good option because of the high energy needed to push bubbles at the bottom of the hull. Wind assist propulsion, this is going to be the next and last slide. Carbon capture, a lot of development, pilot cases running already, and more will run in the next year. And this is about taking CO2 from the exhaust gas, storing it on board, and offloading to a shore. But this needs a lot of infrastructure of build-up on land in order to take the maximum out of this technology. And of course, we need some regulatory acceptance that is not here yet, both from EU and IMO. And lastly, fuel cells.
You have 1 minute.
Yes, I have one more slide. And fuel cells that we are going to see mainly from smaller vessels doing very specific voyages near the coast for short sea shipping. But again, more in the future. And closing with wind-assisted propulsion, we keep it as a last slide because it is interesting to see the uptake of this technology. Currently, about 100 vessels have this technology, half of them sailing, half of them in the order book, mainly using rotor sails or hard sail technology. The total numbers can be seen at the top right. It can be from 7 to 20, 25, even 30, depending on the type of trade on the voyage. And this is a technology that has been recognized by EU, giving an additional reward factor of 5% if a vessel has installed such a technology. And there is a similar proposal submitted to IMO by the International Association of Wind Assisted Propulsion, suggesting them to do the same. Thank you very much for your attention.
Thank you. Next speaker is Mr. Michael Jeppesen of MAN-ES. He's the Principal Promotion Manager.
Well, thank you very much. On behalf of MAN Energy Solutions, I am honored to be able to speak here, and I would like to thank the organizers for another time here at the Greener Shipping Summit. My presentation today is titled Ammonia Engine Development Update. And I have three very brief chapters which I will try to go through from here. So when you're an engine designer and you want to approach a new design of an engine which is going to operate on a toxic chemical, you have to be careful. So by means of different focus areas, we have been trying to unlock the potential of the ammonia as a marine fuel. First of all, nitrous oxide is an extremely potent greenhouse gas. And there's also the issue of combustion slip. If ammonia is unburned in the engine, it could be bad. And then we have to look into the auto-ignition temperature and look at the flame speed. Actually seems very positive for ammonia in a two-stroke slow-speed engine. So if we look at ammonia and compare it a little bit with the different other new fuels that we have available, you can see that the density in liquid form by ammonia is approximately similar to the four other fuels compared to. It's a little heavier than LNG and LPG, but methanol and diesel oil is heavier. Looking at the calorific value and the heat value for these different fuels, we can see that ammonia is definitely the lowest one with 18.6. So it is interesting to see whether this fuel will actually burn or not. Also, the auto-ignition temperature is something to look at, and you can see that for ammonia it's 649, which is quite high. So we will see if it is a problem or not. The laminar flame speed is only 7 for ammonia. So this is actually probably it's definitely not a problem for the two-stroke slow-speed engine. So this is also something that we, of course, have to look into, how well it burns. And looking at the volumetric comparison for the same energy content for the different fuels that are presented here, we are giving an example here with a 1,000 cubic meter tank volume for diesel and compare it to the same energy amount for the different fuels. And as can be seen, most of these fuels have a significantly lower range, or you need to invert that to say that the amount of energy that needs to go into the tank, you have to increase the tank. For LNG, it's with 1.6 times the volume, and for some of the others, it's all the way up to 4.2 times the size for hydrogen. For ammonia, which is relevant in this case, in this presentation, you have to have a tank which is approximately 3 times bigger than for diesel oil. So to the ammonia engine development, the principle of the ammonia engine is the liquid gas injection, and thereby the designation LGIA. And the status is today that we have been operating this and testing the fuel for approximately 12 months for one cylinder in our 4-cylinder 50-bore engine at our research center in Copenhagen. And we have conducted more than 300 tests in our research center with this two-stroke test engine. Combustion stability is very good. The nitrous oxide emissions are extremely low. The NOx emissions are approximately 40% lower than for fuel oil, diesel oil, and we have obtained approximately the same pilot fuel amounts for the ammonia engine as for the methanol and propane dual fuel engines. This is a picture of the test engine as it has been just rebuilt in Copenhagen. You can see all 4 cylinders are actually installed with the new equipment for ammonia. And we are expecting an engine start and retesting any day now, here in November. Looking into the exhaust gas emissions, the laughter gas or nitrous oxide that I mentioned before is a very potent greenhouse gas with a global warming potential of nearly 300 times that of for CO2. So this is really something that we need to avoid. We need to avoid introduction of a new very toxic emission, which is not good for the environment, of course. So, but we have discovered with the one-cylinder test that the nitrous oxide emissions are extremely low and can be removed by the engine tuning. The exact levels will be published to the market after the 4-cylinder testing. So on the unburned ammonia and NOx, this can be removed by the SCR reactor. It is very convenient that the fuel slip in this case is ammonia, because ammonia is actually what is being utilized for the SCR chemical reaction we have in other engines. So yes, we have on the upper side here the graphics showing the exhaust flow where we have NOx and a small part of unburned ammonia. It reacts with the exhaust gas flow, and actually the chemical reaction results in free nitrogen, some amount of water, and NOx compliance or NOx in the level of the Tier 3 compliance. In the bottom picture here, we see the SCR unit, which has been supplied by our Augsburg entity, and this has been installed specifically for detailed measurements for the test engine. And this will happen soon, very soon. This engine here is the test engine that we have in parallel, an ammonia engine, 7S60 MEC 10.5 LGIA, and this has been built by Mitsui in Japan, our licensee. This engine has so far only been running on diesel, but they are rebuilding the auxiliary system to more or less a copy of what we have done in Copenhagen. And this engine is also to start here in November. This will be very exciting to see what the development is. So to the specific combustion for the ammonia engine, when the engine is running in ammonia mode, it is the liquid gas injection design philosophy. A small pilot flame is needed, similar to the other dual fuel engines. And we are targeting a 5% specific pilot oil consumption at 100% load for the L1 rated engines. And that has been confirmed already for the one-cylinder tests. Further potential is for further reductions is possible, and we will see how that goes in the further testing with the 4 cylinders. But we are targeting to obtain the same heat rate for the fuel as for the fuel mode, the normal diesel mode. And this is looking very promising so far. This slide shows the design for the test engine in Mitsui in Japan, the 60-bore S engine. And as you can see, we have 3 fuel booster injection valves. We have 3 accumulators for the hydraulics in order to avoid peaks in the system, pressure peaks. And then we have the hydraulic control block, and we have the inlet and outlet pipes, the yellow pipes below here. Looking into the ammonia engine auxiliary systems at our Research and Development Center, we have the ammonia service tank on the left upper picture, and it is only designed to be able to accommodate a few days of operation, a test operation. So bunkering is happening quite often actually here in Copenhagen. It is happening by means of a truck that comes in, and the bunkering is taking place flawlessly now. We have been practicing quite a lot over the past 12 months. Then we have the ammonia supply and recirculation system by FuelTech, Danish partnership. And we have the fuel valve return train, or fuel valve train, which is enabling the connection between the fuel gas supply system and the engine, and also the disconnection in case of a shutdown from gas. And once the shutdown is available or is necessary, and we shift over to fuel, we will do nitrogen purging with this system seen in the lower picture here on the left. We have double wall ventilation and absorber, which is utilized for the checking and safety equipment. And then we have the ammonia catch system, which we have developed in-house. I'll just go a little more into the details of this. And the ammonia catch system has been developed in order to avoid any ammonia slip all the way down to 20 ppm. I think this is the limit and the threshold, what's it called? The limit for the human nose to smell it. And we need to be below that level. And then we have made some tests, and the specific skid we have developed is based on a full blowdown equivalent to a full engine shutdown based on this test setup. And the result has been a skid which is a little bigger than a car, 7 meters of length, 2.5 meters wide, and 3.5 meters height. So, yeah, the accumulated water and ammonia mixture will be discharged as chemical waste in a compliance and in accordance with existing regulations. We have been involved in a lot of risk assessment with operation on ammonia. At least 10 or 15 HACCPs and HACCPs have been conducted together with classification societies and ship owners. And we have been very much looking into all different details potentially that could arise with the operation of the engine with ammonia. More than 5,000 hours have actually been spent on FMEA and HACCP and HACCP workshops. So the introduction to the market strategy, we have been working diligently on pilot projects with different vessel segments, very large ammonia carriers, bulk carriers, and pure truck and car and truck carriers. And the press releases highlighting involved parties and project details have been made recently upon the confirmed signing of the ammonia option in the ammonia pilot shipbuilding projects. We have approximately 10 vessels with this kind of status. So full release of the ammonia engine with G50, S60, G60, G70 and G80 will be released in the market as soon as the first vessels have demonstrated positive seagoing service experience with operation on ammonia. As such, the actual time schedule will be depending on the shipyard delivery schedules, because the designs for the vessels is actually not finished in some of the shipyards. A best guess time estimate for sales release for these engines will be end of 2026. Finally, a summary. Ammonia is a great fuel in the two-stroke engine due to the slow flame propagation when combusted. And it has shown a very stable combustion stability, similar to that of diesel oil. The N2O emissions are extremely low, and the NOx emissions are 40% lower than fuel oil. Pilot oil amount has been verified similar to the methanol and LPG dual fuel engines, and the toxicity challenges of ammonia is being handled with success in our research center in Copenhagen. However, even so, we are, in order to have a safeguard to the uptake of ammonia as marine fuel, we have a very responsible implementation of these projects, and we will not publish or release them commercially until we have positive seagoing service experience prior to the full sales release to the market. Finally, we're proud to claim that we are the market leader within two-stroke ammonia engine development, with a dedicated two-stroke ammonia combustion test completed over 12 months, with a dual fuel concept of which we have actually already a decade of service experience. So these were the words from me. Thank you very much.
Thank you, Michael. So it has been a quiet afternoon until now. This means that it's time to ask Mr. Zachariadis to.
Hello, everyone, and thank you for the invitation. So I'm going to talk to you about green fuels. As you see, the title of my presentation is "Do you think green hydrogen will save you? Think again." But this is not the title the organizers put in the. They preferred something milder. Anyways, okay. So many years ago, I was saying that natural gas is not really as good as we would led to believe. Let me see. Some myths about it is that we heard back then that methane is only 25 times worse than CO2, that when you burn natural gas in the engine, it's 20% less CO2 emitted. So those turned out to be myths based on a plethora of scientific studies. Methane is actually 86 times worse than CO2 for the first 20 years after it is emitted to the atmosphere, and considering methane sleep on 99% of the engines, it is same or worse than diesel. And that's the reason when methane first is emitted in the atmosphere, it is very potent. It warms it up a lot. The first 10 years is about 120 times worse than CO2, and then the potency gets reduced. So right now, natural gas production is about 3.1 billion tons. The world average escape of natural gas, most of it at production, leaks during extraction is 5 to 6%. Actually, the producers of natural gas admit 2%, but all the independent studies show much larger escapes. The man-made CO2 we know, all of us, is about 36 billion tons, of which shipping is responsible for 0.8 billion. That means if we assume only a 4% natural gas escape, we're talking about nearly 11 billion tons of CO2 equivalent, which is not included in what we believe the 36%. Another factor is that during the last 300 years, CO2 has increased in the atmosphere by 50%, whereas methane has increased by 250%. So you have something in the atmosphere that increases 5 times faster than CO2 and does 86 times the damage. My point is that methane is a much bigger problem than we consider it to be. Let's look into alternative fuels. So you have hydrogen. Most of the hydrogen we produce right now, 70% of it is from natural gas, 20% of it is produced from coal. A minute amount is produced by electrolysis, and if you take that, you need 55 kilowatt hours for 1 kilogram of hydrogen through electrolysis. If you take it from a typical city grid, that's you emit about 49 kilograms of CO2 for every kilogram of hydrogen you produce. Methanol also, the majority of it right now is produced from natural gas. Ammonia is also produced from hydrogen, which has been produced from natural gas by adding nitrogen. And like Michael mentioned before, this is how bigger the tanks need to be. Natural gas 3 to 4 times, methanol 2.3 times. How much the tanks need to be bigger than diesel. Now, right now, the hydrogen produced in the world is only about 87 million tons. Even for this rather minute amount, the emissions to produce it is equivalent to the whole of shipping. 830 metric tons of CO2 per year to produce these 87 million tons. If we are going to move to a hydrogen economy where all the green fuels are going to be produced like green methanol, green ammonia from hydrogen, you are going to need 1 to 2 billion tons per year of hydrogen. I'm not talking about where you're going to find all that power. That's another story. So green methanol is produced by adding CO2 to the green hydrogen, and green ammonia is produced by adding nitrogen to the green hydrogen. But, a big but, this CO2 needs to be green. You cannot use CO2 from onboard carbon capture, for example. It's considered dirty CO2. So this CO2 is CO2 only that you can take only from the atmosphere. And this is the biggest factory there is right now in Iceland. And they hope they will take out this year 36,000 metric tons per year, which is equivalent to the emissions of one small ship, Ultramax size, for about 1 year. Now, their hope also is that they will extend it, and by 2030, they will be able to take out of the atmosphere 1 million tons of CO2, which is the equivalent to 30 ships' emissions for a year. So you can understand that this green CO2 will never be available. I mean, that's the bottom line from this. Now, hydrogen. Breaking news. Probably most of you know, hydrogen, green or not, is a potent greenhouse gas. The same, similarly to LNG or natural gas, when it is emitted to the atmosphere unburned, is a potent greenhouse gas. I put here some of recent studies. I'm not going to go through those, but it acts in 3 ways when hydrogen escapes to the atmosphere. It acts in 3 ways to overheat it. The first way is it combines with free hydroxyl radicals. And that's important because this is why methane gets reduced in potency, because also methane combines with the hydroxyl radicals. The problem is hydrogen combines first. So there is no hydroxyl radicals ready to combine with methane. The result is methane stays very potent in the atmosphere. The potency doesn't get reduced. The second way is it creates ozone in the troposphere, which is a greenhouse gas. And the third way is it creates water vapors in the stratosphere, which also contributes to atmosphere warming. So, to make a long story short, the latest studies say that practically we were wrong before to think that hydrogen is not that bad of a greenhouse gas. And now they are saying in the short term, if hydrogen gets emitted to the atmosphere, it's 200 times worse than CO2. In the longer term, 60 times worse than CO2. But there is another problem. Hydrogen is the smallest molecule in the universe. There is no way you can prevent it from escaping from any system some amount to the atmosphere. So it can escape from everywhere, from compressors, liquefiers, the ships that use it, and so on. Some of it is deliberately vented to the atmosphere. It even seeps through steel walls of pipes or containers. So the studies considered a 5 to 10% leakage, which I find conservative, because in speaking with hydrogen experts, they have a joke. They say, if you send hydrogen down a pipeline, you can expect 50% of it to arrive at the other end. You can expect half of it to arrive at the other end. So just with a 10% leakage, we're talking about a 0.4 degree warming. So déjà vu, what I found out about natural gas years ago, I find about hydrogen now, and I'm letting you know. Final thought. The energy to power one large container ship is equivalent to the energy needed to power 50,000 homes. In my opinion, it is stupid, and also the previous presentation said that, it is stupid to use precious renewable energy to make liquid fuels. This renewable electricity we should use directly as electricity on land for batteries, and not to make liquid fuels, which then we burn, and 60% of them go up in heat to the atmosphere. Totally stupid. And of course, we have a new factor in the equation, and we don't know how that's going to play out, although we have an idea. Thank you very much.
Thank you, Pano. Mr. Theocharis working for ABS.
Good afternoon, everyone. First of all, I want to say I'm really thankful for being here today. I remember when I was participating as an observer here when I was studying for NTUA. So I will try to be as short as possible, given the time. So, decarbonization, IMO decarbonization regulatory agenda. What to expect in the next 5 years from IMO. So in 2023, we had the adoption of the 2023 IMO strategy, which we should always have in mind because it defines the trajectory that the IMO meter measures will have. So IMO meter measures, these are currently the most hot topic regarding the decarbonization from IMO. Where we stand right now, we are here in the finalization of the meter measures, which must be approved by MEPC 83, April 2025. So, of course, according to the timeline agreed in MEPC 80, this must come into force by 2027. So, by 2027, this will be into force based on the timeline agreed. Then we have the life cycle analysis guidelines, the LCA guidelines. The LCA guidelines are necessary in order to define the sustainability criteria that all marine fuels should comply with to be considered sustainable, and also a methodology to actually assess the greenhouse gas intensity of all those marine fuels and also the electricity. And another hot topic nowadays is the review of the CII, the review of the short-term measures. We have identified, the industry has identified a lot of challenges with the CII. There have been submitted many papers in previous MEPC committees, more than 100 papers highlighting the issues. And the organization now decided to work on a two-phase approach. The first phase must be concluded until 1st January 2026, and they will assess mainly challenges such as whether CII is a robust operational efficiency measure, the reduction factors from 2027 until 2030, and the impact of the port and idle time, and also the impact of short voyages, and many other challenges will be assessed in the second phase. Okay. So when we speak for decarbonization, we should always have in mind also the safety aspect. All these fuels will introduce new safety challenges. The IMO is currently working and has developed several interim guidelines for the use of alternative fuels, the use of methanol as fuel, and recently CCC10 in September finalized the interim guidelines for the use of ammonia as fuel. These guidelines will probably be approved in MSC 109 this December. And of course, all these guidelines are in an experience building phase, and based on the feedback and yes, from the actual application of these guidelines, this will be revised and will be turned into mandatory instruments under the IGF code. But as I said, we should always have in mind the 2023 IMO greenhouse gas reduction strategy, which the goal is, of course, the net zero near or around 2050. And of course, there are some interim targets, such as the 2030 target for 40% greenhouse gas CO2 reduction of CO2 per transport work, the adoption of 5, striving for 10% the energy to come from renewable zero or near zero energy sources, and of course the reduction by 20%, striving for 30% the total annual GHG reduction, and for 2040 the reduction by 70%, striving for 80%. So, meter measures. What we have at this stage? There are 7 meter measures on the table, but they have concluded, the member states have concluded on the greenhouse gas, the technical measure, which will be similar to FuelEU Maritime. It will target the well-to-wake or the adjusted tank-to-wake. The idea behind the adjusting tank-to-wake GHG intensity is to offer a grace period to grey fuels, because initially vessels built on ammonia, methanol will have mainly access to grey fuels and not blue-green. And you can see that the reduction rates are much more aggressive compared to the FuelEU, the reduction rates in the greenhouse gas fuel intensity. We will see in the next slide the FuelEU reduction rates. On the economic measure, there are at this stage 2 split parties. One is supporting to implement it in the greenhouse gas fuel standard with means of surplus units, compliance, deficit remedial units, similar in a way to the FuelEU Maritime, or to have a surcharge on any excess CO2, any excess ton of CO2 equivalent, or to have a standalone measure with a levy, let's say, or a contribution. And here we can see some indicative costs as proposed so far. We have at this stage this proposal from Marshall and Solomon Islands suggesting a levy of $100 per ton of CO2 equivalent. You can see the daily cost of a vessel consuming daily 100 metric tons of LFO. This is around 30,000. And you can see the other proposal for a universal levy and simplified GHG fuel standard supporting $150 per metric ton of CO2, which is for 100 tons per day LFO around $50,000. Now, this is all from IMO, very short, and I will jump into the European developments, the FuelEU Maritime. You can see the GHG intensity limit reduction for the first 15 years. It is very, I would say, not that aggressive, but after 2035 it becomes much more aggressive. And this is actually a very interesting slide showing in blue bars the well-to-tank and greenhouse gas intensity of fuels, and the red bar the tank-to-wake. And you can see that the 2025 limit, which is this blue line here, For 2025, HFO, LFO, and MGO vessels that continue to consume these fuels will have to pay a penalty. LNG depends a lot on a methane slip. You can see that the low-pressure four-stroke engines with 3.1% methane slip are slightly compliant for the period 2025 to 2030, but this will change once the fuel EU also aligns with the global warming potentials of EU ETS. Once the global warming potential of methane becomes 28, the DFD's engines will have a problem. The high-pressure two-stroke diesel engines with 0.2% methane slip can be compliant up to 2040. And imagine the compliance surplus these vessels will have banked until 2040. Then we have the well-to-wake intensity of grey fuels. You can see that this is even worse compared to HFO, LFO, and MGO, and this is why I said that the organization is also investigating the adjusted tank-to-wake idea for the greenhouse gas fuel standard to not penalize these vessels from the first years. And we have, last but not least, the B30, biofuel, 30% of biofuel. The B30 can be compliant up to 2040. Of course, vessels will not have to burn from the first year's B30. We have estimated that around 3.3% of biofuel is enough for each vessel to continue and use HFO, LFO, and MGO, but be slightly below the 2025 greenhouse gas intensity limit. And this is my last slide. Some fuel-EU pooling scenarios. Pooling will play a significant role. We can see in each red vessel consumes daily 30 metric tons of LFO. And in the first scenario, we have a green vessel that consumes green, not actually green, but it also consumes 30 metric tons of LFO, but has installed wind-assisted propulsion. As Mr. Kokoulopoulos said, wind-assisted propulsion can give a benefit of up to 5% reduction of the greenhouse gas intensity, and this vessel can offset another one vessel. Then we see the case of LNG with high pressure two-stroke diesel engine, 0.2%. This LNG vessel consuming the equivalent energy of 30 metric tons of LFO daily can offset another 5 LFO vessels for the first 5 years. The B30, another 10, around 9 to 10 LFO vessels. And last but not least, the 30% green methanol. We have a vessel consuming 70% green methanol, 30% green methanol and 70% grey methanol, but due to the rewarding factor that the EU is offering to RFNBOs, the green fuels, this vessel can offset another 15 LFO vessels. Yes. That's all. Thank you. I hope that this was clear.
Thank you. Yes, Aldoni, it's your turn. No, we have one more.
Καλησπέρα και από μένα. Thank you for the invitation. I'll try to take you very fast, as Mr. Hadjigrigoris asked for, through the It's working? Okay. I'll try to take you through the logistics of the ammonia market. This is our 60,000 cubic ammonia carrier, one of the 21 of this size in the world. We're engaged in ammonia since 2015-16 as a company. So ammonia, basically we're talking gray ammonia, which is produced from natural gas, and we are hoping for the green ammonia that will come from renewables. Currently, it doesn't practically exist. Blue ammonia is in the game as well, which comes from the traditional method, but after the emissions have been captured with carbon capture. Ammonia is destined primarily for the production of fertilizers, and over the last years we have seen a continuous growth. Biggest player in the market is Yara, followed by CF Industries. World production is 190 million tons per year, but only a very small portion of that, less than 10%, is transported by sea. Three major players, exporters, has been Saudis, Russia, and Trinidad. However, after the war, Russia has gone down, and this portion has been covered by other regions. Ammonia practically is carried on LPG carriers that are certified to carry ammonia, and that has been on moderate sizes. However, we have seen very recently the so-called VLACs, VLACs, which are practically VLGCs with an ammonia carrying capability at 98% loading, filling rates. Compared with LPG, which we have approximately 140 million tons of transported by sea, it's a very, very small market. So if we see the vessel types that ammonia is carried, we practically see that VLGCs, or the so-called tomorrow VLSCs, are out of the game. They have never been engaged in any ammonia cargo or transportation for the last 20 years. And to the best of my knowledge, there has been only one shipment, only one cargo in the history. It's practically carried on MGCs, which is medium-size gas carriers, 35 to today's sizes, 45,000 cubics, and LGCs, which are about 60,000 cubic vessels. Then we have the smaller vessels, Handys, 22,000, and the very small ones. So if we see the LPGs on the upper chart, upper right, we see that VLGCs dominate the market, while on the lower green ones, it's the MGCs that dominate the ammonia transportation. Ammonia trade by origin, Middle East and Saudis, as we already said, with Trinidad playing a very, very big role, while importers is Northwest Europe and India, the key players. Jumping very fast to visualize that, we see that from Trinidad, we have cargoes destined for North America and South, as well as West Europe, and a little bit in the Med, while the Arabian Gulf is supporting the Med and the Far East. The current situation has changed because of the Houthis issue, so the trade from the Middle East to Europe has declined. Smaller vessels, Handys and small, serve shorter routes compared with the bigger ones. Typical size of designs, type A, fully ref vessels, design temperatures minus 55. They carry the cargo at atmospheric pressure, and they represent the bigger vessels in the market, from 30,000 all the way to 93,000 cubic meters. While type C tanks, either full press for the smaller ones or semi-ref for the mid-size, up to 22,000, 25,000 cubic max, serve for local and smaller trades. Looking at the order book, which is very, very interesting, VLGC's order book stands approximately at 24%, while the MGC stands at 46%. We need to remember that these are small sizes, small fleets. They cannot be compared with bulk carriers or tankers. So we are talking very small number of vessels. And at the same time, we see on the right side that the average age is very, very small. So there are not so many vessels to be scrapped in the coming years. So going into the fleet for the VLGCs and the VLACs, the existing fleet, blue and green, is less than 400 vessels. This is the total number. And only 45 of them, 11%, can carry ammonia, either full loading or partial loading at 86, 87%. While the order book is reversed, with more vessels capable of carrying ammonia, like the VLACs. If we see the pie chart, the bar chart on the right side, we had the peak of deliveries back in 2015, 2016, that the market actually collapsed. And we see the same recipe exactly coming up in 2027, 2028. So the overall situation is highly risky with respect to a potential market collapse. Situation for MGCs is rather different. All of them are ammonia capable. The fleet is even smaller. We have less than 140 vessels in the world, while the order book is less than 60. So we are talking very, very high order book ratios. And again, the upcoming deliveries present a very, very big threat for the market for potential collapsing. If we see the MGC seaborne trade and the split between LPGs and ammonia, we see that from 2017 until 2023, the balance has changed. LPG has played a bigger role in the transportation within the MGC sector, rather than seeing the opposite trend. Ammonia-capable LPG carriers on the upper right, and I'm trying to go faster. So the VLGCs, you see it's about 100, 110 vessels, including the order book, but what the MGCs are more or less the entire fleet. Handys, all of them. Builders, so who are the builders that can actually build these vessels? Hyundai Group maintains the dominant position, both at HHI and Samho with the bigger vessels, while Hyundai Mipo has been always the leader on the mid-size designs. Chinese are following from behind with Jiangnan having done significant progress. That's all, very fast, and I hope I met the time. Mr. Hadjigeorgios.
Yes, I apologize for pushing you.
Okay, taken. Thank you very much.
So last speaker is another Andonis Strakakis, who is the technical director of RINA and the president of CIMAC.
Very well done to organizers, and thank you very much to you also, ladies and gentlemen, for being here with us. Well, the IMO strategy for decarbonization has ignited an ongoing discussion about the future fuels. But what the regulation really requires from us is to embark as soon as possible into a continuous effort for the progressive reduction of emissions. And we believe that failing to appreciate the significance of each and every of these aspects may take us to rather wrong paths. We cannot relax and do nothing but only wait until new technologies will mature. If we also make efficient use of our existing technologies, we don't need a green fuel today. And actually, we find it very risky, if not premature, to invest today on a fuel that after 10 or 15 years may not be relevant anymore. Last but not least, we should be prepared to abandon business as usual and explore new options. The idea of green fuels came up as a solution for balancing the intermittent supply of renewable energy with a variable consumption of the power grid. But it was never promised that green energy will be used only for the production of green fuels. And as we see, the main use of green energy today is electrification. The production of green fuels only for shipping practically requires all green energy produced on Earth. As a result, the high expectations around green fuels cannot be supported. This is in line with what Maersk officially declared in July, namely that what they were promised around the supply of green methanol, nobody can deliver. We should also have an open approach to the term of emissions. For example, the combustion of methanol produces formaldehyde, which is a very strong poison with very short allowable time for exposure. And since there is not enough green energy for green fuels, what we consider as a potential zero-carbon fuel, which is ammonia, in reality it can reduce the greenhouse emissions by only 50, maximum 60%, depending on whether the ship sails in NOx Tier 2 or Tier 3 area respectively. This is quite far from the target of net zero. Bearing in mind that the rate of growth of population is faster than the rate of growth of green energy, we understand it is not safe to count only on the use of green fuels for meeting our future demands. On the other hand, the continuous use of existing fossil fuels requires the adoption of carbon capture, which is very different from SOx scrubbing. And this is a nodal point where the paths of the existing fuels, liquid and gas, really start to become different. In the case of liquid fuel oil, the CO2 is captured by means of chemical absorption from the exhaust gas of the engine, the so-called post-combustion capture. This technology is very mature for land applications, and its efficiency depends on the concentration of CO2 in the exhaust gas, which is in the case of marine engines very small. It is a very complex heat and mass transfer process, sensitive to local load changes, hydromechanic and thermodynamic factors, as well as vibrations and impurities like NOx, SOx and PM,
which can be reduced but not totally eliminated in the exhaust gas. All studies around post-combustion carbon capture arrive to agree that the best fuel for this technology is LNG. But regardless of fuel in use, it is a very capital-intensive solution. According to a test case that the results of which were published recently, for an installed power of only 7 MW of main engine, the capex required to achieve a reduction of up to 20% of emissions is about $15 million US. LNG has a unique feature that it can burn following either the diesel or auto heat cycle. Another distinctive feature of LNG is that aside to the post-combustion capture, it allows us to apply the pre-combustion capture, which is equivalent to the production of hydrogen. Before its combustion in the engine, the molecule of CH4 breaks and becomes hydrogen and CO2. The CO2 is captured cryogenically by use of the temperature that LNG is stored in the tank and can be delivered at reception facilities in convenient ports. The hydrogen that is produced becomes fuel to the engine instead of LNG. The solution produces the dream fuel of decarbonization on board, on demand, and avoids all problems around its storage and transportation. Furthermore, it disconnects the production of the new fuel from the developments on shore. This is important since the real challenge of decarbonization falls on shore to prepare the solutions that we are going to use on board. Furthermore, the addition of hydrogen to LNG is the best measure to reduce the methane slip, and the reformation of LNG to hydrogen converts LNG from a transitional fuel to a fuel in transition. Hydrogen generators are mature technology used in refineries for more than 100 years. Compared to the post-combustion capture, the main benefits of the pre-combustion capture is that it delivers CO2 of extremely high purity. This is a very sensitive topic. It avoids the use of chemicals. It can be applied in a containerized module and thus in a scalable manner. It involves less space and cost, and very importantly, is not sensitive to load changes, vibrations, and impurities. In terms of energy consumption, which is always inevitable, we have assigned a comparative study to the University of Cambridge, which concluded that other things being equal, the pre-combustion consumes less energy than a post-combustion system. RINA was the first, in cooperation with the Liberian administration and with the sponsoring of ICS, who submitted to IMO the proposal for carbon capture to be included in the regulatory frame for the reduction of greenhouse gas emissions from shipping. The submission was made already at MEPC 79 in September 2022. The scope of the preceding analysis was to emphasize that the fuel solution with the easiest path to 2050 through carbon capture is the LNG. Furthermore, the selection of LNG as fuel removes many risks that we are traditionally accustomed to deal with every day, like fuel quality, cut fines, and cylinder oil control, which can even remove totally the boiler from the bulk carriers. Today, the combustion of hydrogen is more advanced in four-stroke engines, although the two-stroke is coming up very fast. Actually, we had an announcement from Mitsui recently. To support its use, we have developed a new propulsion arrangement where we replace the main engine and the three generators with only two four-stroke engines. Each of these engines drives her own shaft generator and through a gearbox, a controllable pitch propeller. Up to 12 knots, only one engine is needed, and both engines will have to run only for maximum speed. Main advantage of this system is the extreme redundancy and safety that it offers, while the modern four-stroke engines have very long maintenance intervals that allow engine overhaul to be carried out at each dry dock. An important feature of this proposal is that it allows the efficient use of wind-assisted propulsion. The more the wind is pushing the ship, the more the efficiency of the standard propeller drops. But this is not the case with a controllable pitch propeller, which allows to harvest more benefits from the wind. Our proposal has developed from the stage of a simple concept, and it has been adopted by SDARI in various ship designs. Here shown the case of Newcastle-Max bulk carrier, where we have developed also designs for tankers. This graph describes the proposed path to compliance. Due to its higher hydrogen to carbon ratio, LNG offers more time for the transition to a zero carbon fuel or technology. And this is well beyond 2035. Therefore, starting with LNG, the owner has the option to decide for his ultimate investment that will take him to 2050, only very close to 2040, when the options will be mature and the risk for the investment minimal. At that time, if the CO2 market will be fully developed and make sense to continue with the hydrogen production on board, the owner will be free to decide how far he wishes to be ahead of compliance and competition and adjust the production of hydrogen accordingly. The units for the production of hydrogen can be installed at each ship's dry dock. If, on the other hand, by 2040, there is another winning fuel solution, then the engines can be easily converted or even replaced with a minimum extra cost. A question that reasonably arises is whether the performance of the ship with the four-stroke engines will be competitive or not. Calculations of the total fuel consumption have been made by SDARI. As we see, in the market speeds below 12 knots, a ship with a four-stroke engine remains more competitive as it achieves a fuel consumption 12% less than a two-stroke dual-fuel engine, meaning that our proposal is particularly effective in a slow-speed future. The selected engine technology allows the use of air lubrication with charged air instead of compressed air, which will further improve the results. The total cost of machinery between 2 and 4-stroke is same when with a 2-stroke engine is not fitted with PTO. In case the 2-stroke dual-fuel engine is fitted with PTO and high-pressure compressor for the boil-off, the 4-stroke can be quite less expensive. In terms of operating costs, the 4-stroke involves much less cost for cylinder oil, and the maintenance is also comparable and actually less. This happens because the maintenance cost is a function of running power, and since we don't need to run both engines all time, the kilowatt of power that needs to be serviced is quite less than a 2-stroke engine. This slide describes in a nutshell the flexibility of our proposal. We suggest a new ship to be built running on LNG. This has an extra cost, but our studies have shown that it brings also serious savings in terms of fuel cost, as well as in the compliance with ETS and fuel EU regulations. Having furnished the ship with a new propulsion arrangement, the owner is rewarded not only with extra safety, but very importantly with less fuel consumption and less operating costs. And when time comes to make the final step towards 2050, which will be only very close to 2040, then depending on market dynamics, which will have become hopefully clear by then, the owner has the flexibility to either proceed with the most efficient carbon capture solution or convert the engines to run on any fuel that may have become prevalent at that time. And since RINA is really expert in building floating islands like mega cruise ships, please be sure that you can build very easily any kind of bulker and tanker. Thank you very much for your attention.
Thank you, Antoni. We are, let's say, behind schedule, but let's take some questions from the floor.
Thanks, everyone. A very interesting panel, a very amusing one. I'm Alex Arkatzos.
Who was the most amusing one?
My friend Panthos.
Okay.
I'm Alex Arkatzos, former chairman of an IMO committee. My capture of the whole picture is the following. There is no clear winner here in fuels. The game from now on will be a pick and choose game from ship owners. Lots of guessing will take place there. The solution will be imposed by outside. Other industries will decide for shipping, because shipping generally there is no a single strategy in shipping. Therefore, others will decide on that, and it will be a good advice to ship owners and to the shipping industry to set synergies from outside. Thank you.
Who wants to make a comment? Pano. Question or comment on? Pano? Zachariadis? Yes. You going to say something on what Mr. Karkatzos said? Yes.
No, he's right.
Okay.
Fine. Nothing to add.
Then Pano. These Panos.
You have one.
I start with a question to Mr. Zachariadis. Since the vast majority of methane emissions comes from agriculture, do we expect to see you in agricultural conferences as well?
As you may know, there are Greek ship owners that have been involved in agriculture.
I'm involved in shipping, so I'll be speaking about shipping. Yeah.
So I just want to make a remark then. I just had a quick calculation based on Mr. Zachariadis' methodology, which is it's not unsubstantiated, but it's, I would say, exaggerated based on, I counted based on the official IEA estimation of coal mine methane emissions, because the coal supply chain also has methane emissions, an estimate of 7% contribution to global warming only from methane in coal. So if we use these numbers and condemn everything in this way, we may end up in a situation where the whole industry will be put against the blame, will be put against accusations, and I think in general we should be a bit, let's say, more consistent in following IMO and UN requirements when calculating emissions. That's the only remark.
Yes, Pano, but remember the well-to-wake concept.
I can reply. I know very well how IMO works and how IMO, when they wanted to set up the well-to-wake carbon factor for LNG, They decided just not on the facts which I presented. They decided on, are we going to kill LNG? If we kill fuels and diesel and we kill LNG, we have nothing. So I'm presenting to you the scientific facts. The regulators and what Mr. Dragaki showed, how nicely you can comply with the regulation by using LNG and all that, is because of what the regulators' carbon factors have put on LNG, not on the real effect and the real carbon factor of LNG. So unfortunately, this is where we live. You wanna live in a dream and continue living on a dream? Right now, the environmental organizations have a new motto. Their new motto is, switching to LNG is worse than doing nothing. But that's not, of course, the motto of the regulators, because you have to have something. But I'm telling you, we are proceeding on the wrong path, in my view, at a huge cost, because there's lots of money involved in all this. But okay, I'll stop here.
My only remark is that let's have the NGOs playing their role, the industry playing its own role, and the IMO or the regulator, whoever this is, it could be the United Nations, for the wider supply chain, let them play their role. If we try to play NGOs, we may be shooting at our feet eventually.
Don't you want to know what the truth is? You wanna just listen to whatever they tell you? Because the truth is that the lesser of all evils is diesel oil. But that's not politically correct right now. That's the truth.
Well, what I can say and this is firmly supported by what we see, is that the dream of the developing countries is to switch from coal to LNG. And this is supported by Qatar Gas ordering more than 100 LNG carriers. So LNG is here to stay and has a very dominant role to play in the decarbonization.
And and remember, Pano, you showed Mr. Trump in your presentation, and he's going to increase LNG export. This is what he's saying. But in any case, I think we have to do something. Now, what is the most proper solution? I don't think that we can discuss it today. Maybe we discuss it after a few years and we appoint Panos as the guru of... Yes. Next question. And I had a number of questions, but I'm not going to ask them. We don't have the time to do it. So on my behalf and on Mr. Kriazis' behalf, we thank the speakers and Mr. Karkanzos especially. Nobody dared to answer your whatever your...
I'm not going to reply to myself. What I forget before to say is that the way for the clever way forward. I have it on.
Okay.
Yeah. Oh, okay. Is technical excellency. Shipping companies must try to be as much as more excellent as they can, and to focus on human element, because digitalization will create many problems in the future. Therefore, they should care for their people and their technical excellence. This is the way forward.
We had a nice presentation in the morning on this. Get in the site and get...
I was absent.
Okay. But you can enter the site and get it.
Okay, I will. Thank you.
So, thank you very much, and we have to give Georgios.
We have one more session to go. Don't go away. And the next session is on the owner's voice regarding, the new regulations and the geopolitical tensions and what effect they will have as a game changer for the industry. So please stay. It will only take, half an hour to finish, and we'll hear some interesting information also.
So we are to start now the last session. I think that will be the most interesting. We do not have presentations in this session. We're going to have only a discussion, and we have with us ship owners that I think that the opinion matters, because it is not just a philosophical position, but it is a position where they're going to put their money and where we're going to see the market coming in the near future. So we have with us Mr. Leonidas Polemis, Chief Executive Officer of Empire Chemical Tankers. Thank you for coming, Mr. Polemis. George Souravlas, Chief Executive Officer of Lodline Marine. Mr. George Savliris, Principal of Savliris Salvage Group. And Mr. George Papagiannopoulos, which is Principal of Common Progress. Thank you very much, all of you, for accepting this invitation and coming with us this afternoon. The subject of our discussion, the topic of our discussion is quite open. We're going to talk about the new regulations, but also about the geopolitical tensions and whether that's going to be a game changer for the future. And I will start with my thoughts when we're talking about geopolitical tensions at the moment, and to make the impact that may have in the shipping. Shipping is related to trading, and now we have actually a trading war between America and China. We have sanctions to Russia. We had sanctions before also in Venezuela, Iran, and some other countries, but not so big countries like Russia. And we have also the tension in the Middle East. All of this, we are expecting that our environment not very favorable for trading and for shipping. I would like to have your opinion whether what we understand is correct, whether you see also a negative impact of all this situation, and how do you think that will be the near future now? Is this something that can be done? Will you change your management style? Are you prepared for take decision and to deal with this matter, or it is something like business as usual? And I would like to start from Mr. Tsavliris, if you don't mind, to hear your opinion about the present situation.
Ladies and gentlemen, first of all, I'd like to thank the organizers for inviting us here today. As usual, I'm impulsive. I never prepare things for panels like this. So what I should start with saying is that, to cut a long story short, is the en ida or the other neither. What we have here is the sudden scenario we had with them. I think we've got to start from a couple of points and try to be as short as possible. The second tenure for Trump has had a tremendous impact on the market. I take the view that may be negative in the first instance because, as you probably know, his whole perception towards the market is he's actually quoted, I quote him, he says that the word tariff, he mentions the most beautiful word in the dictionary. Since we mentioned earlier all the aspects about alternative fuels, and I always, when I see Panos Zachariadis in the room, it always makes a big smile on my face because when he mentions things in his usual controversial way, I mean, I'm in total agreement with him. I'll just make a minor point, is that our first ship, which I ever built, I was 25 years old, back in Brazil. It was consuming 42 tons of fuel, 42 tons. The long-term solution, of course, is to cut the consumption of ships rather than talk about all these alternative fuels, which in my view are somewhat hypocritical, are long-term and won't happen in the next 10 years. So I agree with just one minor point I want to mention from the previous panel is that I agree that fuel is going to be, the fossil fuel will be the fuel of the future. Going back to Trump, what did he mention the other day? Drill, baby, drill. What does that all mean? That basically means that the inference is that the fuel, the way we know it, the fossil fuel, is still the best alternative we have. All we need to do with this, of course, ladies and gentlemen, is let the engine manufacturers progress, let them cut down the fuel consumption of a Panamax, which in 10, 15 years ago would be, 38, 40 tons, and now you can cut down to 16, 18 tons. Go for the second short-term solution, albeit not a permanent solution, short steaming, and that's quoting George Prokopiou, my friend. And those are solutions. So, but in terms of what we see in future, with the fuel aspect, which I had to mention, I think basically what I'm concerned about, and this concerns the newer generation, is that we've got to face the regulators and everybody else and say, look, let's face the music. Let's stop being hypocritical. You know, come up with solutions which are viable, which are doable in the next 10 years. Because coming up with all the alternative fuels, which we mentioned and mentioned in the system, is that all we're doing is that we're generating or we're spending billions of dollars for solutions which aren't going to occur in the next 10 years. Back to the geopolitics, we're going to have problems in the future. I personally think that maybe the only imminent solution which I find on the horizon is perhaps the discontinuation of the Ukrainian-Russian war, and that would be for commercial reasons rather than from a matter of code of ethics. Money runs out, and it's all about, as I say, money talks but wealth whispers. So effectively, I think that's probably going to be the short-term scenario in terms of possibly in the right direction. But in terms of trade and the shipping market in general, we don't know how long is a piece of string. We don't know what Trump is going to do with his tariffs. I've heard figures of up to 10% with the Chinese, 20%, 50%. In fact, I've even heard a situation about the Houthi upheaval in the Red Sea. The Americans aren't actually focused on trying to do something remedial with the confrontation there, because the Houthi disruption in the Red Sea is causing the worst damage to the Far East and in particular the Chinese. So unfortunately here, again, there may be a hidden agenda as to for some reason or the other. Now, I won't go on. I think we'll see what my friends have to say, and then we'll see something else.
Since he mentioned about the fuels and the oil, sustainability of the oil, and we have Mr. Leonidas Polemis with us. You have a long tradition operating tankers. So we would like to hear also your opinion about the general situation and whether you see, at least on the tankers, any impact of the present geopolitical situation.
Sure, thank you. Thank you for inviting me here. It's been a very interesting day. Certainly with Trump coming in as president and saying drill, 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 it seems that he will be producing more oil and gas out of the States than Biden was, and that should be a good thing for shipping, for tanker shipping. But certainly in terms of the tariffs and the situation in terms of the way that Trump is approaching his external politics, it will be that if he applies tariffs, global trade should be affected negatively by that. So containers and dry cargo probably might be affected by that. The tanker market itself has actually dropped since July, and we've had a couple of conversations as well last night about this, but it's not clear exactly what has happened, but certainly the European economies are not doing so well. China is maybe not doing that well, and it seems to be coming through now in the market. In the meantime, the Russian trade seems to have become less, or it seems to be fully covered by what we call the dark fleet. And therefore, it seems that the rates for the ships that are not trading Russia are having fewer cargoes that they can carry. It is in Europe, what we've seen is that the stockpiles have grown over the last 2 months, meaning that the demand for fuels in Europe has reduced or is less than was expected. And it seems that that trend is continuing much further than one would expect. Usually seasonally you would expect going into Christmas that the market for tankers would be much higher or increasing at this stage in November, December, and we're not seeing that. So generally I think that Trump probably will help the tanker market. The situation with the wars is helping the tanker market for the time being, it seems, of course, being that the Houthis are restricting the trade through Suez, which means more ton miles around Africa, and that has increased the ton mile demand for tankers as well as for other ships, but especially for tankers. I think it will be that the level of the tanker market will stay close to where it is today, maybe slightly lower in the coming months. But I think on the long term, I think that the tanker market should improve with Trump's policy. And I think that the only thing that's going to be affecting us now certainly is the number of ships coming in, the new buildings coming into the market in the next 2-3 years.
Thank you. But it is not only the tankers that were affected. Actually, last month we had also the bulkers that we saw different numbers than what we have seen. And if you consider that it is November, expecting that to have the good rates, we don't have them. So what Mr. Papagiannopoulos think about this?
Yes, thank you, Mr. Kourkountis, and thanks to the organizers for inviting us to participate. And having for another year a very interesting summit, which is vital in times like this. So to the subject of new regulations, geopolitical tensions and tariffs, it's a mixed bag, if I'm allowed to say, where we have new regulations and tariffs affecting demand mostly, and geopolitical tensions mostly affecting the supply side of things. The key word in all of this is uncertainty. What is stated and in a political campaign and what is from what is actually being implemented might differ significantly. If tariffs, of course, tariffs significantly affect demand and might we might see a tendency of regionalization and shorter trade routes, whereas new regulations affect the cost of transportation and make transport of goods inflationary to a certain extent, and geopolitics affects supply with longer trading routes, etc. So because all these will come into play, as long as the supply side with new buildings and new orders remains restrained, I'm confident that in the medium term we'll see realignment of stars, and we'll see a healthy, balanced markets ahead. So that's for now.
Thank you. And Mr. Zouravlas, what is your position on all this situation?
Well, one would try to assess the risks in our industry. We know that it is made up of 10 elements. The first element, we have a pretty good idea. We know how many ships there are, how many new buildings will be delivered. The second element, we have a relatively good idea of how things are doing. The third element, we have a mediocre idea. From the fourth to the 10th element, we have absolutely no idea what's going to happen in the geopolitical issues that reflect on our industry. But we can see what we have in our hands right now. We can see that the trade through the Suez Canal and the Red Sea has gone down considerably, has gone down by 61%. We have seen that the earnings of the Suez Canal Authority have gone down by $6 billion. This is a very big number. We have seen that the ton miles in our sector, and I'm talking about handy-sized bulk carriers up to Ultramax, they have gone up by 5.5%. This is a significant number, coupled with a reduction of the average speeds. Now, the average speeds of bulk carriers in those two sectors are below 11 knots, This is the lowest we have seen over the last 5 years. So we're seeing a reduction in speeds, more ton miles. Now, let's see where this industry is going to. We have a lot of unknown parameters. We think that the war between Russia and Ukraine is going to end in 2025. We may consider that there's going to be more grains coming out of the Black Sea as a result of that, and more steels. Having said that, the ports have been destroyed to a great extent, and they have to be rebuilt. The steel mills have been destroyed to a great extent, and they have to be rebuilt. And in general, there's going to be a lot of reconstruction of Ukraine, which is going to take several years to occur. We don't really see that the Houthi effect on the Red Sea is going to cease immediately. We're going to see them being there for the 2025 or even 2026. There is the elephant in the room, in my opinion, is the escalating tensions between China and Taiwan. If this is going, these are going to come to a point where there's going to be a conflict, a lot of things are going to change, and a lot of things is going to greatly affect our industry. If China decides to blockade or attack Taiwan, there are going to be sanctions, and this is going to change in a very wide way the geopolitical balance. As far as we are concerned, we're looking at what we have in our hands right now. And for our sector, we see the ships that are over 20 years old. And in the handysize sector, they're about 13.5%. We're seeing the deliveries of new buildings in the handysize and adjacent sectors that are quite low. They're in the region of about 4%. Our key industry has been killed by over-ordering, and we don't really have this right now. We also see that there is a continuous need of materials, goods to be delivered by the sea route. It has always been, and with the growing population and the higher demand, this is going to keep on going forever. But I think I should put a stop now.
No, okay. But you said actually that Suez Canal traffic reduced, which is something that we noticed. But there is also now the North Sea route that we see that the summertime, especially, we see also ships that are not built are not ice class at all, and they are taking this route, and they started as an experiment maybe 10 years ago with the first LNG, and then the second, and then we had this traffic. Now I see that more ships are taking this traffic, and they're reducing substantially the ton miles that they used to have going down. Do you see any impact from this also? Mr. Polemis, do you believe that will open a new road, or it will remain a niche market?
I think it will remain a niche market for the time being. I think it's got a long way to go before it becomes more mainstream, from what I can see. I mean, I don't know the numbers to tell you of how many ships or how many shipments go through there, but I don't think that's necessarily affecting the market in a big way, but it's certainly something to watch.
Other opinions? Yes, please, Mr. Savlidis.
I think one fundamental thing to look out for, which in fact I'm quite surprised how they haven't, is the security risk, the risk of casualty. I mean, God forbid, imagine a ship going through the North Passage, whatever, a tanker, whatever, which is the biggest polluter, and having a breakdown, crashing into an iceberg or whatever. I mean, it's quite amazing how, with all the security requirements we're all concerned about, as to how they've totally disregarded that. There's nothing up there. If it breaks down, who's going to save it? I mean, how naive can you be? That's what I don't understand sometimes in shipping. We find all these solutions which sound quite adventurous, but on the other hand, I think we always have to have regard to the fact that shipping has always been a risk business, and the main emphasis should not just be on fuel reduction, economies, alternative fuels, but look at the crew and the seafarers who are running these ships. I mean, we go through so many directives with having total disregard about it. Earlier on, Panos Zacharias mentioned about the ammonia saga. I mean, look at the risk factors on crew there. First of all, if you can find any crew who are going to go on board who are specialized enough, but look at the security and the risk factor. The primary concern, and I think it's been totally disregarded, is the welfare and the security and the safety of our crew members. And I think, in fairness, in comparison with the energy and all the hullabaloo we're hearing about all the alternative fuels and the ifs and buts notwithstanding, what about getting the priorities right?
I think that regulators, they have assessed this route, and so far it seems that they agreed, actually. And it is something like a national route, if we are talking about the North. But in general, I will agree that the last years, IMO is more concerned about the environmental issues than the safety on board, because I can tell you that we have still equipment on board which is archaic and a lot of people required for the operation. Mr. Papagiannopoulos, you have something
Yes,
to
thank
add
you.
to Mr. Soulablas?
Upon your comment on the North Sea routes, I mean, the key is that world trade is vital, both for importing economies and exporting. So we're at the tipping point, and we're undergoing a huge change, and maybe trade flows will be affected significantly, but trade, as numbers have shown, has been growing continuously and will continue to grow. And we have to see the impact of the added or reduced ton miles as opposed to the flow of overall cargo.
Mr. Soulablas?
I'd like to say a few things about the decarbonization. At first, we have to take a look at how we run our industry and bring together the various stakeholders, such as ports, cargo interests, charterers, and owners, and try to streamline these operations. We are having vessels running at full speed, arriving to the ports, and waiting for 5, 10, 20 days to discharge their cargo. If the ports and the cargoes were talking to each other, we would have been arriving just in time and not consuming and emitting without any reason. Having said that, we as owners, who don't have the choice of speed that our ships can sail, the charterers order us to proceed with the speed that they think that it is the best. We are trying now to limit the maximum speed in all our vessels, but I think that the ports will start talking to each other and trying to have the ships arriving just in time, not only to pollute less, but to reduce the fouling effect that occurs when ships stay, especially in tropical climates, for a long period at the ports. 5 years ago, nobody was talking about well to wake. Everybody was talking about tank to wake. Even IMO never understood or even thought it was very difficult to conceive the idea of well to wake. The results that have been presented in the previous session show that the misconception that we have had about the various alternative fuels, the ones that we are seeing, so owners or people that decide to order new ships should have this piece of information in mind when choosing the ship that they want to build and invest their money. It's absolutely important to understand the well to wake, and also I heard the words of wisdom by Mr. Zachariadis, and it's very, very important to understand on what happens to methane or hydrogen when it is emitted in the atmosphere. We have to really understand that and then take the right decisions. The stakeholders that take these decisions, they stick with these decisions for many, many years, because an investment in shipping, in a new building, will be for a duration of 25 years, to say the least. So, one has to be very, very careful on the right choice of the propulsion system and the energy-saving devices or carbon capture that may decide to adopt.
So you mentioned something that actually I would like also to discuss. You mentioned about the speed and the importance of the speed, and just before, Mr. Chavlidis said that we should cut the consumption. That will be the first one, and then actually looking about alternative fuels. Whatever is the point of view on this situation, we have a lack of alternative fuels. There is a gap between what we need as alternative fuels, and this gap can be filled in two ways. One is actually to increase the production of the alternative fuels to meet the demand that we need now. But the second one is actually to reduce the demand of the energy that we consume now and to increase also the production. In that way, we will have reduced the gap, and we will reduce also the emissions of the fossil fuels that we're using now. The only proper way to reduce substantially the consumption and to reduce substantially the emissions is to reduce the speed. And actually, 2 years ago, the Korean Register in the technical committee had a very nice presentation demonstrating that even if you have a double number of ships running at half speed, the global emissions will be half of what we have today. So why there is such a big resistance to reduce the speed of the ship if actually we're going to have such a big environmental benefit? We reduce the requirement for the energy, and we reduce the demand for the alternative fuels. Okay, please, Mr. Chavlidis.
Unfortunate question. It's all about making money. They couldn't care two hoots. They couldn't care two hoots. I mean, look, I'm not speaking as a technical guy. I've got a lot of technical people, very technical conversant. One is Panos Zachariadis, Kyriakis Gigoriou has left, Mr. Kokolakis. So in fact, just to make things clear, I'm not a technical guy. I've got the faintest idea about I've got no technical knowledge, but I've got friends who know much more than us, and I digest what they tell us, and especially when they're credible and they know what they're talking about. It's hypocrisy. It's pure hypocrisy. There's a business in this. There's a new business being generated, ladies and gentlemen, the last 10 years. It's the business of unresolved problems. I repeat, the business of unresolved problems. People are making trillions of dollars just by being seen to do their research and development and trying for the new alternative. I'm not saying one shouldn't be progressive. You know, we should always say, you know, as Edward Land said, you never undertake a project in life unless it's manifestly important and nearly impossible. But the point is that even on that scheme, being philosophical about it, you can't build Rome overnight. And at the end of the day, anybody who's got far more knowledge than us in technical aspects, you know, to face the real music, ladies and gentlemen, is we're going to end up in 10, 15 years with nuclear power. Because every other alternative which we heard about, and also, if I make one interruption, look about how these decisions are made. Maersk, I think a couple of years ago, placed an order for some ships, and they had them, the alternative fuel was methanol, methanol green. Parenthesis, methanol green has not yet been produced. Close parenthesis. A couple of years ago, does she know something? Maybe we're too hasty in ordering ships with methanol. We should have gone for ammonia. And they go for another order, having the alternative fuels and ammonia. I mean, how can, ladies and gentlemen, maybe I'm just, maybe my IQ is lower than what it should be, but how can you have a company of the caliber of Maersk, within a period of 5 years, go for an alternative fuel or one batch of ships, and we're not talking about pennies and khanziliki, we're talking about big money, we're talking about $1 billion, okay? To go for the alternative fuel being methanol green, and then saying, we're too hasty, we should have ordered ammonia, and then go and order ammonia alternative. Pesto.
They're going to go LNG finally, because this is where the regulations are pushing them. They're going to go LNG.
They're going to go
finally,
LNG, not ammonia.
because this is the regulations are favoring LNG right now. And I think the discussion we're having about the alternative fuels, all those green fuels, is academic, because like my presentation showed, we're not going to have them. We're not going to have those fuels. The problem is, apart from LNG, they're going to be taxing the liquid fuel so much, we're going to be scrambling for the only other alternative together with airlines, which is biofuels. We're going to be scrambling for that. But there are ways, like Mr. Sourabla said and Mr. Koukoundis said, there are ways to have serious reductions. Like if this just-in-time arrival happened, we're talking 30% reductions from shipping overnight. Somebody has to pressure those ports, okay? And there are ways, I'm a naval architect, there are ways to further reduce substantially the fuel consumption of ships if you make them longer and slimmer, okay? But you have again the ports that are resisting to that. So this is where we're at. Yeah.
I think we opened the floor a little bit earlier than what was predicted. But anyway, since we have questions, yes, please, Mr. Giannoulis.
I appreciate the discussion here, which to me sounds like complaining always. I'm afraid that we are forgetting the elephant in the room. The elephant in the room is that we have to go to zero greenhouse gases in 2050. So if we reduce the speed or we do other things, how do we go towards this direction? So it's very nice talking about they are pushing us to
only
burn
with
LNG.
only with new technology. You cannot
How do
go.
we go there?
You cannot
This
go
is the question.
without new technologies. You can't.
What Panu said before, that the regulations towards LNG. I remind you that 20 years ago, everybody was talking about LNG. Then LNG was to blame because it was not the right decision and was abolished by the European Union. Said that don't talk about LNG. We are not financing LNG projects. Is that true?
True, but they went back. But they went back now.
Panos.
Yeah.
LNG proved to be commercially and technically is the only solution.
Okay.
For 2050, maybe it's not enough. Maybe we have to go for nuclear ship power.
That's what I'm saying. New technologies.
Tell me how we go to 2050 without any technical solution or alternative fuels, like, for example, nuclear energy. I mean, sense and nonsense.
Mr. Sourablas, please.
Okay. I would like to thank Mr. Zachariadis for bringing this subject. We have been building ships to be accommodated inside ports. We are looking at ships that are built for 200 meters and will make a terrible black coefficient because we want to carry as much cargo as possible for a length of 200 meters, for example. The block coefficient is terrible, the efficiency is low. But we have this length constraints, and the naval architect is trying to build the most competitive ship for this specific port length. This length, it is not given by God, but it is given by the port sizes and the allocated space that they have for ships. So if we were able to extend the port discharge or loading facilities, we would be able to make ships that would be more fuel efficient, and this is going to be, we could have fantastic gains in that respect.
You're right. It's an arbitrary decision. It's a decision by the ports. Very few ports really have a length restriction, and that's because of the approaches and the turns. But so they could, if they wanted, they could say, okay, from tomorrow we'll accept 225 meters. They could if they wanted, and that will make a big difference for a Supramax.
We have also from Mr. Polemis, and then from Mr. Papagiannopoulos, comments.
In these circumstances, you have to also be practical. I mean, talking about changing the ports or changing the ship design is a big ask.
I don't think that's necessarily practical, but I think, you know, you have 60,000 or so ships out there. Building prematurely to have dual fuel is, I don't think necessarily is the solution. I like the idea of this scrubber consideration where you can capture the gases, especially carbon dioxide. Of course, there's a whole logistic system that has to go around that, which is still needs to be considered. And energy-saving device, of course, can help a little bit, but I think when you talk about what you can do, and we talked about it before, is the propeller and the engine itself. Whatever you can do in terms of creating more efficiencies first, and then once you reduce the emissions and the consumption, is to capture a big percentage of the emissions that the engine emits. So for me, that's where one can focus, and it's something that's conceivable for owners to invest in. And the whole idea of trying to create hubs for fuels, of alternative fuels, is for me a waste of time, energy and money, and it's distracting the shipping world dramatically in terms of focusing on something that's more practical and something that's achievable by the majority of the ship owners, and that's something that can be done over the next 10 to 20 years, basically. So that's my view as to what is practical for ship owners to do. We tried to order dual fuel ships, and we tried to get a charterer to pay. This is before the market improved 2 years ago. And the charterers were not willing to pay for the extra cost of the dual fuel system. So without the charterers, and of course owners rely on the charterers to pay in order for them to invest. So the charterers are still not sitting at this table and being part of these discussions as you talked about the just-in-time arrival. There needs to be more of that, and there certainly needs to be a more practical approach. That's my view.
And Mr. Papagiannopoulos?
Yes, following on from Mr. Polemis' comment, I mean, the key word is pragmatism. I mean, we might sound as if we're complaining, but we're complaining for a reason, because we're part of the market and part of the industry, in the sense that the numbers prove it. The world fleet is around 2.5 billion tons, and the shipbuilding capacity annually is around 90 million tons. So if we look at the numbers today, in order to replace the existing fleet with the alternative fuel fleet, in order to reach the 2050 target, it's almost impossible with what we have in hand today. If situation changes dramatically, then that's a different story. But certain aspects are not realistically feasible.
Thank you. Just, yes, Mr. Kerkachos.
Just a remark in general. Let's look at the situation in a more broad way. If you look at the financial markets, at the financial industry, there are trillions that are played, just to play between the players. So the same thing happens here in shipping. The regulators, the others, there is a total grid of interests here, which is in play. So we have to take that in mind. To be realistic, we have to account for that. Otherwise, we can't. So, all in all, we must encapsulate, embrace all the influences, all the players here, and then try to find a practical solution.
Thank you. I will take the opportunity, actually, before we go on with some other questions. We discussed also the option for nuclear. And we should consider that when we are talking about decarbonization, The reason that we don't want to have the CO2 is to have a better environment. So I doubt that if we replace CO2 on the Earth with the nuclear wastage, we go for a better environment. We should consider that when we had the first internal combustion engine, nobody was thinking that the CO2 will be a problem. 50 years ago, 100 years ago, we see that it should be the end. And of course, the CO2 can disappear within a few years if we stop today. But with nuclear wastage, the situation will be different. You know that the pollution is something that has no way of return. And you know that even a fist of nuclear wastage can pollute the whole Mediterranean. So I will be very careful when we are talking about environmental regulations and we pick up as a solution to get rid of the CO2 and take in the nuclear. So that's just a comment. Now, going back to the geopolitics, we have also the Iranian sanctions. And I don't know if that will be continued or if there is any input from you regarding this situation.
Yes, Mr. Chairman. Well, look, my personal view is that, first of all, you've got to start from the basics. For some reason, the Iranian sanctions were imposed on by the Americans. For some reason, even though the Americans could be fairly particular and quite dynamic in applying or pushing to comply with the regulations, with the Iranian sanctions, they're kind of turning, in my personal view, they're turning a blind eye. We have the mystical grey fleet, whatever you want to call it, or secret fleet, or whatever the terminology is being used these days. It's quite fashionable. Oil has been exported in massive quantities. It may be less than what they would have wanted to do, but it's been imported in massive quantities. Now, the question here again, without going through a conspiracy theory, but just asking a question. Why would the Americans not impose their sanctions so vigorously? In my view, the answer is very simple. To keep the price of oil low and give them back to money again. Because if they impose the regulators and the sanctions on the Iranian oil, and they stop the trading oil, what would happen at the end of the day? The price of the oil will go up from, what, $80, $90 to maybe a couple of hundred and God knows where. So at the end of the day, again, ladies and gentlemen, and I don't want to go on about this, but maybe I'm too controversial about it, or maybe too rational, too passionate about it. We've got to try to diffuse the situation of hypocrisy and the hidden agendas and just speak the truth, because otherwise you're not going to solve the problem. It's like going to a doctor and not telling where you hurt. I mean, how's he going to solve the problem? Now, sanctions, again, it also creates something even worse than that. It creates instability, it creates lack of integrity, and at the end of the day, people in this world want to be confident that the people who are administering or running or governing countries, they want to be inspired by their confidence and their sincerity. Now, how can you do that when we know the Iranian oil, and correct me if I'm wrong, is being traded like as if there's no issue at all? They're finding all ways of getting into China through all kinds of alternatives, and the reason being is because, again, the Americans are not doing or applying the sanctions because they don't want to keep the price of oil down. Would anybody take a view on that? Am I wrong?
You have to ask the floor, actually. I think that we're going to have a few more questions from the floor, and then I think we have concluded. Do we have some other questions from the people here? Yes, please.
Has anybody considered the idea of applying car practices to shipping, like building hybrid ships? My point is that we do not know what the regulations will hold for us in the years to come. The possibility that we can predict now what the fuel of the future will be are rather slim and depend on politics that we're under no control of performing that. So my idea is that if we can build ships that are hybrid ships and electrically powered, and for the time being we have, let's say, diesel generators powering the ships and providing electricity for the propellers to turn, then at any moment later in time we can change whatever produces this electrical power and still have a new ship. Thank you.
Yeah, can I answer?
We are already building hybrid ships. You know, many ships now have batteries, and there are ships with 5 megawatt batteries installed, which allow them to operate in ports without any engine running. So this is not an issue. But of course, we cannot really power a vessel with batteries going from China to Europe.
Power batteries have generating capacity with normal fuel or any alternative fuel.
Yeah.
Like you said, it already exists. This goes back into we need new technologies. It's not only nuclear. We need better batteries, because the ones we have now are extremely heavy and they cannot hold too much charge. So when we have better batteries, then we can really have hybrid ships.
I will ask now our panelists to have...
Sorry, the point is that we do not have time. We have been talking about these things for so long,
this is true, because
and we do not have time.
5 more minutes is enough. Anyway. Okay, then starting from Mr. Souravlas, then Mr. Papagiannopoulos, Mr. Tsavliris, and Mr. Polemis, our panelists, let's have last few words and think about your position, whether, take it as a question, what do you predict that Trump will be for shipping? That it will be something positive or something negative at the end of his career as president? Let's start with Mr.
Okay, we're in shipping, so we always have to be positive. And I have to start with a positive note. In fact, dry bulk has not been influenced so much by United States. We do more trades with Southeast Asia than with United States. Perhaps this is known, but if it isn't, United States exports 20 times more bulk cargoes to China. This is, on the bulk cargoes front. United States is the real exporter to China. If this is going to cease because United States will put tariffs on Chinese manufactured goods, then this trade will have to go to other countries, for example, Brazil, and in this way, the ton miles will increase. They will go up. So this is one side of this. Now, the second is that Mr. Trump likes coal and he likes drilling. So we think that the coal exports from United States are going to go up. This is, something that we are saying, we have seen in his previous administration. And the third thing is that if the war between Russia and Ukraine is going to come to an end, we're going to see a reconstruction of Ukraine, and this is going to be, of course, a lot of materials that's going to go into the Black Sea for that purpose. So this could be good news. In my opinion, it's going to be more bad news for Europe if there's going to be, in China, if there's going to be more cargoes or more tariffs on on the cargoes originating from Europe and China. This is mostly for the container side, but we also on the dry bulk side do a lot of steel transportation, which in our opinion is going to go down. Manufactured steel from China, for example.
So if I was to make a prediction, I would say that in the short term, the new U.S. Government will be negative, but this will cause restraint in the ordering of new ships. So in the medium term, it will be a net positive. But regardless, I believe that Greek shipping has proven to be resilient and flexible and adaptable. So I think we'll do well.
Ladies?
Double-edged knife. We've seen Trump in the previous his tenure, and right now, I wouldn't call him a chameleon, but he's unpredictable. And but I'm just hoping that perhaps he's built up a lot of scar tissue over the period, especially even in the interim period where he wasn't president. So I'm just hoping, being a typical passionate and romantic Greek, I'm looking at the glass being half full rather than half empty. But in terms of having any predicament or any objective factors to pass judgment or take an opinion, I regret to say that I haven't got one. I'm just saying, God help us. Thank you.
Here, George. We agree. Certainly, he's very unpredictable. But as I said before, I think that certainly LNG exports from the States will increase, and probably in the long term, it will take time. It's not going to happen overnight. And for crude oil and products, it will flow into Europe to replace Russian barrels. So I think that a net positive effect, but it will take time. It wouldn't happen. It won't be something overnight. In terms of, you mentioned nuclear power, I do think that's a silver bullet for shipping in terms of a solution. But there's a long way to go for that, I'm sure.
Well, I have to thank you very much. I have to thank Mr. Polemis, Mr. Tsavliris, Mr. Papagiannopoulos, Mr. Souravlas, and the nice audience. So we have finished also with this session. So Mr. Kriezis.
Thank you, everybody, for attending and staying up late. I would like to summarize what we heard today. First, we heard from Mr. Xilas on the outlook of shipping and efforts to do the decarbonization of shipping. Then we heard of the efforts from Onyx and Skaramangas to revive the Greek shipbuilding industry. And we had 3 panels, and through these panels, we heard a lot of things about LNG systems, energy-saving devices, propeller retrofits, the midterm measures that are proposed by IMO, electric ship propulsion, turbocharger replacement, digitalization in shipping, silicone coatings and hard coatings and how these affect the efficiency of the vessels. And then we heard about the alternative fuels, biofuels, ammonia, green fuels or not. And finally, we had this very nice discussion on the geopolitical influences of the decarbonization and worldwide conflicts and results. And before finishing, I would like to repeat the announcement that the next Green Shipping Summit, New Technologies and Education, will be held at the Eugenides Foundation on April 1st, 2025. And then we will have another repeat of Greener Shipping Summit in November, and then again at Eugenides Foundation on November 11th, 2025. So this will be, repeat efforts and to inform the Greek shipping market. Thank you very much for attending and for all the nice questions.